So you already know that functions are one of the most fundamental building blocks of any JavaScript program. And so let's now turn our attention back to functions, because there's actually a lot that we don't know yet about functions. So in this section, we're gonna study some quite advanced topics, such as higher order functions, the bind method, and also closures. And once again, it's crucial that you understand these topics before moving on to future sections. So make sure to follow this one all the way to the end. Let's start this section about functions with one of the easiest parts, which is default parameters. And a new section means new starter files. So as always, get yours from the GitHub repository and then open them up in your VS Code. So as always, we already start with strict mode here. But now let's talk about default parameters. So sometimes it's useful to have functions where some parameters are set by default. This way, we do not have to pass them in manually in case we don't want to change the default. Now in this section, we're going to continue with the airline theme that we started by the end of the last section. And so let's now create a very basic booking function. And we're going to do that starting with the knowledge that we already had previously. So without the default parameters first. So just a normal function. And into this function, we need to pass in the flight number, the number of passengers, and the price. And then let's simply use this data to create an object and push that into some bookings array. So booking. And now here we can use the enhanced object literal syntax that we learned about in the previous section. So we can now create an object with a flight num property without having to do this. Remember? So we simply define a variable here, and that will then create a property with this name and also the value that's in the variable. And then let's just log it to console. And then let's just create an array out here which will contain these bookings. So we start empty here, and then we simply push them each time there is a booking. So basically for the airline to keep the bookings in some kind of system. And this is all very fictional. It's just to show you the default parameters in this case. And speaking of that, based on what we learned in the last section about short circuiting, how would we implement default parameters? Well, let's start by calling this function without specifying some parameters and see what we get then. So create booking, and now with just a flight number, let's say LH123. And now we need a new terminal as always. So again, I hit tab here to autocomplete the operation. And indeed, here is our browser with our page already running. Now here's some kind of problem. Oh, and that's because we called this booking here the same as the array. And so here it is then trying to push this object into itself, basically. So we need to create bookings here, giving it a new name. And so indeed, now we get here the result of this object. And now it works, and here we see the result of this booking object. And so what we wanted to see here was that the num passengers and the price are set to undefined because we didn't specify them. And so now we can use short circuiting to our advantage because we know that these are falsy values. Okay? And what I'm doing here is basically the old way of setting default parameters, just to remember how it would work before ES6. So let's say I wanted to set the number of passengers to 1 by default. So basically, we would reassign this parameter like this. So num_passengers is num_passengers or 1, which is the default value. And this works because of the reasons that we learned in the last section, which is that whenever this is a falsy value, which undefined is, then the result of the OR operator here will be this second operand. So this value here, in this case, 1. And now we can do the same thing with the price. Let's say 199 is the default price. And so if we reload this now, then indeed we get our default values here. Okay, so coming from this part of the code. However, this is a lot of ugly boilerplate code. And again, this is the ES5 way of doing it. So I will take this out. Let me actually write ES5 here, because now in ES6 there is a better way. So all we have to do is to write this equals 1. And so now this here will be the default value. And the same for the price. Let's say it to 199. And now if we reload, then we get the same result here. And this here, of course, looks a lot nicer and is a lot more intuitive to read. Now, of course, we can override these defaults. Otherwise, this wouldn't make much sense. So let's try H123. And now for 2 passengers and let's say 800. And now, of course, these values are the ones that we specified here instead of the default values. Now, one thing that's really cool about the default values is that they can contain any expression. For example, we could do times 1.2, for example, then we would get this here. Okay, but what's even more useful is that we can actually use the values of the other parameters that were set before it. So here we can now say that the price should be calculated based on a number of passengers. All right. So if we now do this, create booking again, just some random flight number here. Let's say again 2, but then with 5, we will get another value. So indeed, you see 398. So the number continues down here, and then 995. And so the price is now dynamically calculated by default based on this value we specified and the number of passengers. And again, this only works for parameters that are defined in the list before this one. So this would not work because JavaScript basically specifies these parameters in orders, and as it reaches, so right now, as it reaches the price, it doesn't know about the number of passengers yet. And so that wouldn't work. Now, another thing that's important to note here is that we cannot skip arguments here when we call the function. So for example, let's say we wanted to leave the number of passengers as the default value, but then specify the price. So we cannot do this. So skipping the number of passengers now, and then only specifying a new price. So if we do this, then of course, the number of passengers becomes 1,000. Because the second argument here will always be mapped to the second parameter. So if we wanted to leave this one here at a default, there is a nice trick. So the number of passengers we can simply set to undefined. All right, and this works again because setting the parameter to undefined is the same thing as not even setting it. Remember, so when we don't set a parameter, so when we don't pass an argument into that parameter, then it will take the value of undefined. And so specifying undefined here is exactly the same. And so this is how we basically skip a default parameter that we want to leave at its default. And so now as I reload it here, you see that the number of passengers is still 1, and indeed the price is now 1,000. Okay, so yet another very nice addition to the language in ES6 here. and pretty straightforward to understand too. So see you in the next video. In this lecture, I want to quickly talk about how exactly it works to pass arguments into functions. And this goes back to the video that we had about primitives versus objects, which, remember, we also call primitive types and reference types. So this is kind of a review of that lecture, but applied to functions, because it's super important that we really understand how primitives and objects work in the context of functions. And so let's draw up a quick and simple example here. So let's set a flight number here, 234, and an object, which is basically a passenger, which in this case is me. So name, Jonas Schmettmann, and then some random passport number. So let's say just this. And by the way, I could have all of this code here as boilerplate already, so in the starter files, but I strongly believe that it's better to write the code here in the video, because then you are forced to write the code yourself, and second, it makes the examples a lot easier to understand. Anyway, I now want to create a check-in function. So basically when the passenger has already bought the flight and is then ready to check in to take the flight, and then let's say there we need a flight number and then also a passenger object, which contains data about the passenger itself. So basically we would call this function like this. So with the flight that we already have up here and the Jonas object in this case. All right. So this is our flight LH234, and this is our passenger. But now let's say that the number of the flight was changed. And so that can happen in the check-in function. And so let's now change that flight num parameter here. And this is usually not a good practice to do, so you should not change the parameters of a function, but this is just to make a point. So let's say for some reason the number now changed to LH999. And I will also change the name of the passenger. And that's because in aviation, usually they always add a Mr. or a Mrs. In front of the name. Okay. So let's do that. Mr. and then just the name of the passenger. So these are some changes that the check-in function does. And then before we check in, it will just check if the passport number is correct. So let's say if passenger.passport is equal to this one, and let's suppose that this function gets this data from some database which contains the booked flights, right? Then in this case, if the passport is correct, then let's alert check in, and else alert wrong passport. Okay, and this part here will make a little bit more sense by the end of the lecture. Okay, and now what I want to do is to log both the flight and the Jonas object to the console after calling this check-in function. So flight and Jonas. Okay, and now as I save this, what do you think is going to happen to these two variables here? Can you try to anticipate it based on the code that we have here? So anyway, let's see now. And here we get checked in, which for now isn't really important. But then what we get is the flight number, which is still LH234. So exactly as we defined it here, even though it seems like it was redefined here. So it really wasn't. And then we also get the Jonas object But now the name is indeed changed to Mr. Jonas Schmedman. And so that's this change here that happened inside of the function, right? So maybe you actually saw this result coming because we actually have seen this happening sometimes before. But let's anyway analyze it. So this flight here is a primitive type, right? It's just a string. And as we passed that value into the function down here, then the flight number here is basically a copy of that original value, right? So flight number contains a copy and not simply the original value of the flight variable. So this would be exactly the same as writing flight number equals flight. And this would then also simply copy this value to flight num, right? And so again, flight num here is a completely different variable. And therefore, as we changed it here, it did not get reflected in the outside flight variable. Okay, and so it's still LH234. So exactly for the same reason as we saw before in the primitives versus reference types lecture. But now what about the Jonas object that we passed into the check-in function? And in that function it is called passenger, right? And then we changed that passenger object here, and as we saw then, the Jonas object was also affected by that change. So why did that happen? And you might already know the answer. So when we pass a reference type to a function, what is copied is really just the reference to the object in the memory heap. So that would be exactly like doing this. So passenger equals Jonas. And we can actually do this. And here the same, just to get as a reference, same as doing, okay? And so as you already know, when we try to copy an object like this, we are really only copying the reference to that object in the memory heap, but they both point to the same object in memory. And so that's exactly what is also happening here with the Jonas object as we pass it into the check-in function where it's called passenger. So here, as we are manipulating the passenger object, it is exactly the same as manipulating the Jonas object. Once again, because they both are the same object in the memory heap. All right. So in summary, passing a primitive type to a function is really just the same as creating a copy like this outside of the function. So the value is simply copied. On the other hand, when we pass an object to a function, it is really just like copying an object like this. And so whatever we change in a copy will also happen in the original. Now, of course, we need to be careful with this behavior and always keep it in mind. That's because the fact that objects behave this way when passed to functions can have unforeseeable consequences in large code bases. And that's especially true when you're working with multiple developers. So let's write another quick function here to show you what can happen so that you can be prepared for the real life, basically. So let's just create a function called new passport. It will accept any person, and basically it will simply change that person's passport number. And so let's simply create a random number here, random, and let's multiply it by some huge number, and then this will create a number between 1 and this huge thing. So it doesn't really matter here. We will also now trunc as we have used before, just so that we get a new big number, which will be the new passport. All right. And so now let's call that function actually with the Jonas object. All right. So let's say that I booked the flight with my original passport number here. And so that's the passport number that the check-in function will then compare my passport to. That's why it's hard-coded right here. But now, again, I change my passport before I check in. And so let's see what happens then. So here again, we need to pass in the flight and the passenger object. So let's see. So it still says checked in here, but that's coming from this check-in function call. Okay. So then down here, the password is changed, and then there's another check-in call. So let's see the result of that. And so now indeed it says wrong passport. All right. And so what's happening now is that we have two functions manipulating the same object. And so that is creating a problem. Right? So here the exact same thing is happening in the new passport function. I'm passing in an object, and so that object here is then called person, and as the function manipulates that person object, of course it also gets reflected in Jonas. And then as we pass that Jonas object into the check-in function, then of course that passport is no longer the same as the original one. So yeah, I think this is a nice example of seeing how the interaction of different functions with the same object can create some issues here. And of course, this is just a super simple example, but I'm sure you get the point, right? What matters is that you're aware of this issue and then you can be careful with it. Let's just take out these lines of code. Also these don't really matter. Let's just make sure. And indeed, yeah, we get the wrong passport now because of the new passport function down there. Okay, now just to finish, in programming, there are two terms that are used all the time when dealing with functions, which is passing by value and passing by reference. And many experienced programmers that are new to JavaScript have some confusion between these terms and how it works in JavaScript. And so I want to quickly address that here as well. So JavaScript does not have passing by reference, only passing by value, even though it looks like it's passing by reference. So there are languages like C++ where you can pass a reference to any value instead of the value itself. This works even with primitives, so you could pass a reference to the value 5, and then the original value outside of the function would be changed. And this is called pass by reference. But once again, JavaScript does not have pass by reference. So if you already know some programming but are new to JavaScript, be sure to understand this. And I know it's confusing because, as we just learned, for objects, we do in fact pass in a reference. So the memory address of the object. However, that reference itself is still a value. It's simply a value that contains a memory address. So basically, we pass a reference to the function, but we do not pass by reference. And this is an important distinction. And once again, I'm only telling you this because there seems to be a lot of confusion going on about this topic among some JavaScript beginners, and especially when they come from other languages such as C++. Let's now talk about a fundamental property of the JavaScript language, which is the fact that it has first-class functions. This enables us to write higher-order functions. But what's that all about? Well, let's see. So JavaScript is a language that has first-class functions, which in technical terms means that functions are so-called first citizens. In practice, that means that functions are simply treated as values. And we already touched on that idea a couple of times before, but this is such an important feature of the language that it's worth spending some more time talking about this. Now, why does JavaScript work this way? Well, it's simply because functions are really just another type of objects in JavaScript. And since objects are values, functions are values too. And since functions are values, there is a bunch of interesting things that we can do with them, like storing them in variables or object properties. And that, of course, we already did a couple of times before. So the function values here are marked in red, and then you see we create a function expression in the first example and an object method in the second example. So the value in the red rectangle is the function value itself that we can store wherever we like. We can also pass functions as arguments to other functions. And we actually already did that before when adding event listeners or event handlers to DOM objects. So here we have the addEventListener function that you already know, and we clearly pass the greet function into the addEventListener function here as a value, right? Now, to make it even more interesting, we can also return a function from another function. That sounds kind of crazy, but it can be very useful. Finally, remember that functions are objects. And many types of objects in JavaScript have methods, right? Like array methods, for example. And actually, there are also function methods, so methods that we can call on functions. So again, that sounds a bit crazy, right? But we will see how to use this to our advantage throughout this section. This bind method here is an example of that. And again, we will learn about the bind method as we go through the section. All right. Now, the fact that JavaScript has first-class functions makes it possible for us to use and write higher-order functions. So, a higher-order function is either a function that receives another function as an argument or a function that returns a new function. So let's check out both types here. First, for functions that receive another function, we have this same example as before. So here, the addEventListener function is the higher order function. And why? Well, because it receives another function as an input. In this case, the greet function. And we usually say that the function that is passed in is a callback function. That's because the callback function will be called later by the higher order function. In this case, addEventListener will call the greet callback later, as soon as the click event happens. It's like the greet function saying, hey there, don't greet me yet, but call me back once you're ready. And this works not only in the context of the addEventListener function, but in many other use cases as well. Okay, second, we can also have functions that return another function. So we have the higher order function here, so basically this whole code block, which clearly returns a new function, which is this one. And this style of functions is also used a lot in JavaScript, but it's also more advanced and I guess harder to understand. I will show it to you in the next lecture, but we will explore this deeper a bit later. Now, just to finish, there seems to be some confusion between first-class functions and higher-order functions. Some people think that they are the same thing, but actually they mean different things. So first-class functions is just a feature that a programming language either has or does not have. All it means is that all functions are values. That's it. There are no first-class functions in practice, okay? It's just a concept. There are, however, higher-order functions in practice, which are possible because the language supports first-class functions. So it's a subtle difference, but still worth noting if you want to be able to talk like a true JavaScript master. Great. Now in the next lecture, let's actually create our own higher-order functions. Now that we know what higher-order functions are, let's actually create our own, just to demonstrate how they work. So in this lecture, we're going to create a function that accepts other functions as an input. But to start, let's write two very generic functions that do simple string transformations. So one I'm going to call oneWord, and this will simply replace all the spaces in a word. So string dot replace, and then we're going to select all the spaces. And remember, for that, we need to use this regular expression with the G flag and then replace them with simply an empty string. And then we also convert that to a lowercase. Okay? So this function here would simply work anywhere in our code with any string. And it takes in one string and returns a new one without any spaces in it. Okay, let's create another one, upper first word, which also takes in a string. And so these two functions, they will later be the functions that we pass into another function. Okay, so we first need these. So as the name says, this function here will simply transform the first word of the input string to uppercase. So let's just first split the string, so by the empty string, and then we will take the result and destructure it into the first word and then all the other words, and then return a new array that we will join. So that's first to uppercase. And here I'm not explaining exactly how this all works because we already talked about this stuff in the last video. So we spread the others then also in the array, and then we join. And so you see that everything that we learned before is actually pretty helpful. Again, as always, especially helpful is the spread operator and the destructuring assignment, like we use it here. Right? And here it's actually the rest pattern. All right. So we have these two generic functions, and now we can create our higher order function. And that function will be called a transformer. And this function will take in also a string, but as a second argument, it will take in a function. Okay? And therefore, this is a higher order function. So that's the definition that we learned about in the last video. So it takes in a function, and therefore it is a higher order function. And so now let's see how we would actually call this function. So that's how I like to do it many times. So let's say JavaScript is the best. And as a second argument, I will now pass in the upper first word function. And so basically what I want the transformer function now to do with this string is to transform the string using this function here. So this function that we created here in the beginning. All right. And once again, notice how we are only passing in the function value itself. So really just the value. We are not calling this function here. Okay. We are only passing it in, and it will be the transformer function calling this function. So let's actually do that. So we will simply log to the console transformed string, and then here goes our expression. And so this is where we will now call the function. Now inside of the transformer function, this upper word is now called fn, right? So that's the second parameter here. And so fn, and then with the passed in string. Okay. And when we see the result, this will make even more sense. Okay. Let's also log to the console the original string. And so that's just str. Okay. And I also want to show you something else. So let's log transformed by. And in the last video, I told you that functions even have methods, remember? And besides methods, functions can even have properties. And one of them is the name property. So again, we take fn, which is the function that this higher order transformer gets as an input. And then on that, we can read the name property. And so now let's see the result of this operation. And so let's take a look at our interesting output. So of course the original string looks familiar, but then the transformed string indeed was transformed just as we hoped it would. So the first word is now uppercase. And so that is, of course, the work of this function here. Finally, we can also see that it was transformed by upper first word. And so that's fn.name. So as the property says, it is really just the name of the function. And so this one here we can actually use on any function that we have in JavaScript. And now let's try the same here with our other function. So one word, and let's see the result. Let's give it some more space here. And so here is the second output. So the transformed string is now this one here, all in one word, and indeed it was transformed by the one word function. So this one here, right? So let's recap. We're calling the transformer function here, and into that function we are passing the callback function. And remember that we call these functions that we pass, so this one and this one, the callback functions. And that's because we do not call them ourselves, but instead we call JavaScript to basically tell them later. And in this case, calling them later happens right here. So it's the transformer function that will call these callback functions. And the callback functions in here are, of course, called fn. And so that's the name of the function in here that we then have to call. All right. And in fact, this is exactly the same idea that we already talked about using the addEventListener function, right? So let's say we had this very simple function, high5, which doesn't really do much except of logging something to the console. Let's just put an emoji here, this waving one. And so now let's say document.body.end event listener click, and then this function. So never mind about this part here. We're going to learn later what this means. But what matters is the addEventListener. And so just like our transformer function, we pass in a callback function. Okay? And this callback function in this case is also called the event handler or the event listener, but that doesn't really matter. What matters is that conceptually, this here is the callback function, and this is the higher order function. So this one is just like our transformer function, and this one is just like the one word or upper first word. Okay, so it's just a callback function that JavaScript will call as soon as we click on the body. So you see, down there now, they appear. And so only then the callback is really called. And there are many, many other examples in the JavaScript language. And this concept of callback functions is used all the time in built-in JavaScript functions. So there are many, many more examples. For example, the forEach function that we call on arrays. So let's create an array here, Jonas, Martha, and Adam. And on that array, we can call something called the forEach method. And we will learn about this one in the next section, actually. And then again, we pass in a callback function into forEach. So let's again use high5. And so as I reload this now, then we get here these three wavings, okay? And that's because we have three elements in this array. And so as the name of the method says, for each of them, this callback will be called. And therefore, we have three wavings here. But we will learn all about the forEach method in the next section. What matters here is that once again, we use the concept of the callback function here. And so this is something really common in JavaScript. Let me just write that here. Callbacks all the time. And so let's now actually take a minute or two to understand why that is. Why are callback functions so much used in JavaScript, and why are they so helpful? Well, the first big advantage of this is that it makes it easy to split up our code into more reusable and interconnected parts. So that's exactly what we have here, right? We have all of this functionality here nicely split up into their own functions, and that itself is really helpful. But there is a second and way more important advantage, which is the fact that callback functions allow us to create abstraction. So let me explain what that means. So what we did here in our code example was to create a level of abstraction. And abstraction is something really important in programming. So basically what abstraction means is that we hide the detail of some code implementation because we don't really care about all that detail. And this allows us to think about problems at a higher, more abstract level. And so that's why it's called an abstraction. So coming back to our example here, this transformer function does not care at all how the string is transformed. It doesn't care about this level of detail, okay? All it wants to do is to transform a string, but it doesn't care how it should do it. So what I mean is that we could have taken this code here and written it directly into transformer, or even this code here, right? That would have worked just the same. But instead, we abstracted this code away into other functions. So again, we created a new level of abstraction. And by doing this, our main transformer function here is really only concerned with transforming the input string itself. But no matter how that transforming itself actually works. So it's basically delegating the string transformation to the other lower level functions, which are these two. Okay? And I hope this makes sense for you. But we will also come back to this idea of abstraction later when we talk about object-oriented programming. But it's good for you to think and talk about this stuff as soon as possible so that you can start to get an idea for this really important concept of abstraction. And now with this idea of abstraction and higher levels and lower levels of abstraction, it makes sense that this kind of function here is called a higher order function, right? And again, that's basically because this function here operates at a higher level of abstraction, leaving the low level details to this low level functions. Okay? Now, they're not really called low order or low level functions, but that's just how I like to call them in this circumstance. All right. So understanding this is absolutely crucial for your process. And I actually consider this one of the most important lectures here of the course, because callback functions are really a vital part of the JavaScript language. And that's one of the main takeaways from this video. They allow us to create this kind of logic here. And so I think it's probably a good idea that you really review this really well and maybe even write your own example of something that you see in the real world using the same concept. Okay, I think that's a really good idea that you should try out. Then here in the built-in functions like add-event-listener and forEach, these callback functions are so important and so useful because we use them to tell these functions what exactly they should do. For example, the add-event-listener function on its own would have no idea of what to do whenever the click event happens here, right? And so that's why we pass in the callback function here to tell the add-event-listener function exactly what to do. And as you already know, this is the higher order function here with the high level of abstraction, and this here is the function with the more lower level of abstraction. All right, but enough talk. Please take a minute to really review this lecture and build an example of your own maybe. And then I see you in the next video where we will basically do the opposite of this one. So having functions return other functions. Let's now do the opposite of the last lecture and create a function that returns a new function. So I'm going to write a very simple greet function here, because this is really just to demonstrate this point here as easily as possible. So here we can pass in a greeting like hi or hello or something like that. And then all this function will do is to return a new function. So as always, we write return and then simply a new function value. And this new function that we return will also have a parameter. So it will be able to receive arguments, right? And so what this function here will do is it will simply log to the console basically the greeting and then the name of the person that we passed into this function. So let's just write this and it will make sense when we see this in action. I'm sure it looks a bit weird right now. And now let's actually use the greet function. So let's say greet with hey. And so hey is the greeting here. Now, what will be the result of this function call? Well, it's going to be this function, right? And so let's store the result of this function call, which will be, as we just said, that function. I'm going to call this one greeter hey. So this value here now is actually now a function, okay? And essentially it is this function. So what this means is that we can now call this greeter function just as if it was any other function that we defined ourselves. So let's say greeter hey, Jonas, and let's call it another time greeter hey, Stephen. And now I'm going to run it, and indeed we get hey Jonas and hey Stephen. And so this worked again because this greeter hey is essentially this. And so now we're calling it with the argument of Jonas. And so this name here is then, of course, this name that we specified here. Now the greeting is still coming from this greet function here. And in case you're wondering why that actually works, it is because of something called a closure. Now closures are a very complex and difficult to understand mechanism that's part of JavaScript. And so there are two separate videos at the end of this section about closures. So closures is one of the most misunderstood topics in JavaScript. So don't worry about that now. What matters here is that our first function, greet, returned a new function that we stored into this variable. And so this variable is now just a function that we can call, as we did here, again using the parenthesis syntax. And of course, we could also do it all in one go. So we can again call greet. Let's say hello now. And so again, this here is now a function. Okay, so if this is a function, we can immediately call it, right? And so we call like this, and then we pass in the name, which is the argument of this function here, right? And so even though this looks a bit weird, it is going to work. And so we get hello Jonas now. All right. And now this example might look a bit weird and unnecessary for you. Like, what's the point of having functions returning other functions? Well, this will actually become extremely useful in some situations. And especially if we're using a really important programming paradigm called functional programming. And I think I've mentioned it sometimes throughout the course. And we're actually going to look at functional programming by the end of the course. Maybe not by the time I first publish the course, but certainly some point later. Anyway, make sure to understand this here, and especially this line of code. And if you understand this, then I'm sure you understood everything what happened here. Now, just as a small challenge to finish here, try to rewrite this function here using only arrow functions. And believe me, that's going to look a little bit confusing, but I'm sure you can do it. So just take some time and try to rewrite that greet function using arrow functions. And I see you here in a minute. Okay, so let's see how it's done. So greet, just going to call it R. So this one takes, again, greeting as an argument, and it returns a new function. So this means that it only has one line of code which returns something. So all we need is this arrow, and then we don't even need the curly braces, and we don't need the return statement. So what are we going to return from here? A new function. So again, an arrow function, and so another arrow here. And then simply this. Let's give it a save and a try. So greet, err, and let's use hi this time. And yeah, we get hi Jonas. Okay, so this is an even shorter way of writing the same function, but in my opinion, it's actually a lot more confusing. And that's why I wrote it using this more traditional way here. But in the end, it's also simply one arrow function returning another arrow function. And so that's the essence of this video, which I hope was clear to you. And if so, then let's move on right to the next one. In this lecture, we're going to go back to the this keyword and learn how we can set the this keyword manually, and also why we would want to do that. So let's say we are an airline again, and in this case, Lufthansa, which is the biggest European airline group, by the way. And so let's create a very simple object for this airline with a very simple booking method as well. So we have the airline name, we have the code, basically. We also want to keep an array of bookings, so also inside of the object, and then the book method. And remember from the previous section, I will now start using the way of writing methods using the enhanced object literal syntax. And so that's simply by defining the method like this without having to write function. So remember, before this, we used to do this, right? And if you still prefer this syntax, you can still do this one, but I do actually prefer the new syntax. And so I will just start using this one now. So the flight number and also the passenger name here. So then let's log something to the console. And again, this could have been boilerplate code here, but it's also good to practice writing this. So this should be a template string, booked a seat on. So basically we want to print like Jonas booked a seat on Lufthansa flight and then the flight number. And so here we are now going to get the airline name from the object. And so we already learned that for that we use the this keyword, right? And then flight this dot IATA code. So that's going to be the LH and then the flight number itself that we pass into the function. So the flight number. So for now, this is just a nice review of how the this keyword works, right? And of course, I will now assume that you know how all of this works, because otherwise I will have to explain the same things over and over again. And so, as I mentioned before, you should only progress once you really understand a certain topic. Anyway, let's now use the book function here. And I will use the flight number 239, and then with my own name. And let's right away book another Lufthansa flight for, let's say, Mike Smith on flight number 635. John Smith. And now if we take a look at the results, then indeed, everything works just as expected, right? And so it's important to understand that the this keyword here points to the Lufthansa object itself, because that's the object on which the book method here was called. So again, that's just what I explained before, right? But now let's say that after some years, the Lufthansa group created a new airline. So let's create Eurowings here. And then a very similar object. So with the airline, the code, and also an empty bookings array. Okay. Oh, and by the way, we actually also want our book method here to add a new object to our bookings here. So that's super important as well. So I forgot that. So let's go back here. So we will say again this, and then the bookings array. And then let's push a new object in there with the flight. And so that's essentially going to be this one. So the code plus the flight number. And then also the passenger name. And then let's quickly log that to the console here. So this .bookings is not a function, and of course it's not. We need the push method indeed. And so now you see that we have an array of our two bookings here. So that works perfectly. But now anyway, going back here to Eurowings, of course we also want to be able to take bookings for a Eurowings flight. So as being this airline, right? Now taking this exact same method here and simply copying it and pasting it here is a bad practice, right? So of course we are not going to do that. So instead we will just take the method and store it in an external function. And then we can reuse that function for all of the different airlines. So what I mean is to create a new function called book, and we will simply set it to Lufthansa.book. All right. So again, this is possible because JavaScript has first-class functions. And so we can simply take this function value here. So that's this function, and then store it into a new variable, which is then going to be also the book function. Okay. Now we could have written the function here also literally, but that's just not necessary. We have it right here. And so let's just leave it there and assign it to book right here. Okay. So let's try to use this book function to do a new booking now. But what do you think is going to happen? So 23, and then let's say Sarah Williams. And let's give it a save. And now we get cannot read property airline of undefined. So do you know why this happened? Well, it's because this function here, the book function, is now just a regular function call. And so as we learned in one of the previous sections, in a regular function call, the this keyword points to undefined, at least in strict mode. All right. So once more, this book function is no longer this method. Okay, it's just not. It is now this separate function here. It's a copy of this one, but it's not a method anymore. It's now a function. And so here it's a regular function call. And so therefore, the this keyword inside of it will now point to undefined. And that's why I kept telling you earlier that the this keyword depends on how the function is actually called. Okay, so make sure to understand this dynamics here. But now, how do we actually fix this problem? So in other words, how do we tell JavaScript that we want to create a booking on the new Eurowings airline? Or even, how do we tell it that we want to book on Lufthansa here? Well, basically, we need to tell JavaScript explicitly what the this keyword here should be like. So if we want to book a Lufthansa flight, the this keyword should point to Lufthansa. But if we want to book a Eurowings flight, then the this keyword should point to Eurowings. So how do we do that? How do we tell JavaScript explicitly or manually what the this keyword should look like? Well, there are three function methods to do that, and they are call, apply, and bind. So when we first talked about the this keyword, I think I mentioned these methods back then, and so now we're going to use them, at least the call and apply methods. Okay, so let me show you how. So instead of just doing this, which doesn't work, let's actually comment that out. Does not work. So instead, we use book dot call. All right. And remember that a function is really just an object, and objects have methods, and therefore functions can have methods too. And the call method is one of them. And in the call method, the first argument is exactly what we want this keyword to point to. So let's say we want an Eurowings flight. And then, as usual, the rest of the arguments. So 23 and Sarah Williams. All right. And then let's log to the console also the Eurowings object. Let's run this, and then I will explain a bit better what just happened. But indeed, we now have the bookings array, and in there we have the object with the EW23, and so EW comes from here, so exactly from the Eurowings object, and then also, of course, the name. And again, it is inside the bookings array of the Eurowings object. So let's recap what happened here. So this time we did actually not call the book function ourselves. Instead, we called the call method, and it's then this call method which will call the book function with the this keyword set to Eurowings. So whatever we pass as the first argument of the call method. And so this allows us to manually and explicitly set the this keyword of any function that we want to call. Then all the arguments after the first one are simply the arguments of the original function. And so in the case of the book function, of course, that's the flight number and the passenger name. And of course, now we can do the same also for Lufthansa. So book.call, this time with Lufthansa, and let's book someone else on flight 239. Let's say Mary Cooper, and let's log again the Lufthansa object. And let's do it now here. And indeed, this string that we get here is completely correct. And in here, so in the Lufthansa bookings array, we now have, of course, 3 bookings. Okay? And so that, of course, happened because this time we set the this keyword inside of the function call to Lufthansa. And so now this here is again back to pointing to Lufthansa, while before, right here, it was being pointed to Eurowings. All right? So even though the code of this function is inside of the Lufthansa object, we made it so that the this keyword in here pointed to Eurowings. So to this object, this new one right here. Okay? So we have a way now of manually manipulating the this keyword using the call method. And of course, we could now keep going and create more airlines into the Lufthansa group, like the Swiss Airlines, Now, of course, these property names, they all need to have the exact same format as this original object here, because this method is trying to read just these properties. So it's always IATA code and bookings, as you see here, and airline. And so, of course, we need to use exactly these property names here as well. But just like this, we can now go ahead and use our book function on the Swiss airline. And so this time we will set the this keyword in the book call to the Swiss object. 583, and let's book another flight for Mary Cooper here. And indeed, it worked again. So here is the booking again. Okay, there's just some weird thing here. And so, oh, actually here it needs to be airline as well. So I was telling you, you need to use the same property names, and I wasn't even doing it myself. So it needs to be airline just like it is here, and the same here too. And now the string is of course correct here. Okay, so let me add a comment here. Call method, because in fact there is a similar method to the call method, which is called the apply method. And the apply method does basically exactly the same thing. The only difference is that apply does not receive a list of arguments after the this keyword. So it doesn't receive this list here, but instead it's going to take an array of the arguments. Okay, and so it will then take the elements from that array and pass it into the function. So let's say flight data. So I'm just going to create quickly an array here with the flight number and the passenger name. So book on the same flight, George Cooper. And now we can use apply on the book function. So apply. And then just as here in the call method, the first argument is the this keyword. But now the second argument, it needs to be, as I just said, an array of data. So let's pass in the flight data array here. And then let's just take a look. Well, let's just take this one here actually. And so, indeed here it worked again. All right. This apply method is not that used anymore in modern JavaScript, because now we actually have a better way of doing the exact same thing. And do you know what I'm talking about? So let me show it to you. Book.call. So instead of using apply, we can still use call, again with Swiss, and then we can simply use the spread operator to take the data out of flight data and basically put them here. So this here is the same as this one. And so right now with modern JavaScript, I prefer to just always use the call method and then spread out the arguments from an array like this. So again, this here is exactly the same as this. So in summary, we now have yet another tool in our toolbox here. And this one is one that allows us to explicitly define the this keyword in any function that we want. But there is actually yet another method which allows us to do the same thing. And that's the bind method. It's more important actually than the call and apply methods, so I'm going to leave it for the next lecture. So let's now learn about the bind method. And just like the call method, bind also allows us to manually set the this keyword for any function call. Now the difference is that bind does not immediately call the function. Instead, it returns a new function where the this keyword is bound. So it's set to whatever value we pass into bind. So let's continue with our airline example from the previous lecture here. And now let's say that we need to use the book function for Eurowings all the time. So remember, we have this Eurowings object, and then we used book.call to use the book function with Eurowings set to the this keyword. So that's what we did in the last lecture. So let me just copy this code here. But now, as I said, we can use the bind method to create a new function with the this keyword also set to Eurowings. All right. So again, this will not call the book function. Instead, it will return a new function where the this keyword will always be set to Eurowings. And so let's create a new function here called book EW, which is the code of Eurowings. All right. And so now let's use this function. So book EW Stephen Williams, and we're missing the flight number here. so 23. And so as you see, this now looks like the normal book function call again. And that's because this function here already has the this keyword set in stone, basically. And so here, of course, we no longer need to specify the this keyword again. So the signature here, so the name of the parameters, is back to being simply the flight number and the passenger name. Okay, and so now again we see that Stephen booked a seat on Eurowings flight EW23. And so that worked perfectly. Let's also, of course, see the object again. So with all the bookings, and indeed, here is Stephen Williams in the flight that we just booked. Great. So this is really, really useful. And we could now, of course, go ahead and do the same for all the airlines. So creating one booking function for each of the airlines. And this then makes it a little bit easier to book a flight for each of the airlines if we have to do it multiple times. So instead of having to use a call all the time, we can just do bind once. So defining the this keyword once, like this, and from there on, we can then always use these functions. Dot bind, and this one, Swiss. All right. Now I'm not going to use them all here now because we already know how that works. All right. So this is great, but we can actually take this even further. So in the call method, we can pass multiple arguments here beside the this keyword, right? And so in the bind method, we can actually do the same. And then all of these arguments will also be basically set in stone. So they will be defined, and the function will then always be called with these same arguments. For example, we could use bind to create a function for one specific airline and a specific flight number. So let's say book EW, just like we had here, but then really specific only for flight 23. So that would be book.bind. And then, of course, we have to again define Eurowings, but then we can start defining the list of arguments or the list of parameters and setting the first one to 23. Okay. And so if we look at our bind function now, remember that it needs the flight number and the name. But now in our book EW23 function, it is as if this first argument was already set. And so our remaining function now only needs the name. So this function, this one now only needs the name because the number was already preset here in the bind method. So let's see. So our newly created function book EW23. And let's now book a flight for myself. And let's book a flight for Martha, let's say Cooper. And yeah, let's check out our output here. And so these are the two. And indeed, both of them are for Eurowings flight EW23. All right. And so that's exactly what we were expecting. Again, because we preset that 23 right here. If we preset this here to 1, 2, 3, 4, 5, then of course, both of these new flights here would be booked onto that flight number. Okay, so this allows us to set in stone certain arguments, and so this function, the resulting function, then becomes even simpler. So right now, all we need to pass in is the passenger name, right? And then everything else basically happens automatically. And taking this even further, we could even define the passenger name here, for example, like this. And then this function would always book a flight for Jonas on flight 23. But that would probably take it a little bit too far. Oh, and I deleted the 23 here Of course, I didn't want that. So this is correct. And by the way, what we did here, so basically specifying parts of the argument beforehand, is actually a common pattern called partial application. So essentially, partial application means that a part of the arguments of the original function are already applied. So which means already set. And so that's exactly what the book EW23 function is, right? It's essentially the book function, but with 23 already predefined. Great. So hopefully this was a nice example for you to understand the call, apply, and bind methods. But there are also other situations in which we can use the bind method and where it is very useful. And one example of that is when we use objects together with event listeners. So let's write that here actually. With event listeners. And so now this button here will finally come into play, and maybe you've been wondering about that. But let's start by adding a new property only to the Lufthansa object. And let's set it to 300. So meaning that this company has 300 planes. And then we also add a new method only to the Lufthansa object, which is to buy a new plane. So function, and now what we want to do is this dot planes plus plus. So essentially we want to add a new plane whenever we click on this button. So eventually that's what we will want to do. And then let's also log this dot planes to the console, and probably we should also log the this keyword to the console as well. And now let's actually attach our event handler to this element. Let's inspect it here. Okay, should need to go to elements. So this is the button here, and it has the class buy. So document.query selector .buy, add event listener for click, and then the second argument, as you already know, is the handler function. So add event listener here is the higher order function which receives a callback function, and so that should be Lufthansa.byPlane. .byPlane. All right, so essentially this function here is what we want to happen, which again takes the current number of planes and increases it by 1. So let's do that. And now as I click on this button, let's see what happens. And we get not a number here. So this dot planes is now not a number. And the reason for that is that the this keyword is this button element. Okay. And do you know why that is? Well, in one of the theory lectures, we learned that in an event handler function, the this keyword always points to the element on which that handler is attached to. So this is the handler function, right? And so it is attached to this element, so to this button. And therefore, inside of the handler function or the event listener, it doesn't really matter, but inside of this function, the this keyword will point to the button element. And so that's why this keyword here returns this button. Okay, so here you have yet another proof that the this keyword really is set dynamically. Because if we simply called Lufthansa.byPlane out here, then of course the this keyword would be Lufthansa, so this object, right? Because that's the object calling the function. But in this case, it's of course this event listener function calling this function. And so therefore, the button itself will then become the this keyword. Okay? Here we now see the result of calling this function out here. And so now we started with 300 and it was increased just as we wanted it to be. So let's take this out here and let's go back to clicking here to see the result we had before. So that's this button. Now, of course, in this handler function here, we still need the this keyword to point to the Lufthansa object itself, right? Otherwise, this logic here will not work. So what this means is that we need to manually define the this keyword right here. So right here. Now, how should we do that? Should we use the call method or the bind method? Well, we need to pass in a function here and not to call it. And so we already know that the call method calls the function. And so that's not what we need. And so therefore we use bind, because we already know that bind is going to return a new function. And so the this keyword should be Lufthansa. And so that's exactly what we define. Okay, and now as we click here, we should see the Lufthansa object being the this keyword. Indeed, that's now exactly what we got here. So that's the result of this line of code. And so again, this now points to Lufthansa, because that's what we told JavaScript to do right here. And so indeed, now the number of planes is increasing each time that we click on this button. Great. So we have our problem solved. And in fact, we will do this a couple more times throughout the course. So this one is an important one. And in general, the bind method is something you really need to understand. All right. Now, just one final example here, which is again going to be about partial application, because this is another big use case for the bind method. And in this case of partial application, many times we are not even interested in the this keyword, but we still use bind for this. All right. Now remember that partial application means that we can preset parameters. All right. So let's start by creating a general function which adds a tax to some value. So let's start with the tax rate and then the value itself. And let's write an arrow function here. And so this works by doing value plus value times the tax rate, right? So imagine that the tax rate would be 10% and the value 100. And so adding the tax to 100 would be 110. Well, let's actually do 200 to make it a bit more clear. And of course, we need to call the function here itself. Okay, so now 10% of 200 is 20, and so the result should be 220. And that didn't work. And yeah, that's because we need to define this here as a decimal number here, of course. So only then this rate here can make sense. Okay, so 220 now. So this here is the general function for adding tags. But now let's say that there is one tax that we use all the time. And so let's create a function for that. So for example, here in Portugal, the VAT, which is value added tax, is 23%. And so we can now use the bind function on this function and preset the rate always, so that it always will be this 23%. And then we have a function which only calculates the VAT for whatever value we pass into it. So add tax dot bind, and then the first argument of bind is the this keyword. Remember? But in this case, we don't care about the this keyword at all. It's not even here in the function. And so we just say null. It could be any other value because nothing will happen with it, but it's kind of a standard to just use null. And now we can set the rate here. So let's preset it to 23%, so 0.23. All right, and so this sets the rate value here in stone. So essentially this would be the same as writing, let's paste it here. So this would be add VAT equals, and the rate is preset to 0.23. So this is essentially what our add VAT function now looks like. Okay, so because we already set 0.23 in stone. So now we can start using that. So this should be 123, and it is. We can use anything we want now, like 23, and so on and so forth. So I hope this makes sense. When you want to do this yourself, just keep in mind that the order of the arguments then is important. If you wanted to preset the rate, then it has to be the first argument in this function. Otherwise, this would not really work here. Okay. Now you could argue that what we just did here could easily have been done with default parameters. But this is actually different, because this here is creating a brand new, simply more specific function based on a more general function, which is the addTags function. And of course, the example here could be a lot more complex too, right? So this really is different, because using bind actually really gives us a new function. So it's as if we returned a new specific function from the addTags function. And actually now I have a nice challenge for you, which is to essentially rewrite this whole example here, but using the technique of one function returning another function. So we have one lecture about that, and maybe you can go back and take a look at that. And then I want you to essentially create a function that can return a function which will do just what this one does. So that's probably really challenging. So don't beat yourself up if you cannot do it. I know it is a challenge, but you can still try to take a minute or two and yeah, really try it. If you can't do it, then just watch the solution in a minute. Okay? Just don't use bind, of course, because with that we already have the solution. So use the technique that I showed you earlier with the greet function, remember. And so here you can do something similar. So see you in a second with the solution. All right, I hope you tried that out. And here is how I would have done it. So the first function here, I'm going to call it addTagsRate. And I could do this with the arrow functions, but then that looks really confusing. So let's just focus on the functionality here. So this is the first function which only receives the rate. So similar to what we did here. And then what it does is to return a new function. And then this new function is the one that takes in the value. And it will then return, just as the other function, value plus value times the rate. Okay. And so now based on this one, we could create add VAT 2. And so that would be add tax rate and then call it with 0.23. And then let's just do the same to see if the results are the same. So VAT 2 and 2, give it a try. And here you go. So the results are the same. And so this add VAT2 is the same function as this one. So just to recap, we created this function, which then returns this one. So the first one is the one that needs the rate, because the rate is also what we used to define this add VAT function here, right? And so the resulting function is then the one who takes in the value. And that's why we have value here in the inner function too. Now this is just another way of doing the same thing, and this is already pretty advanced stuff, really. So absolutely don't be upset if you didn't do this by yourself. But anyway, in the next video, we have coding challenge number 1 of this section coming up, and so I hope to see you there very soon. Welcome to the first coding challenge of this section. And this one is going to be an exciting one. Because in this one, we are building a simple poll application. So a poll has a question, an array of options from which people can choose, and an array with the number of replies for each option. And this data is stored in this object here that I already created for you. Now you can copy this object from here, or you can get it from the final code that's available for the section in the GitHub repository. Okay, so you see we have the question, the array of options, and also a new array of answers. So this code here, we will learn how it works in the next lecture, but this will create this array of 4 zeros. And that's because there are 4 options here for this question. And now here are your tasks. So first up, in that poll object, create a new method called registerNewAnswer. And this method does 2 things. So it displays a prompt window for the user to input the number of the selected option. And here I want the text to look exactly like this. Then, based on the inputted number, so the user should input either 0, 1, 2, or 3. So based on that, update the answers array. So if the user gives 3 here as the option, then increase the value at the position 3 of the array. And of course, increase that by 1. To do this, make sure that the input is actually a number, and if that number makes sense. Then I want you to call this method whenever the user clicks on this button. And so this is where the second button here comes into play. Then number 3, create a method called displayResults. And this one should, as the name says, display the results of the poll. Now this method takes an argument called type, and that type should be a string, as I say here. And the value of that string should either be string or array. So these are 2 different ways of displaying the results, basically. Now if the type is set to the string of array, then simply display the results array as it is using a normal console.log. And this should actually be the default option. All right. Now, if the type is set to string, then display a string like this one here. Okay. And then once you have this method built, run it each time after the registerNewAnswer. So essentially, whenever someone clicks on this button here, it will call this registerNewAnswer method, and then this method itself will call displayResults. Okay? And to do this, use as many of the tools that you learned in this section, and probably also the last sections, and really all the course itself. Now, there are a lot of moving parts in this challenge, and it might not be as straightforward as it seems here. So if you need to cut some corners and make some things a little bit easier, then that's absolutely no problem. At least just write some code on your own. That's really my main goal with this challenge. Then if you manage to do these challenges, or to do the challenge as instructed here, then I also have a bonus for you. And so that is to use this displayResults method that you built before to display these 2 arrays that we have here in the test data. Okay, so usually you simply use this method to display the answers array that's inside of the object. But here I want you to really display simply this array and this array. And of course, do not put this array here inside of this poll object. Okay, you should use them individually. Now for doing this, you have to really think about what the this keyword should look like in this situation. And then you basically need to set the this keyword accordingly. Okay, so that's a nice challenge here. And one thing that is certain is that your code will look different than mine. I'm just a normal developer like anyone else, and everybody writes their own code. And so my code is different from everyone else's code, probably. And so, yeah, that's completely normal if you are starting to develop your own style. So take maybe an hour even to do all of this, and then come back to this video to check out my solution. So let's get to work here. I hope it went well for you when you tried it out on your own, and you can always share your experience in the Q&A area. Anyway, let's now get the answer here. And so for that, we use prompt. So const answer prompt. And so let's see what it has to look like. So it's just a question. Then it's a new line. Then it's these options, another new line, and then write option number. So this part is always the same. So I'm just copying it from here. So we want to grab the question first. And so that is this dot question. Then the new line, which is this, remember. Then we want the options. And so one new line for each of these options here. So this is an array. We want to transform it to a string. And so for that, we use the join method. So this one we learned about in the previous section. So I hope you remember this one. And so we take the options array here and join it. And we do join it again by the new line character. Now, okay. And then finally another new line. And then this part. All right. Oh, and then we, of course, also need to convert this result to a number. All right. So this looks good. Let's just add a comment here. So this is get the answer. And then here, second is to register. I think that's what we had here. So the first step is to get the answer, and the second is to basically update the answers. So I'm just calling that register the answer. Okay, but here let's actually start by trying it out. So let's do for now Paul.register new answer. And indeed, this is exactly the formatting we were looking for. Let's say 3, and indeed we get 3. Nice. And so now let's register the answer. And remember that we should check if this value is actually a number, and also if it makes actually sense. So in terms of the number of options. So first we check if it is indeed a number. And there are better ways of checking this, but more about that later. And we also want to know if the answer is below the length of this array, basically, right? So if the answer is 10, then that doesn't make any sense. And so it must stay below the length. So the length here is 4. And so the max reply that we accept is 3. So answer needs to stay below this.answers.length. Now here we could now do an if statement and basically saying that if this is true, then increase the answers array at the correct position. However, instead, this is actually a great use case for short-circuiting with the AND operator. So let's simply do this. So this.answers, and then we go to the position of answer, and then simply increase it like this. All right. So if this here is true, then the AND operator will keep going, right? So then this is evaluated, and if it's still true, then this here is executed. But if either one of these conditions here is false, then the AND operator will short circuit, and this part here is not executed. So this is a nice use case for short circuiting, because the code that we want to execute is just one simple line of code. Okay, so now let's then take a look at the answers. So this.answers. So this is for now the register new answer method. And now let's focus here on point number 2, which is to actually call the method whenever we click on this answer button here. So let's select that button, document.query selector, and now we need the class name. Let's check that out here again in the elements. And so it has the class of Paul. So Paul dot add event listener, click, and now the function that we want to execute. And so that is add Paul dot register new answer. All right. Now, do you think that this will work like this? And let's give it a save actually. And there is an error, and that's because we're trying to read property join of undefined right here. And so the problem here is, as you might have guessed, because we talked about this before, is that the this keyword right now points to this element. So to this Paul button here. And so again, that is because in an event handler function, such as this one here, the this keyword will always point to the element to which it is attached. And so right now, that is this button. So to fix this, we need to bind the this keyword, and in this case, we need to set it to the Paul object. And so then, in this function here, which is the result of the bind method, so in this new function, the this keyword will then point to the Paul object. So let's see that, and now indeed it works. So let's input 0 here, and indeed, we already get our array where the count of the answers in position 0 has increased. And if we try this again, it should become 2, and it does. Now, in order to actually display these results, we should create this new method called display results. All right. So it takes a string that is called type, with array being the default here. All right. So let's do this. And also keep in mind that this is the kind of string that we want if the type is string. So let's copy this one. And now here we add that new method called display results. And so it gets the type. And remember, it has the default set to array. And so here we can use the ES6 default parameters using this equal sign. So if type equals array, then simply log this dot answers to the console. Else, if the type equals a string, then we want to log something like this to the console. So once more, a template string or template literal. And actually this should be outside results are, and then do create this here. We can simply join the array together to form a string. So that's this dot results, or actually answers, dot join, and we join them with a comma and a space. Okay, and so now here, let's get rid of this console.log, and instead we will now call this method. So this dot display results, and let's actually call it twice. Once without passing any argument, and then here passing in string. And so then we will see both types of results printed to the console. And so this is number 4 here. So let's give it a save. 0, and indeed it works just the same. 3, let's try 3 again, And so indeed, it works just fine. Let me now input something else. And so then nothing changes here. So the results are not updated. And that's because of this testing logic that we have here. Great. So I hope you have been following this far. So this is similar to what we have been doing. And now let's check out the bonus here. So let's use the display results method that we just used, but to display these two arrays. Okay, let's copy them just so we don't have to scroll so much. And it says here that we should think about what the this keyword will look like. So we will do that, of course. Okay, so these are the arrays that we're going to work with. So the method is at pol.displayResults. But as I said, now we want to call this method here not with this array, so not with the answers array, but instead with this array. So what should we do here? Well, we will have to use the call method because we will need a new this keyword, right? Because display results uses this.answers. Okay, so the answers come from the this keyword. And so if we want to have a different this keyword, then we need to use call. And what should the this keyword be like? Well, we need an object which contains the answers property here, right? Otherwise, there is no way for this method to call this.answers. And so we can simply create a new object and say answers and then this array. And that's it. Let's try this. And indeed, here is the result printed. And let's even now pass in the string option. And so now indeed we get poll results are 5, 2, and 3. All right. So again, to recap, this works because this function here is looking for this.answers. But our array is, well, it's simply out here. So we need a way to make this.answers equal to this array. And so that's why we used the call method here, so that we could manually set the this keyword to a new object, which as the answers property has that new array. And now let's just try it with the other one here. And we can do the same without the string, and then it will just log the array itself. And yeah, that works just fine. Great. Now, what we did here is not really a real scenario, but it's still good for us to use these concepts in some different ways to really get used to how all of these concepts work together. Our next topic is something called immediately invoked function expressions. So let's take a look at what they are. So sometimes in JavaScript, we need a function that is only executed once and then never again. So basically a function that disappears right after it's called once. And this might not appear to make much sense right now, but we actually need this technique later, for example, with something called async await. So how could we do that? Well, we could simply create a function and then only execute it once. So run once function this will never run again, and then we can call it here. However, we can actually run this function again at some other point in the code if we wanted to, right? There's nothing stopping us from later doing run once again, right? And so this is not what we want to do. We want to actually execute a function immediately and not even having to save it somewhere. And so this is how we do that. So we simply write the function expression itself, so without assigning it to any variable. Now, if we try to run this, we will get an error for now. And so it says function statements require a function name. And that's because, of course, JavaScript here expects a function statement, because we simply started this line of code here with the function keyword. However, we can still trick JavaScript into thinking that this is just an expression. And we do that by simply wrapping all of this into parentheses. And so now we basically transformed the statement that we had before into an expression. And so now if we save this, we get no error. But also this function didn't execute yet, right? We never called it. So we know that this here is the function, and so we can then immediately call it. And so with this, we will get now this text here logged to the console, this string. And indeed, here it is. All right. So again, this here is really just the function value. So it's just a function expression. And then immediately we call it here. And so this is why this pattern here is called the immediately invoked function expression, or IIFE for short. So immediately invoked function expression. And the same would, of course, also work for an arrow function. So let's just copy this. This will also never run again. So if we try to call it like this, then it would not work. And so we actually don't get an error, but also nothing happens. So we first need to wrap this into parentheses, and then as we call it, then here it is. Okay, so two ways of writing an immediately invoked function expression. But you might be wondering, why was this pattern actually invented? Well, we already know that functions create scopes, right? And what's important here is that one scope does not have access to variables from an inner scope, right? For example, right here in this global scope, we do not have access to any variables that are defined in the scope of any of these functions here, right? So for example, let's add a variable here. Let's say is private equal to 23. And then as we tried to access it out here, you already know that it's not going to work, right? And that's because the scope chain only works the other way around. So the inner scope would have access to anything defined outside here in the global scope, but the other way around, the global scope does not have access to anything that is inside of a scope. So in this case, of the scope created by this function here. Therefore, we say that all data defined inside a scope is private. We also say that this data is encapsulated. So for example, this is private here, is encapsulated inside of this function scope that's created here. And data encapsulation and data privacy are extremely important concepts in programming. So many times we actually need to protect our variables from being accidentally overwritten by some other parts of the program, or even with external scripts or libraries. And I'm going to talk in detail about these concepts in the object-oriented programming section. But for now, keep in mind that it's important to hide variables and that scopes are a good tool for doing this. And this is also the reason why the immediately invoked function expressions were invented. So basically this pattern here. So this is not really a feature of the JavaScript language. It's more of a pattern that some developers came up with and that then started to being used by many other developers. Now, do you remember what also creates a scope in ES6? And that's right, variables declared with let or const create their own scope inside a block. And we learned that in the behind the scenes section. Remember? So when we create a block like this and declare is private in there, then the outside can still not access is private. So let's comment out this one and paste it here. And once again, we cannot access this variable. While on the other hand, this one here would, of course, be accessible. And so again, that's what we learned in one of the previous sections. So that's because this one here was declared with var, and therefore it does completely ignore this block here, essentially. And this is the reason why now in modern JavaScript, immediately invoked function expressions are not that used anymore. Because if all we want is to create a new scope for data privacy, all we need to do is to just create a block like this, right? There's no need to creating a function to create a new scope. Unless, of course, we want to use var for our variables, but we already know we probably shouldn't do that, right? Now, on the other hand, if what you really need is to execute a function just once, then the IIFE, so the immediately invoked function expression pattern, is still the way to go, even now with modern JavaScript. And we will actually see a great use case a bit later of doing an IIFE. There is an almost mystical feature of JavaScript functions that many developers fail to fully understand. And what I'm talking about is something called closures. So when I ask my students what's the hardest JavaScript concept to understand, then many people say that it's closures. However, I believe that with the right explanation, it's actually not that hard, especially when you already understood everything that you learned before in this course, such as execution contexts, the call stack, and the scope chain. Because closures kind of bring all of these concepts together in a beautiful, almost magical way. So enough talk, let's see what closures are all about. So I'm going to start by creating a new function here called secure booking. And it is this function that will create the closure. Now, the first thing that I need to tell you about closures is that a closure is not a feature that we explicitly use. So we don't create closures manually like we create a new array or a new function. So a closure simply happens automatically in certain situations. We just need to recognize those situations. And so that's what we're going to do here in this example. So we will create one of those situations so that we can then take a look at a closure. So anyway, let's now continue writing this example. And I'm calling this one passenger count. And it will start at 0, but we will be able to manipulate it. And I'm calling this function here secure booking because this passenger count variable cannot be manipulated and accessed from the outside. So, and now what's special about this function is that it will return a new function. And what we do in this function is to update the passenger count variable. So the variable that is defined in the parent function. So that's important. And then let's just log the new passenger count to the console. So passenger count. All right. And now let's call the secure booking function and then store the result in a variable called booker. And so this is actually pretty similar to what we did previously in the lecture of functions returning other functions. So we have one function here that we call, and this function will return this new function. And so as we call secure booking, it will return exactly this function, and it will then be stored inside this booker. And so this here is going to be now a function as well, right? So let's analyze in detail what happens when this line of code here is executed using all the concepts that we already know about. So this is exactly the code that we just wrote. Now, before we start running the secure booking function down here, our code is running in the global execution context. And in there, we currently only have this secure booking function. And so we can also say that the global scope now contains secure booking. Then, when secure booking is actually executed, a new execution context is put on top of the execution stack. Now, remember, each execution context has a variable environment, which contains all its local variables. In this case, it only contains the passenger count set to 0. This variable environment is also the scope of this function. And so the scope chain of this execution context looks like this. So passenger count is in the local scope, but of course this scope also gets access to all variables of the parent scopes. And in this case, just a global scope. Anyway, in the next line of the secure booking function, a new function is returned and it will be stored in the booker variable. So the global context now also contains the booker variable. And now what else happens when the secure booking function returns? Well, that's right, its execution context pops off the stack and disappears. So the secure booking function has done its job and has now finished execution. It really is gone now, and that's important to be aware of and to keep in mind. And for now, that's actually all we did. So all this is nothing new at this point, right? All we did was to analyze the call stack and the scope chain as we call the secure booking function. And this is going to be important to later on understand the closure. So as of yet, we didn't see the closure yet. All we did was use the knowledge that we already have to understand how this booker function was created, because that's going to be important for the next step. So let's now go back to our code to actually use the booker function and then finally see the closure in action. So now that we understand how the booker function was created, let's now actually call it here. So calling it a couple of times here. And as we can see, it doesn't need any arguments. There's no list of parameters, right? So let's call it here 3 times. And now let's reload the page here. And indeed, we get 1, 2, 3 passengers. And so what this means is that the booker function was in fact able to increment the passenger count to 1, then to 2, and then to 3. But now, if we think about this, then how is this even possible? How can the booker function update this passenger count variable that's defined in a secure booking function that actually has already finished executing? And so, as I just said, this function has already finished its execution. It is gone. So its execution context is no longer on the stack, as we just saw in the slide. But still, this inner function here, which is the booker function, is still able to access the passenger count variable that's inside of the booker function that should no longer exist. And maybe you can guess that what makes this possible is a closure. But before I explain exactly how the closure works, I want you to appreciate once more how strange this actually is. So again, this booker function here is simply a function that exists out here in the global environment, or in the global scope, right? And the environment in which the function was created, so this here, basically, this environment is no longer active. It is in fact gone. But still, the booker function somehow continues to have access to the variables that were present at the time that the function was created. And in particular, this passenger count variable here. And so that's exactly what the closure does. So we can say that a closure makes a function remember all the variables that existed at the function's birthplace, essentially, right? So we can imagine the secure booking as being the birthplace of this function, so of the booker function, essentially. And so this function remembers everything at its birthplace by the time it was created. And this cannot simply be explained with the scope chain alone. So we need to also understand the closure And so let me now really explain how it actually works. So this is how we left the call stack and the scope chain after the last slide. And the most important thing to notice here is that the execution context of secure booking is no longer on the call stack, because again, this function has finished execution long ago. So now it's time to finally run the booker function and see exactly what's gonna happen here. And note that booker is really this function here located in the global scope. Anyway, the first thing that's gonna happen is that a new execution context is created and put on top of the call stack. And the variable environment of this context is empty, simply because there are no variables declared in this function. Now, what about the scope chain? Well, since booker is in the global context, it's simply a child scope of the global scope, just like this. But maybe now you're starting to see the problem. So how will the booker function access the passenger count variable? It's nowhere to be found in the scope chain, right? So this is where we start to unveil the secret of the closure. And the secret is basically this. Any function always has access to the variable environment of the execution context in which the function was created. Now, in the case of booker, this function was created, it was born in the execution context of secure booking, which was popped off the stack previously. Remember? So, therefore, the booker function will get access to this variable environment, which contains the passenger count variable. And this is how the function will be able to read and manipulate the passenger count variable. And so it's this connection that we call closure. So let's say all that again to make this really clear. So a function always has access to the variable environment of the execution context in which it was created, even after that execution context is gone. And this last part is really important. The closure is then basically this variable environment attached to the function, exactly as it was at the time and place that the function was created. And this probably still sounds confusing, but don't worry, I have some more familiar analogies in the next slide. For now, we are just trying to understand the mechanism behind the closure, so how it all works behind the scenes. So what matters the most here is that the booker function has access to the passenger count variable because it's basically defined in the scope in which the booker function was actually created. So in a sense, the scope chain is actually preserved through the closure, even when a scope has already been destroyed, because its execution context is gone. This means that even though the execution context has actually been destroyed, the variable environment somehow keeps living somewhere in the engine. Now we can say that the booker function closed over its parent scope, or over its parent variable environment. And this includes all function arguments, even though in this example we don't have any. And now this attached or closed over variable environment stays with the function forever. It will carry it around and be able to use it forever. To make it a bit more digestible, we can also say that thanks to the closure, a function does not lose connection to variables that existed at the function's birthplace. That's a bit more intuitive, right? But anyway, let's see what happens now with execution of the booker function. So the function attempts to increase the passenger count variable. However, this variable is not in the current scope. And so JavaScript will immediately look into the closure and see if it can find the variable there. And it does this even before looking at the scope chain. For example, if there was a global passenger count variable set to 10, it would still first use the one in the closure. So the closure basically has priority over the scope chain. And so after running this function, the passenger count becomes 1, this message is logged, and then the execution context is popped off the stack. Then execution moves to the next line, we get a new execution context, and the closure is still there, still attached to the function, and the value is still 1. And so now this function executes, increasing the passenger count to 2 and logging a message again. Okay, and that's what closures are and how they work behind the scenes. And I know that this is all quite complex, so let me give you a couple different definitions of closure now, some more formal ones and some more intuitive and maybe easier to grasp. And the most formal definition of closure is the one we already saw, which is that a closure is the closed over variable environment of the execution context in which a function was created, even after that execution context is gone. Or in other words, even after the function to which the execution context belongs has returned. Next, and a bit easier to understand, a closure gives a function access to all the variables of its parent function, so the function in which it is defined, even after that parent function has returned. So the function keeps a reference to its outer scope even after that outer scope is gone, which basically preserves the scope chain throughout time. Alright, another definition, or let's say analogy, is that a closure makes sure that a function does never lose connection to the variables that existed at the function's birthplace. It remembers the variables even after the birthplace is gone. It's like a person who doesn't lose connection to their hometown. In this analogy, the person is the function and the hometown is the function's parent scope, and the function then doesn't lose the connection to the variables stored in this parent scope. And I hope that makes sense. Finally, some people like to think of this attached variable environment as a backpack. So in this analogy, a function has a backpack which it carries around wherever it goes. And this backpack contains all the variables that were present in the environment in which the function was created. Then, whenever a variable can't be found in the function scope, JavaScript will look into the backpack and take the missing variable from there. So kind of similar to the other definitions, but maybe a little bit more visual. So these are some different ways of defining closure, but they all mean the same thing. So they all represent the same idea. Finally, we need to understand that we do not have to create closures manually. And this is also what I already touched on at the beginning of the lecture. So instead, this is something that JavaScript does completely automatically. We don't have to do anything. Also, there is no way for us to explicitly access closed over variables. That's because closures are not like a tangible thing. They're not like an object or so that we can access. So we cannot just reach into a closure and take variables from it. That's impossible, because a closure is just an internal property of a function. We can observe that a closure happens, because functions magically keep having access to variables that should no longer exist, but we cannot directly access these variables. However, what we can do is to actually take a look at this internal property. So at this backpack, so to say, in the console. So let's quickly do that before we finish this lecture. And we can do this by using console.dir and then of the Booker function itself. So similar to console.log, but this one is a bit different. And so here we now get this function itself. So we can get the arguments, the name property that we already took a look at before, and then down here we have this scopes internal property. And this internal scopes property here is basically the variable environment of the Booker function. Now in here we can actually see the closure coming from secure booking. All right, And so this is where we see the passenger count, which currently stands at 3. And so this closure here basically is the variable environment of this secure booking. So that's the one that is being preserved by the closure. All right. And by the way, whenever you see these double brackets here, that means that it is an internal property which we cannot access from our code. All right. This was a long video about closures. Now, in the next lecture, we're going to take a look at 3 more examples of closures and also analyze how they work, because it's really important that you understand this concept of closures. It's a feature that's used all the time in JavaScript, and many times even without us realizing that closures are happening. So if you want to become confident as a programmer, you always need to know how exactly everything in your code works. And that, of course, includes closures. Let's now create 2 more situations in which closures are gonna appear, so that you can start identifying closures in your own code in the future. And both of these examples are gonna demonstrate that we don't need to return a function from another function in order to create a closure. All right, so let's start with our first example here. I'm gonna start by defining an empty variable called f, and then a function expression g. So these are just some generic names, because what the functions do here don't really matter. Then in here I defined this a variable, and then I'm going to reassign the f variable that we created out here, and I'm going to assign it a function value. And this function will then simply log the a variable to the console, let's say times 2. Okay, and that's it, for now at least. So let's try to call g. So that's going to be this first function. And so the result of this function is that a will be 23, and that our f variable that we have out here will become this function. And so after g, we can then call f. So let's try that. And we get 46, which is indeed 23 times 2. All right. And so what this proves is that this f value here, so this f function, really does close over any variables of the execution context in which it was defined. And that is true even when the variable itself, so f here, was technically not even defined inside of this variable environment here, right? So this f variable was defined outside here in the global scope. It was created here. But then as we assigned it a function here in this g function, so right here it then still closed over the variable environment of the g function. And that includes this a variable. And therefore it is able to access this a variable here even after the g function here at this point has, of course, already finished its execution, right? So that's just what we learned in the last lecture. So at this point of the execution, the variable environment of g is no longer there, right? But f, so this function here, closed over that variable environment, and therefore it is able to access the a variable. So basically, using the analogy of our last video, the a variable is inside the backpack of the f function. But now let's take it to the next level and create a new function here. So that's h, and it's going to be very similar. All it's going to do is to define b as some other value, let's say this, and then we will again reassign f right here. So let's call this one b now, of course. So this one here will then try to access B and multiply by 2. Okay? And so what I want to see with this is what happens when we assign the f value a second function. Okay? So here we call g, and so g will then assign to our empty variable this f function. Okay? And then if we call h afterwards, or actually let's do it after calling f for the first time. So as we then call h, then the f variable will be assigned again. So then a second function, which is this one here. And so what I want to see is what f does then. So let's see. And again, keeping in mind that f at this point is a different function than this one here, because it was reassigned by h. We just write that here. Okay. And now we get 1554, which is probably 777 times 2. And indeed, it is. And so this proves that the f function that was reassigned here also closed over the variable environment of h. And so that's how it can access then the b variable here, which is set to 777. So let's actually inspect the variable environment like we did by the end of the last video. So of f. And then we will be able to see that in the closure, it does indeed have the value of b. And it now no longer has the value of a. So of the closure that it used to have before. So at this point here, the closure contained the value a. And we can, of course, also see that. So at this point in time, the closure is indeed a23, right? And so then as we reassign the function to a new value, then that old closure basically disappears. And yeah, now the closure is b. So this variable here of the birthplace where it was reassigned. And this is really fascinating in my opinion, that the closure can change like this as the variable is reassigned. So it really is true that a closure always makes sure that a function does not lose the connection to the variables that were present at its birthplace. So it's always going to remember them. And in our case here, the function was kind of born inside of g first, and then it was essentially reborn again in h. And so first, the closure contained the a variable of its first birthplace, and then as it was reborn, to follow our analogy, then it remembered this b variable of its birthplace. Okay? So this was example 1. Let's now create another example. Okay, so I hope the first one was clear here. So whenever something like this happens, where you reassign functions, even without returning them, keep in mind that also this will create a closure. But now moving on to our second example here, and that's going to be a timer. So a timer is another great example that we don't need to return a function to see a closure in action. So here I'm going back to the example of the airline. So creating a function called board passengers. And then we get the number of passengers and a wait time. Then let's create a new variable in here, which I'm calling per group. And that's because boarding usually happens in groups, and we usually have 3 groups. So I'm going to divide all the passengers, so the number of passengers that is boarding, by 3. And by the end of this function, I want to log to the console, we'll start boarding in, then wait seconds. Okay. And now let's actually use a timer. And we haven't actually used a timer yet in this course, and we will learn more about them later. But this is such a good use case that I wanted to use a timer now. And it's actually very simple. So we just use the setTimeout function. And the setTimeout function needs two parameters. The first one is a function which will be executed. Okay, and this function will be executed after a certain time. For example, we can specify 1000 milliseconds because the second argument here is milliseconds. And so that will mean that whatever code is inside of this function will be executed after 1 second. So let me actually do that out here just so you see this as an example. So if I save this now, wait 1 second, and then here you see timer appearing. So I'm going to do that again. Okay, so you see that after this 1 second, this function was executed. Okay, and so this, as we already learned before, is essentially a callback function. And in this case, it is literally called later. So in this case, after 1 second. So let's create our callback function here. And first I want to log to the console. We are now boarding all and then the n passengers. And so this n here is this parameter of the function. So of this parent function, which essentially is the function or the scope in which this callback function here is being created. And so that will of course be important for our closure example. And then let's also use the per group variable now. There are 3 groups, each with passengers. Okay, that's our function, and now let's call it. Oh, and here we want to specify weight, and then times 1000, because we're going to pass in the weight in seconds. And this argument here needs to be in milliseconds, and so we just multiply by 1000. So, board passengers, let's say we have 180 passengers, and it takes let's say 3 seconds. So immediately when we call this function, this variable will be created, then setTimeout will be called, and it will basically register this callback function here, and then that will be called after 3 seconds. But immediately also this console.log here will be called. All right. So this console.log here will not wait these 3 seconds for the setTimeout callback to finish. Okay. So immediately this variable is created, the setTimeout function is run, and console.log is run. And then after 3 seconds, this function here will be executed. And so let's see what happens to the n variable and to the per group variable that is in this function. So immediately we get this log. And then after 3 seconds, we are boarding all 180, and there are 3 groups with 60 passengers each. Okay, it worked. And again, keep in mind that this callback function here was executed completely independently from the board passengers function. All right, but still, the callback function was able to use all the variables that were in the variable environment in which it was created. So that's n and per group. And one more time, this is a clear sign of a closure being created, right? So the only way in which this callback function here can have access to the variables that are defined in the board passengers function that has long finished execution is if it created a closure. And so that's exactly what happened. And yeah, that's how we got access to per group and also this argument of the function. So this weight here, right? So as I mentioned in the last lecture, the closure, of course, also includes the arguments, and that's because they are really just local variables in the function. And to finish, let's now also prove that the closure does, in fact, have priority over the scope chain. So here in the global scope, I'm also going to create a variable called per group equals, and then just some value here. And so if the scope chain had priority over the closure, then this callback function here would indeed use this variable here, this global variable, because we can imagine this function here basically being executed in the global scope. Okay, so if it wasn't for the closure, it would use this. So let me actually demonstrate that to you. So if I remove this variable, then it will be able to use the per group, and that is here outside. So indeed, now we get 1000. But then, as we put it back here, then the callback function will close over this variable. So it will close over the entire variable environment, in fact. And so therefore, it will then use this here first. Right? And it did. So, in fact, the closure even has priority over the scope chain. Okay, and with this, we finished these 2 lectures about closures. And I hope that after this one, you are now a little bit better able to identify closures as they happen in your code, or even here in my code throughout the course, because we will see some closures happening some more times in the future. Now all there's left to do is the coding challenge in the next video, where you will be thinking about closures one more time. To make sure 100% that you understand closures now, let's work on this coding challenge number 2. And actually, this one is more of a thinking challenge than a coding challenge. So what I want you to do is to take this IIFE here, and at the end of the function, simply attach an event listener that changes the color of the selected h1 element. So this header here to blue. All right. And that should happen each time that the body element is clicked. So whenever we click here. And what's important here is that you do not select the h1 element again. So just use this header that you have here. All right. So that's all the code you have to write, which is really simple. But the real challenge here is that I want you to explain to yourself or even to someone around you why this works. So as you click the body, the text will change to blue, and so it's going to work, but you have to understand and you have to explain why it worked. And so this is a good exercise, because being able to explain something to someone else means that you have understood it yourself. So I really hope that you do this one, even though it doesn't involve a lot of coding, but it's still really important to do this. So take all the time that you need and think about when exactly the callback function is executed, and of course what that means for the variables that are involved in this example. So again, take the time that you need, and I see you here in a minute with my own explanation, basically. So the code that you had to write was simply this. So selecting the body element and then add event listener on click, and then this callback function. And then I'm simply changing the style here to blue. And keep in mind that we did not select the h1 here again. I simply used the header variable that we had already selected before. So let's give it a save, and I will click now the body, and indeed it became blue, and that worked just fine. So why did this work? Or in other words, how does this callback function here get access to the header variable? And one more time, the explanation is the closure. So I hoped that you really explained basically how the closure works to yourself or to someone else. And so in this particular example, the closure is necessary, or it's useful, because by the time this callback here is executed, this IIFE, so this immediately invoked function expression, is now long gone. So it has already been executed, and with it, this variable here is basically gone as well, right? So all of that is gone, but still this function here is attached to the body element. And so it's waiting for some event to happen there. And when the event happens, well, then this function here is of course executed. And again, even though the environment in which this function here was created is already gone, it is still able to access the variables that were created in that variable by the time the function was born, so to say. So this is the birthplace of our event handler function here, and therefore the function remembers all the variables present at the time of its birth. We can also say that the header is in the backpack of this function. So that explanation works as well. And you can go even further and deep into theory and basically try to explain how all of this works behind the scenes. But that I already explained you in the more theory lecture, and so I'm not going to go into that again. All right. So hopefully you managed to explain this to yourself, maybe to your dog, whatever. But what's important is that you now understand how the closure works and how and when it appears. So this was yet another great example of a closure appearing. Anyway, with this, we finished this pretty important section on functions. And so in the next one, we will finally build another visual project with a graphical user interface, which is really exciting. So that section is all about arrays, and we're going to build together an awesome application there. So I hope to see you there as soon as possible. Hello and welcome to our next section, which is all about arrays. So in JavaScript, arrays are probably the most used data structure. So we use arrays all the time, and therefore JavaScript has countless modern array methods, which we can also imagine as array tools. So in this section, we will learn all about these tools, so how to use them, and even more importantly, when to use them. And we will do that while building our next beautiful project, so that you can immediately apply all these array tools to a real-world situation. So let's go do that. Welcome back. Let's begin this section with a couple of very simple and very easy to understand array methods, just to expand our array toolkit a little bit more. And as always, at the beginning of a new section, make sure to grab your starter files and open them up in VS Code. So that's the folder called Arrays Bankist. And then open up script.js, which is going to contain a lot of stuff here. But for now, don't worry about any of that. I will explain what all of this is and also what else we have in our starter files in a couple of videos from here. All right. So up there we have the application part for the app we're going to build in this section. And then here we have the lectures part, which is a bit more for the concepts themselves. And by the way, this yellow part here comes from a VS Code extension that I use. And I think I showed it to you in the beginning. But anyway, let's not talk about array methods. Now, before we start, let's quickly talk about why arrays do actually have methods. Well, remember that methods are simply functions that we can call on objects. So basically, they are functions attached to objects. So if we have array methods, that means that arrays themselves are also objects. And so these array methods are simply functions that are attached to all arrays that we create in JavaScript. Now, we will learn why all arrays have access to these methods in a later section when we talk about prototypal inheritance. But for now, I just want you to understand that arrays are objects and that they get access to special built-in methods that we can essentially see as tools for arrays. And so, as I mentioned, in this lecture, we're going to start by learning some very simple tools that we can use on arrays. So let's start by defining a simple test array that we can work with. And I will make it as simple as possible, just with these letters, because that will help us understand some of the things we're going to do here. All right, the first method we're going to talk about is the slice method. And this one is very similar to the slice method that's available on strings. Remember? So with the slice method, we can extract part of any array, but without changing the original array. So essentially, we can take a slice of an array, and so that's why it's called slice. So array.slice, and now just like in strings, we have the begin parameter. And so this is the index at which we will start extracting. So when we say 2 here, we should start extracting here at C, and then all the way to the end. Okay? And then this slice method will return a new array. And so we need to log that to the console in order to actually see it. Okay? So as I said, this does not mutate the original R array. Okay? Instead, it returns a new array, so a copy of the array, but only with the extracted parts. So let's open up a terminal here again, and live server. And here we go. So this is already our Bankist page, but nothing is going to work here yet. So for now, let's just open up the console, because that's really all we are interested in for now. Let's reload here again. And so now we indeed get this array, which is a slice of the original array starting at position number 2. So 0, 1, and 2, right? Now, of course, we can also define the end parameter. So when we write 2 and 4, then let's see the result here. And so what this means is that just like in strings, the end parameter here is not included in the output. So index 4 is this one here. And so, yeah, as I just mentioned, this one is then not going to be included in the output. So 2 to 4 is really just 2 and 3. Okay? And so the length of the outputting array here will be the end parameter minus the beginning one. And so that's exactly the length we get here. Okay? Then next, again, just like in strings, we can define a negative begin parameter, and then it will start to copy from the end of the array. So -1 will basically take the last 2 elements of the array, so D and E. And so with this, it's pretty easy to simply get the last element of any array. So if we just duplicate this, so -1 is always just the last element of any array. So this is a very nice trick that's sometimes useful. And now to make this complete, we can also use a negative index as the end parameter. So let's start extracting at position number 1 until -1, basically. So let's see, that returns B and C, and that's because it now starts extracting at position 1, which is here, and it extracts everything except the last 2 here. So that's what the -2 here means. All right, and if you find this a bit confusing, then just experiment a little bit more with this. Now finally, we can use the slice method to simply create a shallow copy of any array. So to do that, we simply call it without any arguments at all, and then indeed we get here the exact same array. And if you remember it correctly, we already did something similar in one of the previous sections, but using the spread operator. Remember? So back then we did this. So creating a new array and then expanding the original array into that. And so that gives us the exact same result. So the question is, should you use the spread operator or the slice method in order to create a shallow copy? Well, that's actually entirely up to you. So it's just a matter of personal preference. The only time you really need to use the slice method here is when you want to chain multiple methods together, so calling one after the other. And we will do that, of course, later in this section. All right, so that is the slice method. Next up is a method with a very similar name, which is called splice. And the splice method works in almost the same way as slice, but the fundamental difference is that it does actually change the original array. So it mutates that array. So let's again log the result to the console anyway, but now we use splice, and then with the same argument as we used before here. And so the result here looks exactly the same. So this one here is the same as this first one. Let's give it even more space here. But now what happened to our original array? And we see that all that remains here in our original array is the first two elements. And so now the extracted elements are actually gone from the original array. So splice deleted them. And so what we can see is that splice actually does mutate the original array. So it takes part of the array and returns it, and then the original array itself loses this part that was extracted. Now in practice, most of the time the value that the splice method returns doesn't even interest us. All we are usually interested in is to just delete one or more elements from an array using splice. And one pretty common use case is to simply remove the last element of an array. So let's actually do that here. So let's say r.splice and then -1. So just like in the slice method, -1 here is the last element. Okay, so the begin and end parameters works exactly the same as in the slice method. Let's now just get rid of this one here so that we see our original array. And so indeed, as we log here r to the console, it is the original array except for the last element, which was e. So that's exactly what we did here. All right. And as always, in case you want to learn more about any particular method, for example, you can always use the MDN documentation. So let's say MDN array splice. So this one. And so now here are some more examples on how to use this. And so you have the name of the parameters. And actually the second parameter is called delete count. So it's actually not the begin parameter. So it works a little bit different than in the slice method. So let me just show that to you. So going back here. So if we do .splice, let's say at position number 1, and then we want to take exactly 2 elements. And so then we write 2. Okay. And so the result now of the resulting array, it should be that B and C are deleted. Okay, and so indeed, only A and D now remain. Let's log R to the console here to see the process a little bit better. So here we removed the first one, and then here we went to position 1 and extracted or deleted 2 elements. And so position 1 and then 2 elements. Okay, so this first parameter here works the same as in the slice method, but the second one is really the number of elements that we want to delete. All right, so that is splice. Next up, we're going to talk about reverse. So that's a very simple one. Let's just restore our array here at this part so that we can work with the original one here. Or actually, let's also create a new array here. Let's call this one R2. And here we will have 5 more letters of the alphabet, but this time in a wrong order. So let's say for some reason we are working with this array and we need to reverse it. And so that's exactly what we use reverse for. So R2 dot reverse, and indeed it now returns the reversed array. Here I actually want F, and so now it is correct. So F, G, H, I, J. But now what's important to note here is the fact that the reverse method does actually mutate the original array. So you see, as we log the original, it is now reversed too. Okay, so this one here does mutate the array. So that's important to keep in mind. So maybe you're noticing that in each of the methods, I always mention which one mutates and which one does not mutate the original array. And that's because this is a very important characteristic of each of these methods. That's because in a certain situation, we might not want to mutate the original array, and then we cannot use any of these methods. Okay. Next up is the concat method. And so this one is used to concatenate 2 arrays. So let's create a variable called letters. And letters will be the result of calling the concat method on array. And here we have to specify the second array. So let's take a look. And now we have the 10 first letters of the alphabet here. So the first array will be the one on which the method is called, and the second one is the one that we pass into the concat method. And once again, we already did this before in another way, remember? So we could simply also do this, right? R and then R2. This gives us the exact same result, and it also does not mutate any of the involved arrays. So just like concat, which also doesn't mutate the original array here. All right. And finally, just the join method that we already talked about before, but just for the sake of completion here, right? And by the way, here in this concat method, so if you prefer to do this one, it's of course perfectly fine. And once again, it is just a matter of personal preference, whether you prefer to use the spread operator or the concat method. All right. And now here, let's just join all the letters of the alphabet together that we have here in our array by using this separator here. Okay, and so as you already know, the result here is a string with the separator that we specified. Great. So your array toolset is rapidly growing here. And remember that you already know push, unshift, pop, shift, index of, and includes from the intro section. Now, if you ever lose track of all these different methods and how they work, you can always come back to these videos, or of course, check the documentation on MDN, just like we did here. So no developer in the world knows all of this by heart. So sometimes I even have to look up how the splice or the slice method works, because it's just too many methods to keep track of. And yeah, it's very hard to know everything by heart. But anyway, let's now move on to the next lecture, where we will take array methods to a whole new level. There's a new, very simple array method in ES 2022, which is the add method. And so let's take a look at it. And let's start by creating some dummy array. So 23, 11, 64. So just 3 random values here. And then if we wanted to take one of the values out of the array, let's say the first one, then we would traditionally do this, right? So array at position 0. So that's basically what this means. But now with the new add method, we can do the exact same thing using a method. And as you can guess, that is the add method. Then we specify the exact same index here, and then we get the exact same value. So basically now we do what we say here. So here we say array at position 0. And so that's why this new method is called array.addPosition0. So very, very simple, right? So basically we can now replace the traditional bracket notation with the more modern looking add method if we prefer to use array methods like this. Now, maybe this doesn't look all too useful. So what's the big deal here? Well, actually there is one particularity of the add method which makes it quite useful to use instead of the brackets notation. So let's now say that we wanted to get the last element of the array. Now, supposing that we do not know the length of the array, we would write something like this. So array at the position of array.length minus 1. And that will then give us 64. So array.length is the length of the array, which is 3, but the last position here is position number 2, because the array is 0 based. So the indexes are 0 based. So 0, 1, 2. And so therefore, whenever we want to get the last element of an array, we always subtract 1 from the length. So this is quite a common scenario in JavaScript, and that's why there's also another solution. So another way is to use the slice method that we just learned before. So r.slice, and with this we can then get a copy of the original array. And here we can use -1 to get the last element of the array, right? So just like we learned in the previous lecture. So here we get that copy of the array only with the last element. So of course we want the value, and so then we need to take out that first value by doing square brackets 0. All right. So these are the two more traditional ways of solving the problem of getting the last element. However, as you can probably guess, the new add method makes this process even easier. So now all we have to do is to write r.add, and now here we can write the exact same negative indexes that we can write in the slice method. And so if we log this now, then here again we have 64. So the negative index, just like in slice, basically starts counting from the right side here, so from the end of the array. And so we could also write -2. So -1 and -2. So this should give us 11, and indeed, here is that 11. But most of the time, the thing that we're most interested in here is this -1 to get the last element of the array. And that's actually it. Now the only question is, should you use this new add method, or should you keep using the bracket notation? Well, as always, it depends. So if you want to get the last element of an array, or basically start counting from the end of an array, then you should probably start using the add method. Also, if you want to do something called method chaining, which we will talk about later in this section, then the add method is also perfect for that. So basically combining multiple methods all at the same time. And then it's quite helpful to use the add method instead of the brackets notation. Now, on the other hand, if you just want to quickly get a value from an array, so just like the first element, then of course you can keep using the brackets notation. And personally, I also do that all the time. So basically, if all you want to do is something like this, then you can simply keep using these square brackets. Okay. Oh, and by the way, I actually also wanted to let you know that the add method also works on strings. So let's log to the console a string, let's say Jonas, and then here we can also use the add method. For example, let's say at 0, and so that will give us J. And then, of course, we can also get the last character of the string by using at -1. In this lecture, we will loop over an array using the forEach method. Now, we had already learned how to loop over an array using the forOf loop, but the forEach method is really fundamentally different. And from now on, we will start working with our bank account data, but still in a very simplified way. So let me get this data here into the present lecture so that we can see what we're actually working with. So let me comment it out from here and just move it here. So let's say that we wanted to loop over this movements array in order to print a message for each movement in this bank account. So these positive values here are basically deposits, and the negative values are withdrawals. And so we can print something to the console saying whether the user deposited or withdrew some money. And let's actually start by doing this using a forOf loop, just so that we can then compare the forEach loop to this one. So let's create a variable movement of movements, and then we will log something to the console according to the movement value. So basically, if the current movement is greater than 0, then log to the console you deposited and then the movement, and else you withdrew and then the movement again. And actually we can use a nice math function here, which is to take the absolute value. So basically removing the sign. So let's see. And yeah, that looks nice. So of course this solution here works perfect. But now let's finally learn how to use the forEach method to achieve the exact same thing, but in my opinion, in an easier way. So to loop over the movements array, we use forEach, and that's with a capital E, don't forget that. And then the forEach method actually requires a callback function here. So forEach is technically a higher order function, as we learned in the last section, which requires a callback function in order to tell it what to do. So it's the forEach method here that will call this callback function. We are not calling it ourselves, as always. And that's, of course, important to keep in mind once again. But when exactly will forEach actually call this callback function? Well, what the forEach method does is to loop over the array, and in each iteration, it will execute this callback function here. Also, as the forEach method calls this callback function in each iteration, it will pass in the current element of the array as an argument. And so we can specify that here. And let's call it again movement. So again, each time this callback here is called, so in each iteration, it will receive the current element of the array as an argument. And here we can, of course, give this any name that we want, but I'm just calling it movement because that's what we did up here. And so now we can do exactly the same thing here in this callback function. Let's give it a save. And indeed, we now get the same result twice. So let me just add like a separator here for each. And so, yeah, indeed, we get the same result. Can also get ourselves more space. And yeah, so that's essentially how the forEach method works. So basically, behind the scenes, in iteration 0, it will call this function here. So an anonymous function in this case without a name. But let's just call it function. And it's going to call it with the value of 200. Then in the next iteration, it will call it with the value of 450. Then with the value of 400, right? And so on and so forth until it reaches the end of the array. And this part of the forEach function passing in the current element of the array, here like this, this, and this, is especially important to understand. So basically, this is exactly the concept that I explained in the last section when I said that we use a callback function to tell another higher order function exactly what it should do. And so in this case, we tell forEach that in each iteration, it should log one of these two strings here to the console. So we give the forEach method instructions by giving it a callback function which contains these instructions. All right? And I really know and understand that this is quite a hard concept to wrap your head around. But if you just continue using this from now on, then eventually it will start to make sense, believe me. Now, anyway, which of the two versions do you think is cleaner and easier to write and easier to read? Well, I think that we can both agree that it is the forEach method, right? And maybe you don't agree with that. And of course, that's okay. As I keep mentioning, it's always good to develop your own style of programming. But using the forEach method here, and especially understanding the logic behind it here with the callback function, is still really important for all the other methods that we're going to learn later. Anyway, let's now learn some more stuff about the forEach method, because we are not done yet. So what if we actually needed access to a counter variable here? So just like we can access the current index of the array here in the forOff loop. So remember how we did that with forOff. So let's just rewrite this part. So in this case, we loop over movements.entries, remember? So entries is in fact just another array method, and it returns an array of arrays, remember, which in the first position contains the current index and then the value itself. And so this is how we access the counter variable in the forOff loop. And then here in our string, we could use that to say, for example, movement, and then the number of the movement. So that's the counter which starts at 0. And so we just add 1 to that. And so, well, something went wrong. So that's in line 1 to 1. So unexpected token. Oh, and that's because we didn't open it here again. So we were missing this part here. And now this looks a lot nicer with the number of the movement here. And so let's now do the same in the forEach method here. And here, fortunately, it's a lot easier to get access to the current index. So to understand how it works, we need to remember once more that it is the forEach method who calls this callback function in each iteration. And as it calls this function, it also passes in the current element of the array. But actually, that's not all it passes in. In fact, forEach passes in the current element, the index, and the entire array that we are looping. And so, therefore, we can specify them here in our parameter list. So let's say index and array. Now, of course, we can just use one like we have been doing, or we can just use two, or we can use all three together. And as always, the names here do not matter at all, but what does matter is the order. So the first parameter always needs to be the current element, the second parameter always the current index, and the third one always the entire array that we are looping over. Because that's the order in which the arguments, so the actual values, are passed into our callback function. Okay, so now let's just copy this here so we can do the same here, give it a save, and here we called it index and not I. And in fact, in the real world, we actually use shorter names. So let's just call this one I, this one R, and this one here MOV, which is just a shorter abbreviation of movements. And so this is quite a common pattern to just abbreviate a little bit. So let's replace these three here with MOV. Give it a save, and now it does look the same as with the forOff method. But I hope you can see that it's a lot easier to get the current index here in forEach. Just notice that the order of the parameters is different in both these scenarios. So in forEach, the first value here is the current element, and the second one is the index. While when we use here the entries in the forOff loop, then the first element is the index, and the second value is the current array element. So just don't forget that here in this case. So always first the current element and then the index. Okay, and this is how we loop over arrays with the forEach method. Now, when should you use forEach and when should you use the forOff loop? Well, one fundamental difference between the two of them is that you cannot break out of a forEach loop. So the continue and break statements do not work in a forEach loop at all. So instead, forEach will always loop over the entire array, and there is nothing that you can do about it. So if you really need to break out of a loop, then you have to keep using the forOff loop. But other than that, it really comes down to your personal preference, just like so many other things in JavaScript. So every programming language always has many different ways or different tools to achieve the same thing. And especially as more things keep getting added to the language, there will always be more options to achieve the same result. All right, and with this, we wrap up this lecture. So, in my opinion, this is a really brilliant and powerful mechanism, but I know that it's also rather complex to wrap your head around this, isn't it? And it actually took quite some time for me to fully understand this myself. So back in the day. So please don't become frustrated with this. It will all become obvious with the practice. So just keep using this and then you will be fine. Once you do understand exactly how this works, so especially this mechanism of the callback and of the passing arguments into this callback here, so once you understand this fundamental mechanism, then working with all other array methods in this section will become really easy, because most of them follow the exact same principle of the callback function that we just explored here. So please review this lecture carefully, and yeah, if you really understand the role of the callback function here, then just move on to the next video. See you there. So we learned about the forEach method on arrays. However, forEach is also available on maps and sets. And so let's take a small detour now and see how forEach works with maps and with sets. And we're going to start with maps, and for that let's cut this currencies map that we have up here. All right. And remember that in this array of arrays, each of these array elements, so this inner array, will be one entry of the map, where this here is the key and this is the value. All right. And so we can call forEach also on a map. So forEach, and then again the callback function. And now this callback function also has 3 parameters. So when the forEach method calls it, it will call this function with 3 arguments. So the first one will be the current value. So the current value in the current iteration. The second one is the key. And the third one is the entire map that is being looped over. And so you see this is similar to the array, where in the array, the first parameter is the current element of the array, the second one is the index, and the third is the entire array. And so there's a nice correspondence between these. And so this is quite easy to memorize here. And so let's just log a very quick string here. So this is not really that important, but I wanted to show you that forEach also exists on these 2 new data structures. Okay, and indeed, it worked. So we got the key of each of the map entries, and then also the value. All right, and so now let's try the same with a set. So this is with a map, and this is now with a set. So let's create currencies unique, let's say. So new set. And remember that in here, we need to pass an iterable. And so I will use an array here. So let's just create a couple of strings here. Another US dollar, and then some euros. Let's just take a look. And indeed, it only has the unique values. So just as expected. And so let's now call forEach on this set as well. So currencies unique dot forEach. And now once again, the callback function has the parameters of value, key, and map. And we will see in a second if that actually makes sense. So let's log to the console. Actually, the same thing as here. So let's see what's going to happen. So remember, we are logging the key and the value. Okay. But now we get USD, USD. And here, GBP, GBP. And so what this means is that the key here is exactly the same as the value. So why is that? Well, a set doesn't have keys, right? And it doesn't have indexes either. And so there is no value that would make sense for the key. All right. So essentially this key here makes no sense at all. It wouldn't even have to be there. And so the people who designed this forEach method for sets, they could have simply omitted the second argument, right? Well, if they did that, then this forEach would have been different from the others. And so that would then create confusion in developers. And therefore it was decided to keep the same signature. So basically to keep the same 3 parameters in this callback function and simply to set the second one to the first one. So we can just write value here as well, just to avoid that confusion. All right. Oh, and of course, we cannot have the duplicate parameter name. And so we can just use an underscore, which in JavaScript means a throwaway variable. So that means a variable that is completely unnecessary. So it's just a convention, which we will see again a little bit later. Okay, and so now it should work. And yeah, that's all you need to know about the forEach method for maps and sets. So it's very straightforward if you already understood how it works for arrays. In this lecture, it's time to take a first look at the application that we're going to build in this section. We will also take a closer look at the starter files for this project, and we will also check out the flowchart for this application. So let's get started. And this is the application that we will build throughout this section and also the next one. So it's called Bankist, and this is here the demo version that is actually live on bankist.netlify.app. So I invite you to actually try out this application together with me as you watch this video, so to get a real good feeling for how it all works. Now this looks a little bit empty, and so you can just basically log in. So write JS, and then the pin is 1111. And so Bankist stands for Minimalist Banking. And so this is why we have this kind of banking, so an online bank interface. So we have all the movements here. We have the overall balance of the account up here. Then we have some summary data down here. And here on the right side, we have three options that we can do. So we can transfer money to someone else, we can request a loan from the bank, and we can close the account. So let's request a loan here. Let's say I need 1,000 euros. So I click here, and then after some time it is approved, and it appears here as a deposit. Okay, then I can also transfer money, and there is a user called GD, and let's say I want to transfer 5,000. So let's try that. And so now I have 5,000 less than I used to have. Finally, we can also sort these here. So now they are sorted, and now they are back to normal. And now let's go to that other account, JD, with the pin of 2222. And so let's check out if she has a deposit of 5,000. And indeed, here it is. We also see that this account here is in US dollars and with the American formatting, while the other one was in euros. And so that's something that we're going to take care of in the next section. But in this section, we will actually take care of displaying all of these movements, making these operations here possible, calculating the statistics, as well as the current balance. And so, yeah, I think it's going to be a lot of fun. And I'm really, really happy with this application. I think it looks amazing. It also looks like a real world use case. And yeah, overall, this is a great project for training arrays, because we can do lots of the stuff that you see here on the screen using arrays. Great. So now that you have a feeling for how this application works, let's take a look at a flowchart that I designed or that I built for this application. So here is that flowchart for the Bankist application. And just like before in the pig game, I built this one based on the flow of actions that we just saw in that live version of the Bankist application. So starting there in the top left, as the user logs in, which is one of these yellow actions. So all of these yellow elements here mean some sort of action. So when the login action is performed, we check for the correct credentials, and if they are correct, we display the UI, and then we also update the UI. And so that means to calculate the balance, calculate the summary, display the movements, and then later on in the next section, we will also start and display a logout timer. So all of this here happens right at the beginning as the user logs in. And so actually this part in the beginning here, everything that is inside the update UI will be the first thing that we will do. Okay, then from there, we will implement the kind of fake login, and then we will take care of these other operations. So probably we will come back to this flowchart by then. But anyway, this is already a very good overview of all the steps that we have to implement in order to build this application. And you can spend some more time on this and actually compare it to the functionality of the application. That's why, one more time, I included this flowchart in the starter files of this section. Now this time, just like in the pig game, I built this flowchart myself because all that matters here in this project is to build this application and learn all about arrays. But in the next big project, we will actually plan the entire application together, and I will show you all the steps that we have to go through in order to come up with a flowchart like this. So don't worry about designing a flowchart just yet. We will learn how it works and how to plan an application from the ground up. But for now, again, my purpose with this flowchart is just to give us a good overview, so a good roadmap to actually go ahead and implement all the features of this application. And so then whenever we get lost, we can always just come back to this flowchart and see exactly how the application works and what we have left to implement. Okay, but with that being said, let's now go back to our code editor and take a closer look at all the starter files that we have there. So right at the top of our script, we have these 4 account objects. Okay, and so this one here was the JS that I just showed you in the demo. And so here then are the movements stored in that object. We also have the pin, and later on we will also use this interest rate. Okay, now of course in the real world you would want much more data about each of the movements, not just the value, right? For example, we would use the date of each movement, maybe a description, and so on. But here we really just want to work with arrays. And so I'm keeping it very simple, but still at the same time fun to build. Okay? So yeah, so one object for each account. And you could ask, why not use a map instead of an object? Well, the thing is that we're going to pretend that all this data is coming from a web API. So a little bit like we talked about earlier. And whenever we get data from an API, this data usually comes in the form of objects. And so this is why we have objects here. And then finally, an array containing all these account objects in there. Remember that this is one of the most common ways of organizing data in JavaScript applications. And so that's why we are going to use it throughout this section to make this actually feel a bit more like a real-world application. All right. So that's the data. Let's take a look here a little bit at the other files. So as always, we have the prettier configuration. Then here's the flowchart that I just showed you. And so here you can take a look at it by yourself. Then the index.html, and this one is a lot more complex now, and we will actually need it to take some code out of there. Then here we have the icon and the logo. So like this icon you see here in the tab, so the fav icon. And finally we have the style. And so here you can have some fun and learn some CSS if you're interested in it. So it's almost like 300 lines of code, I think, that I built to style this application. So you see, I really put a lot of work to make this application really fun. Okay. So I think that's it for the starter files. Just notice that I already selected all of the elements that we're gonna need. So you see, it's a lot of stuff, and I'm gonna explain what each of this is. But what matters is that this way, we don't have to write all of this code ourselves. And so this makes development a little bit faster. So a lot of elements here. And yeah, so I think that's it for this video. I think you got a good overview of this project for this section. And once again, please go ahead and take a look at this URL by yourself and use user.js and pin 1111. And then when you're familiar with how the application works, then let's move on. In this video, we're finally going to be back to DOM manipulation. And we're going to learn a couple of DOM manipulation techniques, and we will use them together with the forEach method that we just learned about. So this is really exciting stuff, so let's get started. And to start, let's actually open up the HTML and CSS files, and we will then keep them open here throughout this project. And I like to have the script always the last. Now in the HTML, we have this navigation bar, so this nav element, which is all of this top part. And then after that, we have the main element. And so that's basically the entire application. And that part is right now invisible. And so that's because here in the CSS, so in line 87, we have the app selector and the opacity is set to 0. And so we need to comment that. And for that, we can, as always, use command / give it a save, and then we can finally see the application here. All right. So logging in and out of this application is essentially just changing this opacity here. And so now the opacity is basically back to 100 because now we commented it out. And so 100 is the default. But anyway, let's go back to our script here. And so what we want to do now is to basically display these movements right here in the application, here in this list. So in this container. So for each movement, we want one element like this. Okay. And we will be able to do that because of the forEach method, which will allow us to loop through this array, and then in each iteration, basically create an element like this and display it on the page. So this time, we're finally going to move away from the console and actually do some DOM manipulation here. All right, so let's move down here after these elements, but still inside of the app part of this file, and then let's write our code. Now we could simply start writing our code out here in the global context. However, that is not a good practice. So whenever we do something like this, it's always best to create a function. So let's call this one print or a display. I prefer display. So display movements. And then we make this function receive the data with which it should actually work. So in this case, that's the movements. So we call this parameter movements because this function should receive one array of movements and then work with that data. So in this case, that's the movements that it should display in the user interface. All right. And so it's a good practice to pass the data into a function instead of, for example, having this function work with a global variable. That would work as well, but it's a lot better to pass that data directly into the function. Okay, so get used to that kind of approach. All right. So again, instead of working with global variables, start passing the data that a function needs actually into that function. So let me, as always, call this function first to see what we will get as an input. And so the movements that I will use here will come from this account1. So essentially, that's going to be this array. So account1.movements. So account1.movements. Okay, and so inside of this function, these movements are simply called movements. And so now let's loop over these movements using what we learned before. So forEach, and then our callback function here. Now inside of this function, we need the current movement, and we also need the index. And that's because here actually I have them here number 1, number 2, and so basically we have the movements numbered like this. Okay, so starting with the first movement down and then adding the new ones on top. Okay, all right, so that's the easiest part. now we have to essentially create an HTML that looks like this. So let's go to our HTML file and to actually take a look at what this HTML looks like. So we are inside our app element here, basically. Then we have this movements element, which is all of this container here. And maybe it would be easier to actually see this in the console. So if we did this, maybe we can get rid of this part. Not really. But anyway, now we can see that all of this is the movements. And then in each movement, we have a movements row. So each of this is a movements row. Okay. And so let's now copy the entire code of one movements row, because this is what we want to create in each iteration of the loop with the current data. So essentially, let's take all of this. So I'm going to copy it. And let me now paste it here into a template string. So I will create a variable, which I'm going to call HTML. And then I'm creating a template literal. And template literals are amazing for creating HTML templates like the one we will create now. Because now it's really easy to create a multi-line string like this. Okay, let's just fix indentation here a little bit to make this then easier to understand. Okay, and now all we have to do is to basically replace the data that is not relevant, so this hard-coded data, with our actual movements data. Okay, now this part here of the date we will not do now. We will take care of this in the next section. So let's get rid of it. And then here we have the movements value. So this is formatted, but again, we will just use the plain value that's coming out of the array for now. And so now we can simply insert that here. And so that's mov, right? So mov is the current element in the array that we are looping over. And so in each iteration, that will then be one of the movements in the array. Then here we have to deposit. And so we will have to check whether a certain movement is a deposit or a withdrawal. So let's delete that. And for now, we can add the number here. So you see 1, 2. And so for that, we now use the I. And so that's why we also needed the current index besides just the current value. Okay. And now we need a way to knowing if it's a deposit or a withdrawal. And so let's use a ternary operator, and let's do that out here as a separate variable, because we will need that twice. We will need it, one, to write it here on the user interface, but here also this class name depends on that. So you see that we have type deposit, so that's then this green color, and we have type withdrawal, and so that's then this red color. So we will need this information twice. And so let's just calculate it outside here. So I'm going to call it type. And so this is the same logic as before. So if the current movement is greater than 0, then the type should be deposit, or else it should then be withdrawal. Okay. And now let's write that here. So the type here, and again also here in the class name. So we can also basically construct this class name here, which is very useful too. And I hope here you can see that the template literal is really a lifesaver here. Okay, so we created our HTML template here. Now all we need to do is to find a way to actually adding this HTML onto the web page here. So we need to attach this HTML somehow into this container. So into this movements element. Okay. And to do that, we will use a method called insert adjacent HTML. So that's gotta go right here. So let me first write the name of the method, and then I'm going to tell you where we actually have to attach this method to. So it's called insert adjacent HTML. And we are going to call this method on this movements element here. So this container onto which we want to add a new movements row element. So this element here on which we want to add a new movements row, right? So we are looking for an element with the class of movements. And as I told you in the last lecture, I already selected all of these elements. And so in this case, it's this one. And so the name is container movements. Okay. So you see that I used kind of uniform names here. So I have container app for this entire application container and container movements. Then all the other ones are called label, so label welcome, date, and so on and so forth. Then the others are called button, and then all the input fields are all called input, and then whatever the name of them. So to keep it nice and easy to understand. But anyway, this one is called container movements. And so onto there, again, we call insert adjacent HTML. And this method accepts two strings. The first string is the position in which we want to attach the HTML. And this one I'm going to set to after begin, but there are more options. And I think the best way of showing it to you is actually in the documentation. So MDN. And so whenever I need to figure out something, this is how I do it. So I know that down here there is a visualization. And yeah, so these are the four options here. And the one we chose is after begin. So that's this one. So imagine that this P element here is our container movements. And so basically I want to add new elements right after the beginning of this element. And so basically I'm saying here that I want to insert the new child element right after the beginning of the parent element. So again, that's container movements. Then we have before end, which is at the end of the element, as the name says. And then we can even put it outside of the parent element. And then we could even put it outside of the container movements. And sometimes this is useful as well. But usually I always use after begin or before end. And once we see the result, I will explain a bit better why it is after begin and not before end. But anyway, let's go back here because now we need to specify the second argument. And that is the string containing the HTML that we want to insert. And that's it. So if we now run this, it should already work. And yes, it does. So that's amazing. And let's check it out. And let's compare it with our values. And so indeed, the newest one is the last one here. And so that's element number 8. And it is indeed 1300, right? And it is indeed green because it is a deposit. So a positive number. The same with the 70. And then we have minus 130. And so indeed, that's a withdrawal. Beautiful. Now, if we scroll down here, we will see that we still have these two old ones. So basically the two that were already there. And that's because all we are doing is to add new elements to this container. Right? We are only inserting new HTML here inside of the container movements, but we are not overriding anything. And so actually that has to be the first thing that we do. So the first thing is to essentially empty the entire container, and only then we start adding new elements. So that's something common to do, and it is also not difficult at all. So container movements, and now we can use the inner HTML property, inner HTML, and set it to the empty string. And that's it. So this fixes our problem. All right. Now inner HTML here is a little bit similar to text content. So remember that. Now the difference is that text content simply returns the text itself, while HTML returns everything, including the HTML. So all the HTML tags will be included. Okay. But here we are then using inner HTML as a setter. So just like we also used text content equal empty string or equal something else. Remember? So we used to do in our pick game, for example, like whatever and then text content and then set it to 0. Remember that? But as I said, we can also use this to read data. So let's simply log to the console just to understand this property, which is pretty important. So after all this, let's do container movements.inner HTML. So we're simply reading the inner HTML and then logging it to the console. So console, and indeed, here you see all of this HTML. All right. So essentially, that's the HTML that we just created. Okay. But let's get rid of this. I just wanted to show you both sides or both applications of inner HTML. All right. And finally, I wanted to show you why I used after begin and not before end. Well, let me show you what would happen with before end. I think this is how it works. So before end. Yeah. So with that, the order of the movements would be inverted. Okay. And that's because each new element would simply be added after the previous one. So at the end of the container, right? And so that's after all the child elements that are already in there. And that's why I wanted it to be the other way around. Because like this, it will always be basically appended to all the other children. So any new child element will appear before all the other child elements that were already there. And so now we are back to the order that we wanted here. All right, that's amazing. So we completed the first part of our user interface here already, and all with the power of the forEach method. And then also we introduced some new concepts. In particular here, the insert adjacent HTML method, and then the inner HTML property. Now, there are many other ways of creating elements in JavaScript besides this one here, and we're going to study all of them in great detail in a future section. But this here is actually the one that I like the most. It's the easy, quick and dirty solution, so to say. So all we have to do is to create a string of HTML, and then we can insert that simply with this method. So very simple, very straightforward. So this is some great DOM manipulation that we did right here, and I'm really happy about the result that we got here in our application. Great, so let's now move on. Welcome back to the first coding challenge of the arrays section. And in this one, Julia and Kate are doing a study on dogs. So each of them asked 5 dog owners about their dog's age, and then they stored that data into an array. And that's one array for each of them. All right? And in this study, they are interested in knowing whether each of the dogs is an adult or a puppy. And the rule is that a dog is an adult if it is at least 3 years old, and it's a puppy if it's less than 3 years old. And by the way, the test data here, so the arrays for each is down here, so test data 1 and 2. All right. So your task is to create a function called checkDogs, which accepts these 2 arrays and does the following things. So first, Julia found out that the owners of the first and the last 2 dogs do actually have cats and not dogs. So here, what I want you to do is to create a shallow copy of Julia's array and then remove the cat ages from the copied array. And you should copy it because it's a bad practice to mutate the parameters or the arguments of a function. Then, second, create an array with both Julia's and Kate's data. So for Julia, of course, the corrected data. And then for each of the dogs, simply log to the console whether it is an adult with a string like this or a puppy and then with a string like this. And that's of course according to the rules in the beginning. And then just run this function for both test datasets. And that's it. So all you need to do is to use the tools from all the lectures in this section so far, and then I think you will be fine solving this on your own. So this is really all about using the tools that we already learned before, and there's not a lot of new thinking to do here. So I hope you managed to do this one, and I see you back here in a second. All right. So hopefully you did this just fine without any problems. But I will anyway write my solution here and explain what I'm doing. So we accept the docs from Julia and the docs from Kate. And we will call this with the test data. And so Julia's data is this. And there's not a need to store them in separate variables. I will just call the function like this. All right. And now we should create a shallow copy of docs Julia so that we can then remove some elements from there. So docs Julia corrected dot slice. And so I'm using here the method and not the spread operator. And now I will simply remove some elements from there. So docs Julia corrected dot splice. And so it tells us that the first and the last two docs are not valid, basically. So the first is element number 0, and then we want to remove 1. So that's the first part. And then docs Julia corrected dot splice, and then the last 2, which is -2. Okay. So let's take a look here simply at docs Julia corrected just to see if this is correct, actually. So we need the console now. And so this was our beginning data. And indeed, the first and the last 2 are gone here. All right. Now, of course, you could have also done this in a different way, which is to simply copy the correct data from the original using the slice method. So something like this. Docs Julia dot slice. So starting from the second one and then all the way to the third one. Okay, and so this would give us the exact same result, but in this case, I just wanted to use the splice method. And in fact, I wanted you to use the splice method as well, and that's why I gave you that task like that. Anyway, we don't need this here anymore. Let's now simply create a new variable with both these docs. So simply calling it docs. And again, we could use the spread operator here, which I actually prefer. But since we are in the arrays section here, let's do everything with array methods. So that's the concat method, remember. And then we want to join the corrected Julia docs with docs Kate. So always a good idea to check. And yeah, that's correct. All right. And so all we have to do now is basically create this string. Let me just copy the string. And so looping over this array is now an easy task, hopefully. So dogs.forEach, then the callback function, and one more time, we need actually the current element and also the index. And that's because here is the number, so dog number 1, and it's going to go all the way to 7. And so let's check out our rule. So a dog is an adult if he is at least 3 years old. So if dog is greater equal 3, then log a string like this. So here is the index plus 1. Here goes the dog itself. And then else is still a puppy. And here we need just this. And I think with this we are good. Let's just remove this. And yes, dog number 1 is 5 years old, so it's still an adult. Number 2 is 2 years old, so still a puppy. This is again a puppy with 1 year old. And so, yeah, that's the correct solution. Now let's just do it for this test data here. Then I'm gonna duplicate this one. Let's just comment out the first one. And okay, here we only have one puppy, which is the one before the last. And so this one is correct as well. And so, challenge completed. In JavaScript, there are 3 big and important array methods that we use all the time to perform data transformations. So basically, these are methods that we use to create new arrays based on transforming data from other arrays. And in recent years, these tools have become really popular, and for good reasons, and therefore you will see them everywhere you look in modern JavaScript. And the tools I'm talking about are map, filter, and reduce. So these are 3 array methods, and in this lecture I'm going to give you a quick overview of them. Then, over the next couple of lectures, we're going to dive deep into these 3 methods in practice so that we can use them throughout the rest of the course. First, the map method is yet another method that we can use to loop over arrays. So map is actually similar to the forEach method that we studied before, but with the difference that map creates a brand new array based on the original array. So essentially, the map method takes an array, loops over that array, and in each iteration, it applies a callback function that we specify in our code to the current array element. So in this example, we say that each element should be multiplied by 2. And with this callback in place, the map method multiplies every single element by 2 and puts it into a new array. We say that it maps the values of the original array to a new array. And that's why this method is called map. And it is extremely useful, usually way more useful than the forEach method, because forEach simply allows us to do some work with each array element. But map, on the other hand, builds us a brand new array containing the results of applying an operation to the original array. Alright, and we will use the map method in practice right in the next video. Anyway, next up we have the filter method, which, as the name says, is used to filter for elements in the original array which satisfy a certain condition. So in this example, we're only looking for elements greater than 2. So only elements that pass the test that we specified will make it into a new filtered array. Or in other words, elements for which the condition is true will be included in a new array that the filter method returns. All other elements will get filtered out, so they will not be included in the new array. And finally, there is also the reduce method, which we use to boil down all the elements of the original array into one single value. And an example of this can be to add all the elements of an array together, but we can also do many other interesting things. So for the example of adding up all numbers in the array, we need to specify an operation like this one, where we have an accumulator variable. Then, as the reduce method loops over the array, it keeps adding the current element onto the accumulator until, at the end of the loop, we have the total sum of all the elements. So you can imagine this as a snowball that keeps getting bigger and bigger as it rolls down a hill. And so this is known as the snowball effect, and reduce is pretty similar to that. Okay, so keep that in mind as a nice analogy. Now we also say that this whole process has now reduced the original array to one single value, which in this case is the sum of all the elements, but it can of course be many other operations. Now it's this value that then actually gets returned from the reduce method in the end. So there is no new array in this case, but only the reduced value. Now this probably sounds more complicated than it actually is, and so let's start to put it into practice right in the next video. Let's now start seeing the three data transformation methods in practice, starting with the map method in this video. And as we just learned, the map method is yet another way that we can use to loop over arrays. But unlike forEach, the map method will give us a brand new array. And this new array will contain in each position the result of applying a callback function to the original array elements. So let's see how that works. And let's start by bringing back our movements array here. So this one, so we will once more work with these movements. And in this one, we will try to convert them to US dollars. So let's suppose these movements are in euros, and we now want to convert them to US dollars. And let's suppose that 1 euro is worth $1.1. So let's just store that conversion rate here first to a separate variable. So euro to USD is 1.1. And so now what we want to do is to basically multiply each element of the movements array by this 1.1. So let's say movements.map, and then just like in the forEach method, we need a callback function. And this callback function also gets as an argument the current array element. So again, just like in the forEach method that we studied before. And that's why I said back then that once you understood the forEach method, all the other methods will then become a lot easier to understand. So let's call this one here mov one more time. And then here in the callback function, we need to return the value that we want the new array to have in the current position. And so in this case, we want the original array times the euro to USD conversion rate. And this will make sense when we now see this result. And so let's actually store it to a variable. So we already know that the map method will return a brand new array. And so we need to store that somewhere. So let's call it movements USD. And then let's log both to the console movements and movements USD. Give it a save, and sometimes we need to reload the page as well. But anyway, here is the result. Now, never mind these multiplication errors here. I will explain you a little bit later where they come from. But essentially, this new value here is now 220, which is exactly 200 times 1.1. And so indeed, we ended up with a new array containing all the movements, but converted from euros to US dollars. And again, that's because that is exactly what we returned here from this callback function. We could, of course, have returned simply something else. So we could have returned simply 23. And so what do you think we will end up in this situation? Well, we now simply have an array of the same length, which in each of the position contains 23, because that's what we returned from the callback function. And so in each iteration of the original movements array, it simply put 23 into the new array at the same position. But of course, that's a little bit useless, and so let's go back to the example that we're working with. Great. And of course, you can also see that the original movements array was not mutated at all, right? And so indeed, the map method really only returns a new array with the new elements. And this really is the fundamentals of how the map method works. So we can use this, and we will use it in all kinds of different situations. Now, just for fun, let's write the same thing here using a for-off loop. So we can create another mov, and then we are looping the movements, of course. And so in this loop, we want to create a new array. And so in this case, actually, we first need to create that new array. So let's call it again movements USD, but then for. So here we first need to define that empty array. And then as we loop over movements, we keep pushing a value to the new movements USD for array. So push and the current element times euros to USD. Let's log that as well, and it should look exactly the same. And in fact, it does. And so, yeah, we could have written this here, and it doesn't look too bad either, but it's a completely different philosophy. So here, in the map method, we use a function to solve this problem of creating a new array. While here, we simply loop over one array and then manually create a new one. So these are completely different philosophies, or we can also say paradigms. So this here is more in line with functional programming, which is something that I have mentioned a couple of times in this course, and we will talk about it later in greater detail. And in modern JavaScript, there's definitely a push going on in the direction of functional programming, so of a more functional language, and therefore in modern JavaScript, this here is the way to go. So using methods together with callback functions like this is the new and modern way of doing stuff. All right, but now let's actually make our callback function here look a little bit cleaner. So this callback function, we can simplify it greatly. So do you remember arrow functions? We could perfectly use an arrow function here and simplify this here into just one line of code. So here is my challenge for you. Do you think that you can do that yourself? So basically replacing this callback with an arrow function. Take a minute and see if you can do that for yourself, and I'll see you back here in a second. So let's just copy this and then replace this by parts. So first we can remove the function keyword and then replace it with an arrow. Then we can also remove these parentheses here because there's only one argument. And finally, since we only have one line of code, we can remove the curly braces, and we can even remove the return statement. And so this code that we have here now is exactly the same as before. So we can comment out this one here. And of course, I'm leaving it here for reference. But as I save it now, you see that the result is exactly the same. And so here we now have a nice and clean one-liner callback function, just like this. However, many people don't like the way that this looks. So they argue that this lacks the function and the return keyword, which they say leads to bad readability and that it makes this whole thing more difficult to understand. And while I can see that that might be true, I actually do prefer the fact how much smaller and cleaner this code is. So in my opinion, if you understand well enough how the arrow function actually works, then you will become familiar with this pretty quickly. And so then there is no problem in writing code like this. Okay? The main thing that you need to keep in mind is that here we are actually returning this value. So you need to remember that this is like writing return here. And so if you understand that, then you're good to go. So I will actually use arrow functions in these situations in the rest of the course, because I believe that they are perfect for these small callback functions. In my opinion, they were really developed for this kind of application. But as always, if you do prefer the regular function syntax, then please feel 100% free to keep using them instead. And with that being said, let's now experiment a little bit more and explore the map method some more. So just like the forEach method, the map method also has access to the exact same three parameters. So besides the current array element, which is this one here, we also get access to the current index as well as the whole array. So let's now use the map method to loop again over the movements array, but this time we're going to create a string similar to the ones that we printed to the console earlier using forEach. So let me actually get that logic. And so it's this one here. So let's specify a callback function. And indeed, now I will actually use an arrow function. And so, as I said, we get access to the current element, but also to the index and to the entire array. This time we do need a block, at least for now, and then here we have our logic. Now, in this case, we will not log something to the console. So instead, we want to return the string so that it then gets put into the new array that results from the map method. So let's say here, movements descriptions. So that's a long name. But anyway, again, here we do not want to log something to the console. So we don't want to simply do something with this value like we do when we console.log. Instead, we really want to return it. And so that will then place this value into the new array. So let's save that. Let's then also log this to the console, movement descriptions. And so indeed, we get this array with these strings that we previously logged to the console. And by the way, it's completely acceptable to have two return statements or even more in the same function, as long as only one of them is executed, right? So in this case, either this one here is executed or this one. It's impossible for both of them to return at the same time, right? And actually, we can even simplify this whole thing here, because these two strings are essentially the exact same thing, except for this word here. And so let's do something else here, right? Now you also have this math.absolute value, but if the value is already positive, as it is here, then that simply makes no difference. And so let's use a ternary operator here to put either withdrew or deposited right here. And so this has nothing to do with the map method, but yeah, it's a good way to also keep practicing the other skills that we have been learning. So we can check if the movement is greater than 0, so the same condition as here, and if it is, then at this part of the string, it should say deposited. And if not, well, then it should say withdrew. And so like this, we built this string all in one go. And so we can get rid of this, we can get rid of this, and so therefore we don't need the return keyword anymore. And so it works just the same. Okay, now in this case, we don't need this array here, so let's actually also get rid of it. And it's a good idea to keep in mind why we actually get access to these two parameters here. So one more time, all we do here is to pass this callback function into the map method, right? But we do not call this function by ourselves. It is the map method who will call this function for each of the array elements in the movement array. Okay? Now, each time that the map method calls or callback, it will simply pass in the current array element as well as the current index and the whole array. And of these three, here we are only using the first two, just the current element and the current index. All right, and with this, I hope that by now it is really crystal clear how this all works. Now you could say that what we did here with this map method is essentially the same as what we did with the forEach method. But in fact, there is a big difference between these two approaches. So before, we printed each line individually to the console as we were looping over the array. So in each of the iterations, we performed some action that was then visible in the console. And we can call this a side effect. So the forEach method creates side effects. But now, here with this map method, all we did was to return each of the strings from the callback. And so basically they got added into a new array. And then finally, we logged that entire array to the console and not the elements one by one. And so here, in this map method, we did not create a side effect in each of the iteration. All we did was to build a brand new array. And this idea of side effects will become important again as we talk more about functional programming. Great, and this is how the map method works. In the next video, we will see a more practical application of it in the context of our Bankist application. Let's now use the map and the forEach methods to compute usernames for each account owner in our application. So we have these 4 accounts, and for each of them, we want to basically compute a username. And the username is simply the initials of each of the users. Okay, so let's just start with one of them, just with one string to make it really easy. And then we will generalize that function for the entire accounts array that we have down here. So which contains all of the accounts. But for now, I will just grab this string here and create a username for this one. So let's do that down here after this first function that we created. And for now, we will do this outside of a function just to see how it works. And then afterwards, we will create a new function. So let's say the user is this one here, and we want to compute the username. So for this one here, the username should be STW. So that's just the initials in lowercase. And so let's do that. So we start by transforming this string to a lowercase. So we already know how to do that. And now we simply want to take the first letter of each of the words. All right. And so we need to basically split up this string into the multiple words. So this is a very common use case for the split method. So dividing by spaces, which will divide the string into words. And let's just take a look at what we have now so that we can discuss our next move here. So username. And so right now we have Stephen, Thomas, and Williams. And so how do we take each of the first letters here? Well, we could simply loop over the array and then take the first letter in each iteration and add them into a new array. And then in the end, we would join that array and we would end up with just a string of STW. Okay, so let's do what I just said. So looping over this array, taking the first letter and then putting it into a new array. And that is exactly what the map method does, right? Now we can do that directly here because this split method here returns an array. And we can then call the map method on that resulting array. So we can immediately do .map here, just like we can call the split method on the result of the toLowercase method, because this one here returns a string and split is available on all strings. Okay, so let's define our callback function here, and I will start by doing it with a regular function. And so here, let's say we get a word or a name. It doesn't really matter here. And so in each iteration, what we want to do is simply to return the first letter. So that's name at position 0, right? And so right now, this should be an array with only these 3 initials. So let's see. And yes, beautiful. That worked just fine. And so the result of this here, of this whole thing, is now an array. And on an array, we can call the join method. So .join, and simply by an empty string, and this will give us the final result of STW. All right, great. Now let's simplify this callback function here. And again, I will start by deleting the function keyword. Then we can also delete the curly braces. And finally, also delete the return. And so see how simple this has become now. So we transform name to name at the first position. So just the first character. And one more time, don't forget that this is actively returning here. We just don't see it. Okay, but the return is happening. And this is the reason why this works. Because the callback function in the map method always needs to return the new value that should be in the new array. All right, so this works great with this username. Let's now take this actually into a function. So I'm cutting it here. And let's say create usernames. Create a function. Add this here, and for now, let's say we get the user in here. And so now we can call the function with this string. Oh, and here I called console.log instead of create username. Okay, and yeah, if we want to see the result, we would also have to log it to the console now. So of course, first returning the username and then log it to the console here as well. And so indeed, we now get the same initial that we had before. But now we actually want to compute one username for each of the account holders in our accounts array. All right. So to do that, should we use the map or the forEach method? Well, we do not want to create a new array in this situation. All we want to do is to modify the objects, so the elements that already exist in the accounts array. So in this array here, right? And so what we want is to simply loop over this array here and then do something. And so for that, we use forEach. All right. So let's modify this function here some more. And instead of simply receiving one user, what we want to do is to receive all the accounts. So basically an array of accounts. And this goes back to the philosophy I explained to you in the last lecture, which is that each function should actually receive the data that it should work with instead of using a global variable. So that's exactly what we did here with the movements, which we could have read directly from the global variable of account1.movements, for example, but instead we created a function that receives that data and can then work with that data or with any other data that we choose to pass into it. And so here we are doing the same. We do not want to rely on the accounts array that we already have, but instead we want to pass it into the function. Let's get rid of all of this. And so what I mean is to actually pass the accounts array in here. And here it doesn't have to be called accounts. Let's just call it like this as an abbreviation. Okay, just to remove a little bit the confusion that you might have. Okay, and now as we were saying, we need to use the forEach method here because, again, we do not want to create a new array. We simply want to modify basically the array that we get as an input. And this is a really important distinction to keep in mind. So here we are again talking about the side effects that I mentioned in the last video. And in this case, the side effects are going to be to change, so to mutate the original accounts array. And so that's what we want to do here. And so forEach is the way to go. So for each account in the accounts array, so I'm just calling this ACC, which is again an abbreviation for one single account. So for each account, we now want to do this here, basically. So let's grab all this. We can remove this. And so let's create a new property on each of the account objects. So account.username, and that will be equal to user.owner, owner. And so let's check out why that is. So each of these accounts has the owner property. And so that's where the name of the owner, so of the user, comes from. So we take that, so account.owner, and create our username from that. Okay, so that's what we do here. And then we create a new property on that account element. And yeah, and that will then contain the username that we create here. Okay, here we have some kind of error. And of course, it's not user, it is account.owner. And now that's it, right? And in this function, we do not return anything because, again, what we're doing here is to produce a side effect. So we are doing something to this account object here, and so there's no need to return anything. We are just doing some work here, basically. We are not creating a new value to return. Okay? Now, if we want to see if this actually worked, we can log this accounts object or this accounts array to the console. And so in there, we should now see our objects with a new property. And indeed, we get the username of JS. And this one should be JD. And here our Stephen Thomas Williams. And indeed, it is the STW that we had previously worked with. Okay? So in this lecture, it was very important to understand the use case for the map method here, which was perfect because it allowed us to create a new simple array which only contains the initials of whatever name it is used on. And then, on the other hand, the forEach method was a great use case to produce some so-called side effects. So in other words, to simply do some work without returning anything. And so that's what we did here. We simply looped over the accounts array, and in each iteration, we manipulated the current account object and added a username to it based on the account owner, plus all of these transformations that we had already done before. So a couple of interesting and important takeaways from this video. So make sure to review it properly, and then let's move on to our next transforming method, which is the filter method. Now let's learn about the filter method, which, as we learned before, is used to filter for elements that satisfy a certain condition. And how do we specify such a condition? Well, you guessed it, we use a callback function again. So let's again work with our movements. And so now the filter array. And once again, I will start with a regular function. And just like the other callback functions, like in map and forEach, this one also gets access to the current array element as well as the index and the entire array. But let's only work with the current element here, which in filter is usually all that we need. Okay, now what we want to do here is to create an array of the deposits. So let's actually write that. So deposits, and deposits are only the movements that are above 0. So we already know that, right? Let's indeed take a look at the movements here. So here there are, and so we want to filter out these negative values. And so that condition is so that only the values that pass the condition will then make it into the new array. And passing that condition means that it's true. So we will again return something here. And here the trick is that we return a Boolean value. And so in this case, all we need to do is to say the current movement greater than 0. And that's it. And so now only the array elements for which this condition is true will make it into the deposits array. All the other ones will simply get filtered out. So they will not be included in this deposits array. Okay, and in fact, we only get the positive values now. Beautiful. And that's actually it. That's really simple, right? So just as I told you, if you know how to use the callback function correctly, and if you know how and why it works, then all of these methods become really, really simple. And once more, I also want to use the forOff loop here again, so that you can appreciate the difference. And that's very simple. So we need, of course, the same condition. So if the current movement is greater than 0, then we want to push the current element into a new array. So we need to create that here, deposits for, and start again with an empty array. And so in this case, we simply push it there. So we push the current movement. And so let's take a look now. And as expected, we get the same result. And so you could again ask, what is the big difference here? Like, what's the big deal? And why not just use the for loop for everything? And the reason for that is, again, the push that exists in JavaScript for using more functional code like this. But there's also a more practical implication here. And that's because we can actually chain all of these methods together. So basically use them all one after another to build a big final result. So a bit similar, in fact, to what we did here in our application right here. But here we mixed string methods with array methods. But later on, we will do like big chains only with array methods. And that would be completely impossible using the for loop. So that's another big advantage of using the methods instead of the regular for loop. Now, anyway, I have just another small challenge for you here, which is to create an array of the withdrawals. So withdrawals like this. So I want you to create this array without looking at the code we already wrote. And so the withdrawals should only include the negative numbers here. So pause the video now for a minute and please try to write this code on your own. Okay, so hopefully you did that. And so it is movement and again dot filter. And now I will use an arrow function here. So I will leave this one with the regular one and now an arrow function. Okay, and now mov less than 0, and that's it. This is our condition, and never forget that this one is actually returned here. So again, it is like having return written here. And so this is why this works. Let's log it to the console. And yeah, only the negative numbers remain now. All the positive ones got the result of false here in this condition, and so therefore they were not included in the withdrawals array. And again, these callback function here also get access to the current index and the whole array. And I will just leave it here, but I never used these in my life ever in the filter method. Okay, so this was the second of the data transformation methods. So that's map, filter, and reduce. And so in the next video, we will then talk about reduce. In this video, we're going to talk about the third data transformations method, which is the reduce method. And as you remember, we used the reduce method to essentially boil down all the elements in an array to one single value. And we talked about the example of adding up all the numbers in one array, right? And so let's try that now with our movements array. And remember that array looks like this, okay? And then by adding up all these numbers, so both the deposits and the withdrawals, we end up with the global balance of the account, basically. So let's start using the reduce method here. And so as I just said, we're going to call it on the movements array. And the result of the reduce method will be, as I just said, the global balance of the account. So let's call the result balance. And remember that in this case, this balance will be simply one value and not an entire array. Okay, so the reduce function also gets a callback function, but this one is a little bit different from the other ones, like the one in map or forEach. So in these other callbacks, the first parameter is always the current element of the array. Let's call it current. The second one is the current index, and the third one is the entire array. But here in the callback function of the reduce method, the first parameter is actually something called the accumulator. So let's call it ACC like this as an abbreviation of accumulator. And this accumulator is essentially like a snowball that keeps accumulating the value that we ultimately want to return. So in the case of adding all the elements or all the numbers of an array together, that will be the sum. So let me write that here. Oops. So let me write accumulator is like a snowball. All right. But anyway, let's now write the actual function block here. So as always, this callback function here will be called in each iteration of looping over the array. So reduce also loops over the array and calls this callback in each iteration. But now what will we actually do in each of these iterations? Well, since the accumulator is the value that we will keep adding to, what we're going to do here is to add the current value to the accumulator. So the accumulator plus the current value. Okay? And this works because in each call of the callback function, the accumulator will be the current sum of all the previous values. And so we will really keep adding to this accumulator in each iteration of the loop. Finally, we also need to return this value here from the callback. And so this is how the new accumulator can then be used in the next iteration of the loop. So basically, in each loop iteration, we return the updated accumulator, so the current one, plus the new current value. And so like this, we can then keep adding to it in the next iteration. Okay? So this callback function is the first argument of the reduce method, but the reduce method actually has another, so a second parameter. And that is the initial value of the accumulator. So the value that we specify here, which in this case is going to be 0, is the initial value of the accumulator in the first loop iteration. And so in this example, we want to start counting, or we want to start adding at 0. And so therefore, we simply specify 0 here. Okay, and with this, we should be able to already take a look at our balance. And yeah, so we have one single number. So indeed, everything was reduced, was boiled down to this one number, which we can suppose is all of these values here added together. All right. And to make this even more clear to see, let's actually always log the accumulator to the console. So let's say iteration number I, and then the accumulator in there. Okay, so we see that in iteration 0, the accumulator is 0. And so this is the value that we specified here as the starter, so as the initial value. Then in the second iteration, the accumulator is already at 200. And that's because that is the initial value plus the current value in the previous iteration. So that was 200 there, right? And so this 0 plus the 200 creates the new accumulator, which is then in the next iteration 200. Then in this iteration, we add the current value again, which is 450. So that result is 650. And therefore, in the next iteration, that's the value of the accumulator. Okay? And so here you can really see like the snowball effect of all of these values adding up to one final value. And in the end, that value is essentially the accumulator. Now here we see the value going down because in this iteration we are adding minus 400. And so 250 is 650 minus 400. Okay, so in the last iteration, the value is 2540, and then adding 1300 will eventually result in this value here. Great. So this is really how the reduce method works. And I think this log here is a great visualization of that. Let's give it all the space we need. And let me just change this one here to 100 so that you see the effect of changing this. And so now we can expect this accumulator in the beginning being 100. And so we already start with a small snowball here, which then we keep adding to. And therefore, our final balance is now 100 euros, or whatever it is, larger. Okay? And yeah, let's one more time do the same thing manually, basically with a for loop. So of movements. And so we need one more time an external variable here, which is going to be the sum. Well, let's call it balance 2. So balance 2 starts at 0. And so essentially this is our initial accumulator value, just like this 0. And then sum plus equal the current movement. And if we log balance 2, we will get, okay, now of course, this has to be balance 2, but now we get indeed the same result. And so here you can see this common pattern that we always need an external variable whenever we want to use a for loop. And that's fine if you only need one loop, but it starts to become really cumbersome and unpractical when we use many loops for doing many operations. So these methods that we've been studying, they completely avoid this extra variable, and they simply return the variable, or the value actually, right away. All right. And of course, we can write this here in an even simpler way. So using an arrow function, and I will still keep this here so that we can see the return that's happening. So first we can get rid of this, then we get rid of this. We also don't need any of these. But here we always use or need the accumulator and the current value. So here we need parentheses, then the arrow, and then, as always, we can get rid of all of this. And so now still our balance is the same. Awesome. So understanding how the reduce method works is something really important, but it's also way more confusing than the other ones. But I'm sure you're well underway of really understanding it. And now that we know how it works, we can actually now also calculate the balance of these movements here, and then print that balance right here to our application user interface. And so let's go ahead and do that here. So finally back to our application here. And so let's do that down here. So calc and print balance. And so this function here will once again receive the movements as an input. So any array of movements will work. And so now let's calculate the balance based on this array. And essentially this is exactly what we wrote before. So that's movement dot reduce, but it doesn't hurt to write it here again. So remember, the first parameter is now the accumulator, and only the second one is the current value. So let's call it the movement now. And so here simply we return the accumulator plus the current movement, and we start at 0. Great. And now all we need to do is to display it here in this element. So let's check this out. And it is called the balance value. And just like before, I already have it selected here. And this is a label. So balance value is here. So I called it label balance. And so label is basically all the things where we simply want to put some text in. All right. So let's say label balance dot text content, and this one we already know, equals the balance. And let's actually do a template string here, or a template literal, and also display the euro sign. Well, I don't know where it is, so let's just write EUR, which also means euro. And so now, let's see. Of course, we didn't call the function yet. So let's do that here as well. And actually, let's put this function here where it makes a little bit more sense, because it kind of belongs to this display movements here. Okay, so let's actually also call this one here calc and display balance. So to give it a similar name as that one. And so now I'm going to call it calc display balance. And once again, I'm calling it with account 1. So account 1 dot movements. And then later on, as we keep developing this application, of course, these movements here that we're going to use will be from the account that logged into the application. So if Jonas logged into the application, then Jonas's movements will be shown and Jonas's balance. But if Steven logs in, then of course Steven's movements and Steven's balance will be shown here. And right now we already see our balance up here. And so this actually happens to be exactly the same we calculated before. So also 3,840, because the movements are indeed also exactly the same. Great. So that's beautiful. With this, we actually already completed some parts here of our flowchart. So let's also keep this one handy here so that we can keep looking at it. And so we already did calculating the balance and displaying the balance. So we did all this in just one function. And we also already have displaying the movements. So indeed, we are making some nice progress here. And the rest that you see here will be even easier as we go on. Now, just to finish this lecture here about reduce, let me show you one final example, because we can also do other stuff than just adding up values. That would become boring at some point, right? And so we can also do other stuff. So this time what I want to do is to get the maximum value of the movements array here. Okay, so in this case, the result we're looking for is this 3000. Okay, and so for that, we can also use reduce, because remember, reduce is for boiling down the array into just one single value, but that value can be whatever we want. So it doesn't have to be a sum. It could be a multiplication or even something completely different, like a string or an object. But here we will keep working with numbers, but this time we want the maximum number. So let's kind of go manually through this array to determine what the reduce method should do. So let's start here at 200. Is this the maximum value at this point? Well, we don't know yet because we just started. So let's save 200 here mentally as our current maximum. Then we move on to the next value and we see 450. So is this greater than our current maximum, which was 200? Well, yes, it is. It is greater. And so 450 is now our current maximum. Then minus 400 is of course less than our current maximum. Then we move on even further. So 3000, is it greater than our current maximum? Yes, it is. And so that becomes our current maximum. So we store this 3000 and then we keep going through the array. And as you see, there's no other value greater than 3000. And so in the end, our maximum was this one. So 3000. Okay. And now all we need to do is to essentially translate this into code using the reduce method. So let's call it max movements.reduce. And as always, we need the accumulator and the current value. So I'm calling it movement here again. All right. And now this time, what should be the purpose of this accumulator value? So that's always the big question that we have to ask when we use reduce. So up here, when we wanted to add all the numbers together, the purpose of the accumulator was to keep track of the current sum. And so here, the accumulator will be the one that will keep track of the current maximum value. So let's just start by writing the logic here in a bigger way so we can understand what's happening. And then I will simplify it to make this a one-liner function one more time. So translating the logic that we just went over here is to say, if the accumulator is greater than the current value, which is the movement, then return the accumulator, right? Because in the reduce method, we always have to somehow return the accumulator to the next iteration. And in this case, we simply want to keep the accumulator at the value that it already is and not change it. Okay? We want to change it in the other scenario, basically. So when the current value is greater than the accumulator. So that would be this case here. So here, remember, the current value is 450, but the accumulator is 200. And so now the movement is greater than accumulator. And so what we want to return here as the accumulator in the next iteration is the current movement. And so that's it. Okay. And now we also need the initial value. And so the initial value makes sense to be this first value here of the array. Okay. And so that's movements at position 0. Now we could have used 0 here, but that would not be correct because imagine that the first value would be like negative. Then this might not work as expected. Maybe it might work with the maximum, but not with the minimum, for example. So don't just put 0 here when you're trying to find a maximum or a minimum value. Always just go with the first value of the array. Okay. And that's it. Let's see if it works. And then we can maybe go over this again. So, indeed, we get 3000. So, we started at 200. So, in this iteration, is the accumulator greater than the movement? Well, it is not. And so, return the current movement. Okay, but the first iteration is not that important. It gets interesting here in the second one. So now our accumulator is at 200 and the current movement is at 450. So this one here is false again. And so now we return the movement as the new accumulator in the next iteration. All right. And so in the next iteration, that accumulator is 450 now. Then here, the current movement is minus 400. And so here is 450 greater than minus 400? Yes, of course it is. And so let's simply return the accumulator so that it stays the same in the next iteration. And so that's the logic all the way until the end of the array. And with this, we then end up with this maximum value. All right, so I hope that made sense. And in fact, there is a ton of things that we can do with this reduce method. It is by far the most powerful array method that there is. And because of that, it can also be the hardest one to use. So we always need to think exactly what we want the accumulator and the current value to be and how they should interact. But I hope that with this exercise here, I could demonstrate the thought process a little bit. And throughout this section and the rest of the course, there will be some more exercises of the reduce method so that you can also learn better and better how to use it yourself one day. This is coding challenge number 2. And in this one, we're going to go back to Julia and Kate's study about dogs. And this time, they want to convert the ages of the dogs to human ages and then calculate their average age. So your job is to create this calcAverageHumanAge function. And this function accepts an array of dogs' ages, and it does the following 4 tasks. Or actually just 3 tasks. So first, calculate the age of all the dogs in human years using this formula. So if the dog is less or equal to 2 years old, then the human age is simply twice the dog's age. But if the dog is older than 2 years, then the human age is calculated by this formula. All right? Then, in the next step, exclude all the dogs that are less than 18 human years old. And that is essentially the same as keeping the dogs that are at least 18 years old here. Okay? Then, finally, calculate the average human age of all the adult dogs. And from the other challenges, you should already know how to calculate averages. Now, in this one, you will do it in a different way, hopefully, because the goal of this challenge is, of course, to use the map, filter, and reduce methods. Finally, then run this function for both these test datasets. So, as I said, this is a way of training the map, filter, and array methods that we just studied earlier. And so, good luck with this challenge. Take all the time you need, and I see you here once you're ready. So, were you successful in solving this one? I sure hope so. And in case there was some doubt, here is my solution. So, this function takes an array of dog ages, and then we want to convert all of these ages to human ages. So what we want here is to create a new array based on the original array. And so for that, the map method is perfect. So we will have a new array called human ages, and that will be the result of calling the map method on the ages array. Then this callback function gets access to the current age, so the current element in the array. And now here what we need to return is the result of this formula. So this one here. And so let's write a ternary operator here. So if the age is less or equal to, then what we want to return here is 2 times the age, right? Because that dog age is of course this age variable here, because it comes from the ages array, which itself is an array of dog ages. Anyway, if the age is greater than 2, then the result will be 16 plus the age times 4. And so, since this has an implicit return here, remember it's like writing this here, okay? And so it's returning either this value here, or actually either this value, so twice the age, or 4 times the age plus 16. So that's the callback function, and this will then produce the array that we're looking for. Let's take a look. So human ages, and then we just need to call the function. And so here is the age converted to human ages. And it does indeed look correct. So let's assume it is correct. Then next up, we want to filter for all the dogs that are at least 18 years old. And so that will then exclude all the dogs that are less than 18 years old. So that's going to be the adult dogs. And so that is human ages. And now we use the filter method. And that makes sense, right? Because it's the filter method who allows us to set a condition like this one. So when the age is at least, so greater or equal 18, then put it in the new array, which will be the adults array. And so let's log that one as well. So actually I want both of them here. So human ages and the adults. And so indeed, these two here, the 4 and the 2, are gone. All right. And now finally, we want to calculate the average. Okay. And so the average is basically adding all of these values together and then dividing the result by 5. So the length of the array. So that's essentially what we already did before. So that's going to be adults.reduce, then the accumulator and the current age, and we want to return the accumulator plus the age, and the start is going to be at 0. So this here will return the sum, so all of these ages here added together. And so now all we need to do is to divide this by the length of this array. And then we simply want to return this average value that we just calculated. So let's just see if this makes sense. Let's actually save it here in a variable instead of logging it directly. So average 1, and then also average 2. And then just log both here to the console. And all right, here they are. And this looks pretty reasonable to me. And so our solution here works. Now, I just wanted to let you know that we could have done this average calculation here in a different way. So in a bit more complex way. So let me show you one property of an average. So let's say we want to calculate the average of 2 and 3. So we do that by 2 plus 3. So we add all of this together and then divide it by 2. because we have two values. And so that is then 2.5. However, we can also do it in a different way. So we can divide both of them by 2 immediately. So 2 divided by 2 plus 2 divided by 3. And this will also be 2.5. So these here are essentially the exact same thing. Okay? And so here we can do this differently. So let me actually duplicate this line so that we can keep both here. So what I mean is that we can actually simply divide the current age here immediately by the length of the array. Right? Here, this is actually 3 divided by 2. Okay, sorry for that mistake. And so what we did here was basically to divide both of the values always immediately by the 2. And so that would be the same as immediately dividing the age here by the length of the array. So dividing this by the length of the array. And now remember that we can get this length immediately here from this parameter. Well, not really the length, but the array itself. So that's the 4th parameter. And so now we can say array.length like this. And so see what happens now here. And indeed, the values are exactly the same. And so this way of calculating it is just the same as this one here, but we can do it kind of all in one line. And I also wanted to show you a good use case for using this array here. In this case, we could of course also just have written here adults.length, but sometimes when we chain these methods together especially, then this is the only way we have of using the current array. And we will see a use case of that later. Now, of course, I did not expect you to write it like this, but I just wanted to show you a good use case for the current array parameter that we have here. Okay, and with that, we finished the challenge, and I see you in the next video. So up until now, we have been using the map, filter, and reduce methods kind of in isolation. However, we can take this one step further by chaining all these methods one after another. For example, let's say that we wanted to take all the movement deposits, then convert them from euros to dollars, and finally add them all up, so that we know exactly how much was deposited into the account in US dollars. Okay? Now, we could of course do each of these operations individually and store each results in a new variable. However, we can also do it all in one go. So let's do that. And I will start here with the filter method. So as I said, we want to take all of the deposits. So we get the movement here, and then we filter only for movements that are positive. And so only these are the deposits. And so the result of this operation here will be a new array. And so now we can call map on that array. So here again, we then get a movement. And now we can convert that movement to US dollars. So we can do that with that variable that we used before. Let's see where that is. So euro to USD. So movements times euro to USD. And so with this, we converted all of the deposits to US dollars. But now we can take this even further, and on this result, we can also call a reduce. And of course, we could also call more filters or more maps. But now let's just do a reduce here. And so basically add all of these values together. And so we already know how that works. So accumulator, and then the current movement. And we just need to return accumulator plus the current movement. So that's movement and 0. And so now let's store all of this into total deposits in US dollar. Okay, so you see that we did 3 data transformations here all in one go. So let's log it to the console to see that we actually get a result here. And yeah, we do. So this is the deposits that we did into our account in US dollars. And as I mentioned, we could of course change many other methods here as well, as long as they return new arrays. So filter returns a new array, so we could have added something else here, or the same goes for map, but reduce, for example, will return a value. So only this number in this case. And so of course here we could now not have chained a map or a filter after this. So we can only chain a method after another one if the first one returns an array. So you can imagine all of this as a sort of pipeline that processes our data. So we put data in at the beginning, which is here, and then it goes through all these steps. So in this case, these 3 steps here, and then in the end, our input data comes out processed on the other side of the pipeline. So let's just write this here, because I think this is a nice analogy, right? Now, when we chain all these methods together here, it can be a little bit hard to debug if one of the results is not what we expect. For example, if this result here would be something really weird, we wouldn't really know from which step of this pipeline it would come from, right? And to solve this, it would be good to check out the array in each of these different steps. So let's say we did a mistake here and we wrote it like this. And so our result would come out negative, and that would be strange. So in this case, it would probably be like to know the result of this filter operation. And so we can do that by using the array parameter that we get access to in this callback function. Remember? So we have the current element, the index, and the entire array. And actually, let's duplicate this here first. Okay, and set this back to what it was. Okay. So let's now log to the console this array. And so now we need these curly braces because we will have a code block. And we need to actually return our calculation here. But anyway, we can now take a look at the whole current array that this map method here is being called on. So let's take a look. And so indeed, it is this array of the 3 negative movements. So let's log the movements here one more time. So you see that indeed we get these 3 negative movements now. And so that is the result of this filter here. And so again, if we want to see that result of only this operation, we can check out the current array in the next array method that is chained on that filter. And so in this case, it's the map. And so this is one of the great use cases of having access to this current array. Because as you see, of course, this array has to be the result of the previous operation, so of this filter. It is not this initial movements array, because that's not what we called the map method on, right? The map method was called on the result of movements.filter. And therefore, that is the value here of this array. That makes sense? Now it was of course logged here 3 times because this callback function here is called 3 times. So once for each of these 3 values. Okay, so let's put it back to what it was. And now we get the correct array. And this one is now printed 5 times because there are 5 values in the array. So let's just turn this one off here as well. And so this was just to show you that we can inspect the current array at any stage of the pipeline using the third parameter of the callback function. All right, and so now that we know how this chaining works, we can go back to our application here. Let's give us some more space. And we can now calculate these statistics down here. So that's all of the deposits. so incomes here basically. Then we have the outcomes, so that's the sum of all the withdrawals, and then also an interest that the bank might pay us. And so let's go back up here to the application. And so we already have display movements, calc display balance. And now here I will create another function called calc display summary. And just as our previous function here to calculate the balance, this one also receives the movements data. And so we will also call it with the account1.movements. And once again, we will then later change this to the user that is logging into the application. Okay, so let's start by calculating the incomes. So that's this first value here. And so that's all the movements. And then we filter them for only the positive ones. And so this is now exactly what we did before. So greater than 0. And now onto this one, we simply chain another reduce. Because now we want to add all these positive numbers together. So there's no mapping involved here. It's just filtering and then adding together. Give it a save, and now we can put it here inside of this label. So this HTML element. So it's always a good idea to check out the name of it. So this one is called summary value in. So as before, I already have that here. So it's this one, and it's called label sum in. We will also then need label sum out and label sum interest. So keep these in mind for a bit later. So here we have label sum in, and then our old text content property. So incomes, and then the euro sign. And now I know how it works. At least on Mac, you can use the emoji picker. And then you just search for euro, like this. And here you go. And I'm sure there is something similar on Windows as well. Let me actually copy it and put it also here instead of this euro. And the same also here in this movement. So here where we display all the movements so that the euro sign also appears here on all these. Okay, this should now already be working. So let's give it a save. But nothing happened here. That's because I am calling the wrong function here. So this has got to be summary. So I was calling calc display balance for a second time. Now it works. So that's 5,000 euros. And you see that also now here we have the euro sign, which makes it look a little bit more like a bank application, right? And now here the same for the outgoing money. So we're going to calculate a variable called out. And now I want to leave this one here again as a challenge for you. So that's a very simple one. Just don't look at the rest of the code. And I'm sure you can do this one without any problem. So that's just movements dot filter. And so now it's basically just the opposite. So the negative movements. Okay, and then label sum out, set to out, and that did not work. I see we have an error here, and so assignment to constant variable. No, I see we are forgetting here the text content property. Maybe you saw that coming. And now it works here beautifully. Okay, now I just want to get rid of this minus sign here. We already know that the money is going out, so there's no need for the negative sign. So let's just take the absolute value here. So we did that before. So math.abs, and this is going to remove the sign. Yeah, beautiful. Now, finally, the interest here. And so let's say that this bank pays out an interest each time that there is a deposit to the bank account. And that interest is 1.2% of the deposited amount. Unfortunately, in the real world, it's nothing like that. But here in our fictional bank, we can do whatever rules we want, right? So as I said, the interest is paid on each deposit. So first we need to get these deposits. And so that's this filter here. We just copy it. Okay. And so now on each of these deposits, we will receive 1.2%. So what do we do here? Well, we're going to create a new array which contains all of these interests. And then in the end, we can just add them together. And so map is the way to go here. So we take the current movement, and we could even call this here a deposit. Let's do that. We know that this has to be a deposit, and so let's call it that to make it a bit more explicit. We could do the same here, but that's not necessary. So we get 1.2%. So we multiply this by 1.2 divided by 100. So that's how you calculate percentages. And then finally, we just add it all together. So let's just take this one here, chain it here. And now each of the current elements is no longer a movement. So let me just call it here an interest, so int. All right. And now let's also just copy this one here. So label some interest. And then here, of course, it is the interest. And you see, we got 60 euros and 24 cents of interest. Great. But now let's say that the bank introduces a new rule. So now the bank only pays an interest if that interest is at least 1 euro or whatever other currency. So where do we put that in our calculation? So again, only if one interest is at least 1, only then it will be added here to this total. And so this sounds like it's got to be somewhere between this place where we actually calculate the individual interests and here where we then add them together. So let's add a new method here in the chain between the map and the reduce. And it is going to be a filter, because we basically want to exclude the interests that are below 1. So this one here is an array of interests. And actually, let's take a look also at the current array here. So interests, then I, which we're not going to need, and the whole array. And so let's log to the console the whole array just to see what's happening. But anyway, what we will have to do here is to filter the result of calling these interests here for values that are at least 1. So interests greater or equal 1. And only these interests will make it into the final calculation. So into the next step here of the pipeline, which is this reduce. So you see that the interest now decreased a little bit. And that's because indeed here in this array of interests, we have one value that is below 1. So this 0.84. And therefore, it will get filtered out in this new step that we edited here to the processing. And so then the final interest that's going to be paid by the bank is only these other 4 values added together. So these 3 plus this one. But this one here has been excluded. All right, that makes sense. So anyway, this was another great part here of our Bankist application. So with this, we now also completed this part here. And hopefully you can start to really appreciate the huge advantage that working with these array methods gives us over simply working with more traditional loops. And now just to finish this lecture, let me just give you a couple of remarks about chaining. So first, we should not overuse chaining. So we should try to optimize it, because chaining tons of methods one after the other can cause real performance issues if we have really huge arrays. So if we have a huge chain of methods chained one after the other, we should try to compress all the functionality that they do into as little methods as possible. For example, sometimes we create way more map methods than we actually need, where we could just do it all in just one map call. So when you chain methods like this, keep looking for opportunities of keeping up your code's performance. And second, it is a bad practice in JavaScript to chain methods that mutate the underlying original array. And an example of that is the splice method. So again, you should not chain a method like the splice or the reverse method. I mean, you can do that, and for a small application like this one, it's not a big deal and it's not going to cause problems. But in a large-scale application, it's usually always a good practice to avoid mutating arrays. And we will come back to this when we talk a little bit more about functional programming. Anyway, with that being said, there is now another coding challenge waiting for you. Welcome to coding challenge number 3. And this is going to be a quick and easy one. So all I want you to do is to rewrite the calcAverage function that we wrote in the previous challenge. Now the difference here is that this time you should use an arrow function and you should use chaining. Now to make this chaining work, just keep in mind the second way that I used in the last challenge to calculate the average. Then, as always, use this test data here to try out your function. And so I see you here in a minute or 5 minutes maybe once you're done. All right, so let's grab the code here from the previous one. So there's no need to just rewrite everything. So let's get rid of all the comments here, all the console.logs. And so let's save it here and then rewrite it as an arrow function. So it still takes in the ages. And now what it returns is simply the ages, then dot this map. So calculating the human ages. Okay. And then on the result of that, we filter for only the adult docs. So when the age is greater than 18. So this is what we have for now. Let's call this one here 2. Okay. And so for now, this is the 2 arrays that we have, one for each function call. But now let's then also calculate the average. And so for that, all we need to do is to chain this method of calculating the average that I showed you in the last lecture, or actually in the last challenge. So pasting that here. And so now we get the exact same results as before. And that's actually already it. Now, what's really important to notice here is that this is actually really the only way of calculating the average now. So basically dividing the age by the length of the current array immediately here in each of the iteration. So remember that in the last challenge, I first simply added all the values together, and then afterwards I divided it by the length of the array. So in this case, by the length of the adults array. However, that would not work in this case, because there would be no way of knowing the length of the adults array. So of this result here, right? Because we haven't stored it anyway, and so we couldn't do like this. like adults.length, right? This wouldn't be possible because adults here does not exist anywhere. And therefore, we need to take that length from this input here. So from this fourth parameter, which gives us access to the array on which the method is called. And that's the reason why I showed you this way here in the last lecture. Because, yeah, again, this is the only way in which we can now calculate this average. Unless we wanted to do it in 2 steps. But my instruction here was to really do it all with chaining. And so this is the way to go then. All right, so make sure you understand really why and also how this one here works. And then let's already move on to our next method, which is going to be the find method. So another really cool one. So I can't wait to see you there. After the very important map, filter, and reduce methods, we still have some more methods to learn, which are also super important and used all the time. So in this lecture, we're going to talk about the find method. So as the name says, we can use the find method to retrieve one element of an array based on a condition. So let's again use our movements. And so find, and just like the other methods that we've been talking about, the find method also accepts a condition. And just like the other array methods we've been talking about, the find method also accepts a callback function, which will then be called as the method loops over the array. All right, so find is basically just another method that loops over the array, but then it does something different. And in this case, what the find method does is to retrieve an element of the array. So as always, the current element of the iteration is the movement, and then here we specify a condition. So let's say movement less than 0. So basically, this is here a withdrawal, right? So a negative movement. So you see that just like the filter method, the find method also needs a callback function that returns a Boolean. So the result of this is of course either true or false. Now, unlike the filter method, the find method will actually not return a new array, but it will only return the first element in the array that satisfies this condition. So basically, in other words, the first element in the array for which this operation here becomes true. And so basically this here will return the first withdrawal. So first withdrawal is this. So let's log the movements again to the console. And then let's also log the first withdrawal. And so indeed, minus 400 here is the very first value that appears in the array that is negative. Okay? So, as you see, the find method is a bit similar to the filter method, but there are 2 fundamental differences. First, filter returns all the elements that match the condition, while the find method only returns the first one. And second, and even more important, the filter method returns a new array, while find only returns the element itself and not an array. Okay? So make sure that you understand this fundamental difference. Now, this example here is not really exciting, and so let's now take it to the next level and start actually working with our array of objects. So that's this accounts array, remember? So this array which contains the 4 objects where each of them is one account. And as I mentioned earlier, this is a pretty common data structure in JavaScript, and so let's now work with this together with the find method. Because in this context, the find method actually becomes really useful. So that's because using find, we can now basically find an object in the array based on some property of that object. And so that's really cool. So let me show it to you. So let's create a variable called account, and it's going to be accounts So all the accounts dot find, and then our callback. And so as we loop over accounts, each of the current elements is one account. Okay? And so now let's say we want to select one of the accounts by the name. Now, this disappeared here, so let's bring it back. Okay. So let's say we want to get the account where the owner is Jessica Davis, right? So we can simply do account.owner equals Jessica Davis. So let's see. Just the account. And indeed, we get now only this object. And this is really, really powerful of arrays and objects. So where one array contains multiple objects, which all have a similar structure. So all of them here have an owner, have a movement, a pin, a username, and so on and so forth. So using the find method, we can then search this array basically to find an object that matches a certain property that we already know. So in this case, that property that we know is the name. All right. And so we simply compare Jessica Davis here with the account owner. And whenever this condition here is true, well, then that object is returned. So usually the goal of the find method is to just find exactly one element. And therefore, we usually set up a condition where only one element can satisfy that condition. And so that's why we used the equal operator here. Okay, so if the owner names are unique, then this equal operator here will only ever match one account with this name here. All right, and we will actually use this in the next couple of lectures to implement the login feature and also some other features. Now, I'm going to leave it to you here as a challenge to implement this functionality using the for-off loop, just like we have been doing it with some of the other methods, like map and filter. So we have also been implementing these using the for-off loop just to see the difference. But now I'm not going to do that, but I'm leaving it here as an idea for you to do that. Now anyway, let's go now to the next video and actually start to implement the login functionality. Let's now finally implement the login feature of our application. And this is going to be a lot of work, so let's get started right away. And to start, let's take a look at our demo application. So in this case here, in the beginning, we cannot see anything, so there's no logged in user, and then we can input a username. And so this is the kind of username that we computed before, remember, and then the pin. And if that is correct, so if the pin corresponding to this account is correct, then we get logged in. And that's going to happen whether we click on this button here or hit the enter key. And so then all of this appears. So all the values here are calculated. And yeah, so that's the main thing that we need to do in this lecture. And then of course, if someone else logs in, then their values are going to be displayed. And so let's take a look at the HTML here of this form. So indeed, here we have a form element, and this form has a button. And so it's onto this login button that we will attach the addEventListener method. Then, as for the inputs, the username is going to come from this one with this class, login user -- input, and the pin is going to come from this one. And as always, I already have all of this here selected. So this is the button here. And then we have input login username and input login pin. Okay, so let's now create these event handlers. So event handlers right here. So button login, add event listener for the click, and then as always, our callback function. And here, let's just log to the console login. Okay. And now, did you see what happened here? Take a close look down here what happens as we click. So for a flash there, you saw the login and then the page reloaded, right? And that's because this is a button in a form element. And so in HTML, the default behavior when we click the submit button is for the page to reload. So we need to stop that from happening. And for that, we need to actually give this function here the event parameter. And let's just call it event. And you already know how this callback function gets access to this event object, remember? And so on that event, we can call a method called preventDefault, like this. And so as the name says, this will then prevent this form from submitting. So prevent form from submitting. So let's do that again. And now we fix that problem and we can see login. Okay. Now another thing that's great about forms is that whenever we have one of these fields here inputted, and when we then hit enter like this, then that will actually automatically trigger a click event on this button. Okay. So once again, hitting enter in this field or in this field is exactly the same as the user clicking right here. So both of these things will trigger a click event. So you see, as I hit enter, we get more and more click events. So that's why we get then login logged to the console. But now let's do the actual work. So to log the user actually in, we need to find the account from the accounts array with the username that the user inputted. And so that's where our find method comes into play again. So we can do accounts.find. And then this is actually the same that we did in the last video. So account.owner should be the same as, so 3 equals actually. And so remember, we have this value at input login username. Okay, so that is this element here. And then from there, we need to take the value property. Remember that? So we did this here, I think in the guess my number game, where we also read the value out of an input field. And so here, this is the same. And so now let's actually save this into a variable. Now this variable needs to be defined outside of this function. Okay. And that's because we will need this information about the current account also later in other functions. So it's a good thing to have this big important information outside of this function so that we can then remember it for other actions in our application. For example, when we transfer money here, then we need to know from which account that money should actually go. And so for that, we need the current account. So current account, and here we just define it, and that's why we need a let. And so then here we assign it this value. So current account. Okay, so let's check that. So JS, and we get undefined. So there was some problem here. And the problem is, as I see right away, is that we are looking for the owner, but we need to look for the username. So the owner is the whole name, but the username property is these properties that we created earlier. So here in this function, remember? So we need to compare this value here that the user inputs, of course, to that username. So try that again. And now here we get the object which has exactly this username. All right. And so it is here my object, basically. All right. So we got the user that is trying to log in. And now all we need to do in order to actually log the user in is to check if the PIN is correct. So PIN here is like a password, but something that we usually use like in an ATM. And so I decided to just go with that here, because I think this also looks a little bit like an ATM machine here. So let's then do that test. So if current account dot pin is equal to input login pin. Okay, so that's the variable that holds the selection of selecting this element. And then again, we need to take the value. And finally, we also need to convert this to a number, because as I mentioned earlier, this value will always be a string. All right. And so here, before we do anything, let's just log in again here to the console. Okay, so JS, and we got logged in. But if we only input JS, then we simply get the object itself, but without being logged in because the pin is correct. And now let's try just some other user to see what happens here. And we get an error. So that error is cannot read property pin of undefined. And so the reason for this is that this object here is now undefined, right? Because no account could be found for this username. And so the find method, so this one here, will return undefined if no element matches this condition. So that's something that we haven't seen before, and so that's why I'm showing this to you. But anyway, how should we solve this? Well, the first thing that might come into mind is to simply check if the current account exists, like this. Okay, so this would fix the problem, but we can do better because we already learned about something called optional chaining. Remember? So we can do this, and then this pin property will only be read in case that the current account here actually exists. Remember that? And so this is a lot easier and a lot more elegant. So let's try that. And so now nothing happened. So no error. All we get here is the undefined because, yeah, this account does not exist. But that's, of course, not a problem. Okay, but now in case that the account does exist and that the pin is correct, what should we do? Well, let's take a look at our flowchart here. So this is the part we already checked. So if we have the correct credentials, right? And so if yes, then we should display the UI and the welcome message. So let's write that here in our script. Put that here. And so I like to kind of plan out what I'm doing here using comments. So display UI and a welcome message. Next up, we should display and calculate the balance. Then the same with the summary and the same with the movements. Okay, this part here we are leaving for the next section about the timer. Okay, so display balance, summary, and movements. So display movements, display balance, display summary. And let's start with the message here. So that is this element here. So let me inspect that. So it's this paragraph here called welcome. And so as always, I already have that selected. So it's a label, so probably it's called label welcome. Label, indeed, here it is, label welcome dot text content, as always. And then here we are going to write welcome back and then the first name of the person. Welcome back. And then the owner of the current account. So that's current account dot owner and then only the first word. So how do we do that? Well, we use our good friend split. And we split it with the space. So as I said, we use this one all the time. And then from the resulting array, we simply take the first element like this. Okay, so this displays the message. And now about displaying the UI, remember how in the beginning we set the opacity here from 0 basically back to 100, which is the default. So usually the opacity here is at 0. And so now when we log the user in, we actually set this opacity here to 100. So as we save this now, it will all disappear. And so now what we will do is the container app, I think. Yes. So container app is the element that we selected previously, which has this app class. Okay. So this element, we will manipulate the style and in particular the opacity style. Now remember how I said in another project that it's also good to use classes for this. Okay. But in this case, it's really just one style. So it's not a big work to just do it like this. So let's test this one out for now. So JS and my pin. And indeed, we get our message here. And also we get everything here now back to visible. And Jessica Davis now, which has pin 2222. And so now we also get Jessica. Now, as you see, these balances and these movements here, they're all still hard-coded from what we had back here. So here we called calc display summary and also the balance and the movements. But now we want to do that not here, but actually inside of the login function. So let's remove all of this. Again, because we do not want to call these functions right in the beginning when our script is loaded. We only want to calculate and display the balance and the movements and the summary as soon as we actually get the data that we want to display. Right? That makes sense. So let's remove all of that and actually do it here. So display movements, and then it is the current account dot movements, right? And that's because this method here, or actually this function here, it expects a movement argument. And as we hover this function name, VS Code is so smart that it actually shows it to us here. And so from there, we can immediately see what we need to pass into the function. So that's really handy. Then the same with the balance. So display or calc display balance actually. And so once again, let's just hover this here to make sure what we need. And it is the movements. So that data is stored in the current account dot movements. And finally also the summary. So calc display summary. And once again, we will need the movements. So that data is in current account dot movements. All right. Now we will have to come back to this function here by the end of this lecture. But for now, let's leave it like this. And let's log in again, first with Jonas. And so this is the data that we are already used to seeing, this balance value and this movements here, because we have always been printing these values here using that account. But now, as we log in as Jessica Davis, you will see that these values here will all change accordingly. So let's see. And yes. So that's great. Now we are getting all of these values, so this data here dynamically really from the account object itself. So we have all her movements, we calculated all of these statistics or summaries, and of course also the balance is now really about this account itself. And we have more. Let's try Stephen here. So Stephen Thomas Williams with pin 3333. And this kind of messed up our UI here because of this calculation. So Stephen only has a balance of 10 euros. And now finally we can try Sarah Smith. And so once again, we see all her different movements here. And yeah, this is great. So this now really works depending on the user's data. So let's go back here. So what I want to do next is to, as we log in, also get rid of this data here. Okay, so basically emptying these two fields. And also as we log in like this, I didn't want this field here to lose its focus. So let's do that before this. So clear the input fields. And so we already know that the fields are input login username, which we want to set to the empty string, and then also input login pin. And we can do it like this. Login pin, also set it to equal, because the assignment operator works from right to left. So it will start here assigning equal to this field here. And then this here will become the empty string. And so then empty string will also be assigned to this one. We are just missing the dot value here. Otherwise, we would set the entire element to the empty string. All right. So JS 1111. Okay. And now this happens, what I mentioned before, is that this field here still has this focus. So we can see the cursor there blinking. And so that's a bit ugly. And so on that field, so input login pin, we can use this blur function or method. So just call blur. And so that will make it so that this field loses its focus. So you see, now it looks great. And now just to finish, we also need to come back to this function here, just as I mentioned earlier. So calc display summary, and let's go there. So this one here. And as you see, we calculated the interest using this 1.2 rate, right? So right now, for all of the accounts, the interest rate is now calculated using this 1.2 interest rate. However, as we take a look at the accounts, each of them actually has a different interest rate. So this one has 1.2, but this one has 1.5. And this one has less, so it gets a less interest. And so now, of course, we also want to dynamically use this interest rate depending on the current user. Right? That makes sense. And so we have to modify this function here a little bit. And so in order to get access to that data, so to that interest rate, we now need more than just the movements. Instead of the movements, we want now the entire account, because then we can take the movements from the account and also the interest rate. All right. So again, we will now change this function and pass in the entire account and not just the movements array. And so then from there, we will be able to take the movements that we need to calculate these three statistics here, and then also the interest rate that we have here. So account, let's just call it, or let's just call ACC one more time. So here, now we need to take the movements from that account, the same here and here. All right. And now here, instead of this 1.2 fixed rate, we take ACC dot the interest rate that's in there. All right. So let's just see if everything still works. And let's see it with Steven. So that was STW and 3333. And you see that now our UI is no longer messed up. But of course we forgot to call this function here correctly. That's probably why we got this error. Yeah, right. So down here, we are still calling this function only with the movements array. So we need to instead pass in the entire account, because as you see, now we do need the account here. So try that again. TW. And so now we get the correct interest. And maybe you remember that before it was different. It was this crazy long number with a lot of zeros, which messed up our user interface here. So this means that it is now being calculated differently for each of the user according to their own specific interest rate. Great. And with this, we implemented all of the tasks that we had in our flowchart for this functionality. And in practice, what this means is that for the first time, we made all of this data that we see here in our application dynamic. So depending on which user is actually logging in. So let's see that change again. Let's try a wrong pin here. And so now nothing happens. And of course, we could now hide the user interface and display an error message, but I want to keep it simple here. So this is just a simple learning application, so we don't need to mess with all of that. What matters is only the correct version for now. And so with the correct pin, now as you saw, the data changed here back to this Jonas account. Awesome, that's great. So that's really great progress. Congratulations for making it this far in this section. I know there's a lot to learn and a lot to take in, but I hope that this lecture too was clear to you how everything worked here. And just to recap, clearly the most important part here is the usage of this find method here and knowing that this is the correct method for the job. So maybe analyze this line here a little bit and then see exactly what happens here. Also this nice usage of the optional chaining. And then we are ready to implement our next feature, which is going to be transferring money from one of our users to another. In this video, we're going to implement our next feature, which is to transfer money from one user to another. And this is how transfers work. So here we input the username of the user to which we want to transfer, and then here the amount. Okay, and so now we need to attach an event handler to this button here, and then we're going to take a look at our flowchart to see what we have to do. Okay, but let's start to take a look here at this element. So it is the button form, and then we will take our values from form input amount and form input to. So that's input transfer to and input transfer amount. And the button is button transfer. So as always, I already selected them here beforehand. So let's use button transfer dot add event listener click and then our function, and we will actually need our event here again, because just like before, we need to do event.prevent default, because this one is also a form. And so without this, if we clicked here, then that would reload the page. So this here is pretty common to do when we're working with forms. So preventing the default behavior. Okay. All right. So let's create some data here based on the input data, and starting with the amount. So the amount to transfer is input transfer amount dot value, and then we need to convert it once again to a value, or to a number actually. Okay. Oh, and now as I reload here, of course we lose all this data, so this current data that we need. So now we will have to start to log in always here. And we could find a way around this, but yeah, let's just keep logging in whenever we have to check our code. So anyway, we have the amount, and then we also want to figure out the account to which we want to transfer. So const receiver account, and now the value is of course in input transfer to dot value. So that is the string that's going to be right here. So for example, if we want to transfer to Jessica Davis, that's going to be JD, right? However, that value alone, so that username alone, is not that helpful. It is only helpful when we use it to then actually find the account object to which we want to transfer. All right. And so for that, we once again use the find method. So that's accounts. So that's the array holding all the accounts. And then we have the current account. And we want to find account where the username is equal to this value that we put in here. All right. So to recap here, we are now looking for the account which has this value here. So that's going to be the username value that we input into that form, so to which we want to transfer. And so here we are looking for the account with the username which is equal to that inputted username. And then we select that from the account once more using the find method here. Okay, so we have this data. Let's just check if it is correct here by logging it all to the console. So also the receiver account. So this should be a comma. So I'm logging in as JS with this pin. And now let's say I transfer to Jessica Davis. That's JD, 100 euros. And now in the console, we indeed get 100 and the account with the username that I just inputted there. Great. So let's see what we have to do now. So what we will do is to add a negative movement to the current user and add a positive movement to the recipient. And that makes sense, right? So if I transfer 100 to someone, I should lose that 100 and the other person should receive that 100. Otherwise, we would just be creating new money, right? So we do that and then we update the UI again. So we show again the movements, summary, and balance, because all of that will be affected by this transfer. Now, what's kind of missing here in this flowchart is that we also actually first need to check some stuff. So we need to check if the amount here is actually a positive number. And we also need to check if the current user, so Jonas right now, actually has enough money. So I should not be able to transfer 5,000 if I only have like 3,000 and something. Okay, so let's implement that check first. So as I just said, the amount needs to be greater than 0. Otherwise, we could do a negative transfer and basically transfer money to ourselves. So this needs to happen. And also, the balance of the current account needs to be greater or equal the amount that we're trying to transfer. Now, this balance value is actually not stored anywhere, right? So in the place where we calculate this balance, so that's right here. So calc display balance, all we do is to calculate it and then display it immediately on the user interface. But we do not save it anywhere. So let's actually change that. So besides only displaying it on the user interface, we also want to save it in the account. Now, how do we get access to that account? Well, we will do the same as we did previously with this function here, where now instead of the movements, we pass in the entire account. And so then we will be able to read the movements here from that account. And also we will be able to then create a new property on that account with the balance. Okay, so I hope that makes sense. So we are changing it from movements. And so now we will be calling it with an entire account object. So here we need to do account.movements. And before we move on any further, let's call this correctly. So calc display balance should now only be called with the entire account object and not only with the movements array. Okay, so here it is. So now we take the movements from the account object, and then we can add that. So we can say account.balance equals balance. And in fact, we can make this even better. We can store this value here immediately in account.balance. So let's do that. Account.balance here. And then we get that property here from account.balance as well. Great. And remember why all of this works. And we have some error here, but that doesn't matter. It's something unrelated. Now, anyway, let's remember why all of this works. So why we can set this property here on this account object that we receive, and it will then set that right here on these objects that we have here. Well, and the reason is that, once again, all of these different references do actually point to the exact same objects in the memory heap. Okay, so when we access this account1 object here, so down here in the login function, so right here, where we create this current account variable, this is of course not really a copy of the object itself. So just as we learned before, this is simply another variable which points to the same, so to the original object in the memory heap. Okay, so this current account object again is exactly one of these objects that we have right here. So one of the objects of the account array, right? They are the exact same object, they simply have different name. Here it is called account1, but then down here it might be called the current account. Okay, and then we use that current account to pass it into this called display balance function. And so then inside of that function, it will have even another name. So here it will be called ACC, but it's still the same object. Okay, it's still pointing to the same place in the heap, so in the memory. All right, and therefore setting the balance property here on ACC is exactly the same as setting it up there where we first defined the objects. Okay, and I will show you that in practice in a second. But now let's go here. And so this is where this error comes from, because we don't have any code block, and also because there is no second operand here. So anyway, let's go back to this condition here. So we already defined that the transfer can only happen if the amount is greater than 0. And now the second part is that the current user needs to have enough money to do this transfer. And so that means current account dot balance, which is the property that we just defined. All right, so we calculated the balance, and that needs to be at least equal to the amount that we're trying to transfer. Okay, also we should not be able to transfer money to our own account. So let's add that condition as well. So what we're trying to say is that the receiver account dot username must be equal from the current account dot username. All right, and here we have one equal too much. All right, and actually we should also check if this receiver account actually exists. So if it doesn't exist, of course it makes no sense to transfer money there. So we could add that here, like simply testing this. But instead, since we're already trying to read a property from that object here, we can use, once again, optional chaining, like this. And so then, if this object here doesn't exist, then immediately this here will become undefined, and the whole AND operation will fail. And so in this case, we don't need that. Let me just comment it out. And so now this should work. And so let's just log something to the console. So transfer valid. And now I will check all of these conditions here. So let's log in. And now I want to transfer again to Jessica Davis, and I will try to transfer 0. So we get 0, but we do not get transfer valid. So that means we didn't enter this if block here. Now let's try to transfer more than I have. And so this is also not valid, but now 500. And so all of these should now be true. So you see transfer valid. If I try something else, then again, nothing should happen. Oh, and actually it does happen. So indeed, the receiver account is undefined. And so this here will now be undefined. Oh, but I see what's happening. Because all that we are asking here is for this here to be different than the current account.username. And so JS is of course different than undefined, and therefore this here is still true. And so in fact, we need to do this as well. So let's try this again. And so you see, of course, bugs like this can happen all the time. And so we find them, we fix them, and we move on. And of course, now we test with some wrong username there, and now nothing happens. Okay, so now the transfer is not valid. Now I'm also trying to transfer to myself, and so this is also not valid. But finally, to Jessica David, it will be valid. Okay, and so now here we can finally do what we intended to do all along. So these steps that we have here. So let's do that. So the current account dot movements. So we will add one new movement, and so we're pushing here the amount but negative. So the negative amount, and now on the receiver account we will add a positive movement. Okay, and that's actually already it. That's the most important part of doing the transfer. So doing the transfer, and then we also want to update the user interface. So we could now copy this code here and paste it there as well, but that's not a good practice, as you already know. And so I will now refactor this code here all into one function. So let me grab this here, and this function will be called update UI, and it will also receive, of course, the current account. So let me write now the function here, update UI equals function, and I'm going to leave it empty for now. And so indeed here I need the current account now. Okay, so otherwise I could not call these three functions then using the account. But here I can call them whatever I want again. So let me just call them account. All right. So we refactored that functionality into its own function. And so now we can call this function anywhere that we want in our code, and it will then always perform these three tasks. Okay. So here I already called it update UI. Let me just write it here also as a comment. And now all I have to do is to paste it here as well. Great. So that should be working already. So let's transfer to Jessica Davis 500. And so now I should see one negative movement here, and this should also decrease by 500. And indeed, it did. So let's check now here the accounts variable, just to see if we actually get the balance. So indeed, we now have the balance property here. We also have the movements, and of course it's gonna contain the minus 500, right? So that's the money that we just transferred away to Jessica Davis. And indeed, it should also already be in Jessica Davis. So her latest movement is now indeed 500. So let's check it out also in the user interface. Now, before doing that, the final thing that we're going to do is to clean these input fields. But now, just to make sure, let's log in as Jessica Davis, and then we should get plus 500 here as the latest deposit. All right. Now, as I was saying, we need to clean out these inputs now. And that we will do no matter if the transfer was successful or not. So we can do that outside of this if statement. So just down here. Or actually, we can do it right here. Let's get rid of this console.log. And then input transfer amount equal, or actually dot value equal input transfer to equal the empty string. And with this, we should be finished. Let's try it one more time. This time, Jessica Davis will transfer something. And so we lost here the latest transfer, of course, because the page was reloaded. And this data, of course, then gets lost. So when our page loads, the information about the accounts, so the account data, will always be exactly what we have here in our code. Okay, so that's the reason why that data, that 500 transfer, is no longer here. But that doesn't matter. So let's transfer to Stephen Williams here, 1000. And we get an error here, assignment to constant variable HTML button. So at line 167, and oh, one more time, I forgot the value here. That's a very stupid mistake, right? Let's try that again. Stephen Thomas Williams, I believe. And now it worked. So all of our statistics here were updated. And indeed, now this field, or both of the fields, are empty. And now as we go to this account, oh, apparently it does not exist. Yeah, it is Stephen Thomas Williams. Yeah. So now we get this 1000 deposit here that we just did previously. All right, awesome. So our application is coming more and more to life here. Welcome back. It's great to still have you here in this project. And now that we have a good grip on the find method, let me introduce you to a close cousin of the find method, which is the findIndex method. And the findIndex method works almost the same way as find. But as the name says, findIndex returns the index of the found element and not the element itself. So let's see a great use case for findIndex in our application here, which is the close account feature that we have here. And in our application here, closing an account means to basically just delete that account object from the accounts array. So from this one here. Okay. So for example, if Sarah decides to close her account, then this account 4 will simply be deleted, and that's it. Now, to delete an element from an array, we use the splice method, remember? But for the splice method, we need the index at which we want to delete. And where could that index come from? And you guessed it, from the findIndex method. So let's first select this button here and attach an event handler to it. And so that's the button close here. So let's come down here to our event handlers. Now we have multiple. And button close dot add event listener, click. And then as always, our function in which we need the event object so that we can call prevent default. All right, let's just test if this connection works here. Let's log in. And now as we click this here, we get delete. So that's great. And now let's take a look at our flowchart here. And so, yeah, the first thing that we need to do is to check if the credentials are correct. So basically, if the username that is inputted here is equal to the current user and the same for the PIN. So that doesn't sound too hard, does it? So actually, let me leave that for you as a challenge. So just write this condition here to, again, check if both the user is correct and the PIN. All right, I hope you did that. So let's first take a look at the element names that we have up here. And so that's input close username and input close PIN. So I hope you figured these names out here too. And so let's now say input close username dot value needs to be exactly the same as the username in the current account. So current account dot username. So this needs to be true, and the same thing for the PIN. So that's input close PIN dot value, and once again convert it to a real number. And this one also needs to be equal to the current account dot PIN. And now let's actually do the deletion itself here. So as I already said, we are going to use the splice method to delete the current account. So let me actually start by writing that part. So we will take our accounts array and splice it at a certain index, which is the index that we're going to calculate in a second, and we will remove exactly one element. All right, and then the splice method actually mutates the underlying array itself, and so there's no need to save the result of this anywhere. All right, and so now let's actually calculate that index at which we want to delete. So we take the accounts, and now instead of find, we use findIndex. And once again, this one takes a callback function, which is very similar to all the other callback functions we have been using. So it's going to loop over the array essentially, and in each iteration, we get access to the current account. And then we want to find the one where the account has the username equal to the current account dot username. All right. And so let's then take a look at that index. And for now, let's actually take out this part. Okay. And we will then come back and maybe explain this a little bit better. So as I click this here without anything, nothing happens. So just as we intended. Then with the correct user and with a wrong PIN, also nothing happens. And notice that here you cannot see the numbers I'm typing now because this is a different format in HTML, but I'm still using the 4 ones. So 1, 1, 1, 1, and now something should happen. And indeed, we get the index number of the JS account in the accounts array. So let's take a look at that array here. And indeed, the Jonas one is number 0, right? Now, if we logged in here as Steven, STW with 3333, and now we need to confirm that here. So STW again and 3333, hit enter, and then the result should be down here. And indeed, it is. So that's element number 2. So 0, 1, and 2. So that is correct. And so our splice here would now indeed delete the user. Okay, so let's see here what we did in the findIndex. So just like before in find, we passed in a condition, so something that will return either true or false. And the findIndex method will then return the index of the first element in the array that matches this condition. So for which this condition here returns true. So again, similar to find, but it returns the index and not the element itself. Now you might notice that this is actually similar to the indexOf method that we studied before. So index of, and then here we can pass in some value. All right. Now the big difference here is that with indexOf, we can only search for a value that is in the array. So if the array contains a 23, then it's true, and if not, then it's false. But on the other hand, with findIndex, we can create a complex condition like this one. And of course, it doesn't have to be the equality operator here. It can be anything that returns true or false. Okay, and here we can simply check if the array contains this value or not, and if so, return the index of it. So both return an index number, but this one here is a lot simpler. And so now let's actually delete this element here. So this current user, or the current account. And now let's get back here to our flowchart, which I closed for some reason. And so we just did this part. Now we also need to log out the user. So that just means to hide the UI. And so that's similar to what we did here, where we showed the UI. Now we want to set it back to 0. So down here. So hide UI, and here delete account. Okay, and then of course, as we reload the page, as I said before, the user will then be back, of course, because we do not persist this data anywhere. All right. Well, the UI is still there. Oh, and that's because we didn't change this here to 0. But anyway, let's still take a look at the accounts object in this moment. And we see that we now only have 3 accounts left. And the one of Jonas is nowhere to be found. So this means that it actually worked. Now we just need to fix this here and set it to 0. And we also, just like before, want to clear these fields here. So that's the same as we did before. So similar to this one. Let me just copy it here. And this one we can paste right here outside of the if statement. And then just copy these 2 inputs here. So close username and close pin. This is set to 0. And now this should actually be complete. So let's see. Well, nothing happened. So let's see here. Oh, okay. This is a bug that I just introduced here. So basically, before even reading the data from this field, I'm already setting it back to empty here. Okay, and so therefore, of course, nothing can work. So this needs to be after the if-else statement. All right, but it's still a good thing that these small bugs keep happening here so that I can fix them and show to you that everyone makes this kind of mistakes. So let's try it again, 1111, and now it's gone. And as I try to log in now as this user, you see that nothing happens, and we get undefined down here. And that's because this user no longer exists now in our accounts array. Great. So one more feature implemented successfully. Now, there's just a couple of things I want you to note here. both the find and findIndex methods get access to also the current index and the current entire array. So as always, besides the current element, these other two values are also available, but in practice, I never found these useful. And second, both the find and findIndex methods were added to JavaScript in ES6, and so they will not work in like super old browsers. But don't worry, there is going to be a lecture a little bit later on how to support all of these old browsers. So we're getting closer to the end of this section, but there are still a couple of array methods left to learn. And so in this lecture, we're going to look at the sum and the every methods. And to start learning about the sum method, let's look back at the includes method that we studied earlier. So let's log to the console here, movements.includes -130. And let's also log our movements array so we can see it. And so indeed, the value of -130 that we're testing here is in the array, and that's why we get true here. And so we can use the includes method to test if an array includes a certain value. Now, however, we can only really test for equality, right? So basically, includes here returns true if any value in the array is exactly equal to -130, right? And so again, this is essentially testing for equality. But what if we wanted to test for a condition instead? And so that's where the sum method comes into play. So let's say that we would like to know if there has been any deposits on this account. So in other words, we want to know if there is any positive movement in this array. So any number above 0. So how would we do that? Well, we can say movements.sum, and now we can specify our condition here as always. So the same callback function, which has to return either true or false. And so a deposit is a movement greater than 0. So let's call this here any deposits and log it to console. And so indeed here we get true. So we have, of course, more than just one deposits here. But let's say we wanted to test if there is any deposit above 5,000. So easy enough, we can check if there is something above this value, and then it is false. Or we can check if there is something above 1,500, and so now it's true, because there is one movement here in that condition. And so you can see that these two methods here are kind of similar. The difference is that here it checks only for equality. So equality, but here we can specify a condition. All right. So basically this one here, we could rewrite it like this. So let's log it to the console here. So movements.sum -130. So this would be exactly the same. And so that's why we also get true in this one. Now for equality, this doesn't make much sense. We could then simply use the includes method. But for the case we need a condition like this one here, or really this one, then the sum method is perfect for that. Okay? And probably if I would have named this method, I would have called it like any. But of course, that's not the real name, but that's really what it does. If there is any value for which this condition is true, then the sum method will return true. All right? And now let's actually use this sum method to implement our missing functionality, which is to request a loan to the bank. So we will do that right here between the transfer button and the close button. And the sum method will become helpful for this loan feature because our bank has a rule which says that it only grants a loan if there is at least one deposit with at least 10% of the requested loan amount. So that sounds complicated, but we will implement this here in a second. So button loan, add event listener, click, and this is now always the same, as you can see. So starting by preventing the default action. So that's always going to be the first thing. And then let's take a look here at the user interface, because right now it is hidden. So you see that here we only have this one field. This field is called the input loan amount. Okay, so input loan amount. So that's the element with this long class name. So let's copy that actually. And so let's start by actually getting that amount here. So we already know we will have to convert this input dot value. Okay. And now we need to create our condition here. So first of all, that amount should be greater than 0. Okay. And now let's take a look here at our flowchart again. So this is what I was saying earlier. The loan is only granted if there is any deposit that's greater or equal 10% of the requested amount of loan. All right. So here we need now our second condition, which translates that. And so whenever we see or hear the word any, we can already know that it's probably a good use case for the sum method. So let me show it to you. So as always, we get the movements from the current account object dot movements, and now on there we call the sum method. So you already know by now how this callback function feature here works. So we get the current movement in the current iteration. And now here the condition is that movement needs to be greater or equal than 10% of the amount. So that's the amount divided by 10. Okay. Or we could also do times 0.1. And so that's exactly the same thing. So 0.1 here stands for 10%. And so let's keep it like this. Give it a save so that it looks nicer. And so, yeah, if at least one of the elements in the movements array has this condition, so is true, so basically is greater than 10% of the requested amount, then all of this here will become true. And so the sum method is perfect to be used in a condition like this. So when we need to test for something. Okay, so in case this is true, oh, and I closed our flowchart again. So in case this is true, then add a positive movement to the current data and update the UI. So that's easy enough. So add the movement here. So current account dot movements dot push, and then of course the amount that was requested. And then update the UI. And for that we already created our nice function which does all of the functionalities in one go. And so that's update UI, and we simply pass the current account into it. Okay, and that's it. Finally, let's also then clear the input field. So that value equals empty value. So we did that here and also up here. Okay. Let's log in. And so you see my deposits. My largest deposit is 3,000. And so the loan that I can request can be maximum 30,000. Okay, because 3,000 here is 10% of that. So let me try something bigger, so something really huge. And so now nothing happened. And again, in the real world, we would then probably get some error message somewhere here at the top or so. But in this case, we're not going to do that. Let's just try 5,000 now. And so now, indeed, it appeared here in our movements. And also, as you see, our balance was updated. And also here, our total income. Okay, now let's request 50,000. And so with this, you can now actually cheat. You can always create a little bit of a larger number. So now I can even request 500,000. And so that's cheating our algorithm, which is way too simple. But of course, this is just for testing purposes. All right. So that's how the sum method works. I hope that makes sense. And so let's now actually go back here and talk about the close cousin of the sum method, which is the every method. So let's write here sum and every. So again, the every method is pretty similar to the sum method, but as you might guess, the difference between them is that every only returns true if all of the elements in the array satisfy the condition that we passed in. So in other words, if every element passes the test in our callback function, only then the every method returns true. And that's why the method is called every in the first place. So let's test it out here now. So let's log to the console movements.every, and then with the same condition. So let's essentially check if all of our movements here are deposits. And well, indeed, they are not, and that's why we get false. However, we do have one account which only has positive movements. So let me show that to you. That's account 4. So account 4, all the movements are positive. So let's check it out now. So account 4, and then the same condition. And every is not a function. And that's, of course, because we are still missing the movements array. And now it is true. All right. And so that indeed proves that the every returns true if all the elements in the array satisfy this condition. Because in this movements array, all of the values are, in fact, above 0. Okay. So that's how the every method works. And I think it's quite straightforward, isn't it? And now to finish, there is one more cool thing that I want to show you. So up until this point, we have always written the callback function directly as an argument into our array methods, right? However, we could also write this function separately and then pass the function as a callback. So let's say separate callback. And so we could do this. So let's call deposit to this function. All right. And so this function here is exactly the same as these ones. But as I just said, there is no reason for them to being directly written here in all of these array methods. We could simply write them like this, and then all we would have to do is to call movements.sum, for example, and then deposits or deposit. And now we could reuse the same function for all kinds of different methods that require callbacks with a true-false condition. So that could be every or filter as well. Okay. And so here is the result of these three operations. And so here we get the expected results, and all by reusing this same function. Then if we wanted to change the function, all we would have to do is to change it here in one place, and then all the results would become different according to that. So in practice, that's something that we do sometimes, because this is of course better for the dry principle. So don't repeat yourself. That's always important, and it is important here as well. But anyway, with this small detour that we did here, let's now move on to learning about two more array methods. The next two array methods that we're going to learn are the flat and flatMap methods. And thankfully, these are very easy to understand. So let's go. So let's say that we have an array with some arrays in it. So essentially a nested array. So let's say 1, 2, 3, and then another array here, 4, 5, 6, and then even some values like this. So this is perfectly normal. But what if we wanted to take all these elements in the subarray and put all of these together in just one big array, which contains all the numbers here from 1 to 8? Well, that's pretty simple using the new flat method. And they say new because flat and also flatMap were introduced in ES 2019. So they are pretty recent. And one more time, they will therefore not work in super old browsers. Okay, and actually that's it for the flat method. So no callback function, just like this. And we get indeed our full array from 1 to 8. So this removed the nested arrays and flattened the array, which is why the method is called flat. So very nice, very simple, and no callback function this time. Okay, but now let's say that we have an array which is even deeper nested. So let's call it R deep. And so this one right now has only like one level of nesting. But let's say that these two here are in their own array still. And maybe these two here as well. So now we have an array inside an array inside an array. So let's see what happens when we flat this one. And we got the same result, but that's because I made this mistake. So we need to flatten R deep. And so now you see that we get this result, which still contains the two inner arrays. All right. So this means that the flat method only goes one level deep when flattening the array. So this 3 here was inside the first level of nesting, and so therefore it was taken out and is now in the main array, but then we still have this nested array in there. So we can fortunately fix that by using the def argument. So right now, basically flat is running with the 1 here as the def. And so if we run it with 1, which is the default, then we get this. But we can go 2 levels deep. And so now we get the same result as before. And that's because it now goes even into the second level of nesting and also takes the element out of that array. All right? So that's how flat works, but this example is not really that useful. And so let's go back to the bank accounts. So let's say that the bank itself wants to calculate the overall balance of all the movements of all the accounts. So how would we go about solving this problem? Well, first of all, we have all these movements stored in arrays. And these arrays are inside the objects in the accounts array, right? So in this array that we have been using, so accounts, so that's the one. So this is where we have our movements. And so the first thing to do is to take them out of here and put them all into one array. So how would we do that? Well, let's create a variable here called account movements. And so we could do accounts like this. And then what we want to create is a new array, but with the same length, which only contains these movements array. So that's what I was just saying, right? And so for that, we can use the map method. So in each account, take the account dot movements and so return that value into the new array. All right. And so now we have this array, which then in turn contains the arrays of all the movements. And so you see that now we actually have a nested structure here. So an array which contains other arrays. And so probably you can see where I'm going with this, because now I want an array which simply contains all of these values just in one array. So let's call this one all movements. And so it's going to be account movements dot flat, right? And we have only one level of nesting, and so there's not even a need for any parameter here, so for any argument. So now we get this nice array of the length 29 with all of these movements. And now all we have to do is to add them all together, which is pretty easy at this point, right? So let's call this one overall balance is equal to all movements dot reduce. And here we get the accumulator and the current movement. And we return accumulator plus movement, and we start with 0. So I'm doing this all very fast here because I already explained all of this multiple times at this point, right? And so here we get the final result of adding up all of these values that were originally, as we started, in the separate movements arrays that were in turn inside of the account objects, right? And of course we can make this here a lot more beautiful. So instead of doing all of this separately, as you already know, we can use chaining. So we start with this here. So building a new array out of the array of account objects. Then we flat that result, and then we add it all together. So like this. And then we log it all to the console. And this is then unnecessary. And actually, I will just delete all of it. Give it a save. And here we get the exact same result. Now, it turns out that using a map first and then flattening the result is a pretty common operation. So that's exactly what we have here. So first we map and then we flat that result. So that's exactly what we have here. And so to solve this, there is another method that was also introduced at the same time, which is flatMap. And so flatMap essentially combines a map and a flat method into just one method, which is better for performance. All right. So let's do this one here again, but this time with flatMap. So actually we can just copy it, and here I'm going to call it just a 2. And so here we will now use flatMap instead. And since flatMap also does mapping, it needs to receive exactly the same callback as a map method. Okay, so this is essentially a map method. All it does is, in the end, it then flattens the result. And so you see here the result is the same. Now just notice that flatMap here only goes one level deep, and we cannot change it. So if you do need to go deeper than just one level, you still need to use the flat method. So anyway, keep these two in mind whenever you find yourself in a situation where you have nested arrays and need to work with them. And believe me, that happens more often than you think. And I believe that even in the course of this course, there is going to be another situation. So we're almost finished with this section and with our application. But one feature that is still missing in our application is the ability to sort or movements. And so in this lecture, let's talk about sorting arrays. Now, sorting is a much discussed topic in computer science, and there are countless algorithms and methods of sorting values. And we might actually talk about this a little bit later in the course. For now, though, we're simply going to use JavaScript's built-in sort method. And let's start here with an array of strings. And let's call it owners. So Jonas, Zach, Adam, and Martha. Okay, and now all we need to do is owners dot sort. Okay, and so indeed we now get our array here nicely sorted, so alphabetically from A to Z. So this works indeed just as expected, right? Now this actually mutates the original array. So if we take a look at owners now, you will see that it also is now mutated. Okay, and so we have to be very careful with this method. So this is with strings. Now let's try it with numbers as well. So let's use our movements array here one more time. So I will start by logging it to the console so we can see it. And then let's also log movements dot sort. So give it some more space here. And if we take a look at the result here, this time the result is not really what we are expecting, right? These numbers are not at all ordered in any way, are they? And the reason for this is that the sort method does the sorting based on strings, all right? So that might sound weird, but that is just how it works by default. So basically what it does is to convert everything to strings, and then it does the sorting itself. And if we look at the result as if they were strings, then the result actually makes sense. So the minus here, you see, always comes first. Okay, so first you have all the minuses here, and so that's basically alphabetically the first string that occurs. And then afterwards, you have this one which starts with 1, before this 4, and then before this 6. So these three are alphabetically ordered if they were strings. And the same here. So you have 1 first, then 2, then 3, then 4, and then 7. So again, if they were strings, then this result would make sense. But they are not strings, and so we have to fix this. And in fact, we can fix this by passing in a compare callback function into the sort method. So this here does not work. Let's get rid of it. And so let's write movements.sort, and we need to give it a callback function. And this callback function is called with 2 arguments. And let's simply call them A and B. Okay. And these 2 parameters here are essentially the current value and the next value if we imagine the sort method looping over the array. However, in order to understand how the compare function works, so how this callback function here works and how we have to write it, let's just think of A and B as simply being 2 consecutive numbers in the array. And it doesn't matter which ones. So let's simply take these 2. So 450 and 400. Okay? So let's just compare these 2. Now in our callback function here, if we return less than 0, then the value A will be sorted before value B. And the opposite, if we return a positive value, then A will be put before B in the sorted output array. Okay, so let's use that in practice to sort the movements array in ascending order. And first, let me just write what I just did here. So if we return something less than 0, then A will be before B. But on the other hand, if we return greater than 0, then B will be before A. Okay? And so we can use this knowledge to sort our movements array now in an ascending order. So ascending order means that we want to go from small to large numbers, right? And to make this easier to understand, let's analyze the two numbers that we have here. So we have 450 and minus 400. And so if we want to sort these two in an ascending order, then we need to switch them. So this is A and this is B, right? But now we want to switch them to make them in an ascending order. So what we want here is B and then A. So BA, right? And so therefore we need to return something that is greater than 0. Okay, because that's the rule how the sort callback function works. So again, in the case basically that A is greater than B, which is what we have here, then we want to return something that is greater than 0. So let's write that. So if A is greater than B, return, and let's say 1. And the number here doesn't really matter as long as it's greater than 0. And else, or actually let's write it like this. So if B is greater than A, then return something negative. So just minus 1. Okay? And that's actually it. So let's log then the movements again here to the console, because here we are mutating the array, and then at this point it is already the mutated version. And now, as we see here, the array is now indeed sorted in an ascending order. All right? And so that is because basically the sort method keeps looping over the array and applying this callback function here until everything is in an ascending order according to the rules that we established here. Okay? So returning 1 here basically means to switch the order. And let's write that here. Switch order and keep order. So maybe that makes it also a bit easier to understand. So if we come back to one of these examples here, so let's say we have A and B 200 and 450. So in this case, we want to keep the order, right? And so therefore, that's the case in which we return something less than 0. So that's what we have here. And maybe it's easier to read like this. So A less than B, but of course it's the exact same thing. And then here again with our original example, this first one is greater, so the order has to be switched. And so here we have that situation where A is greater than B. Now, if we wanted to do it the opposite, so sorting in a descending order, we would simply do it exactly the other way around. So all we would do is to return -1 in this case and return 1 in this case. And so now the array is nicely sorted the other way around. So let's write that here. So ascending and descending. Let's also log the movements here. And great. So this works beautifully. And it's also going to work for strings. And you can try that out yourself if you want. Now, if we are working with numbers, then we can actually simplify this a lot by simply using some simple math. So let's take a look again here at our condition. So we already know that if A is greater than B, then A minus B would always be something positive, right? And the same here with A less than B. So if A is less than B, then we know that A minus B is always something negative. And something negative is exactly what we want to return here, isn't it? And so what we can do is take this and improve it dramatically. Because in fact, we don't need any of this. All we need is to say A minus B. And that's it. Let's check the result. And it still works the same. So let's recap what we did here. So again, we already know that if A is greater than B, then this will be a positive number. And so here we then return that positive number. It doesn't have to be exactly 1, just something greater than 0. Now, if it's the other way around, if A is less than B, then this operation will always be a negative number. And so therefore, then something negative is returned just as -1. But again, it can be any number. And by the way, if we return 0 here, so in case these two values are the same, then their position simply remains unchanged. All right? So let's do the same here. And so here it is the opposite. So B minus A. And as always, keep in mind that we are actually returning this value here. But we don't have to write the return because we're using an arrow function. So you see, it still works the same. All right. And this is basically most of what you need to know about sorting arrays with numbers. Now, if you have a mixed array, like with strings and numbers together, then this is not going to work. And I advise you to simply not use the sort method in these cases anyway. And that's because there's not really a point in doing so. But anyway, now that you know how the sort method works, let's go back to our application and implement it there. So let's first see in the demo version what I mean. So down here we have this sort button. And so this sort will basically sort these movements. So as we click the button, it will sort them in this descending order, which actually is an ascending order because remember, we are starting to display these movements here from the bottom up. Okay? Then as we click it again, it goes back to normal. So as we keep clicking, it orders and goes back to normal. And so let's implement that now. So we can give us some more space here. And now we will actually implement the sorting functionality right in the function that displays the movements. Okay, so let's first implement the sorting itself, and then after that we will implement the clicking on the button. So that's right here. So display movements. All right. Now what we're going to do here is to add a second parameter, which is the sort parameter, and by default we will set it to false. And now depending on this parameter, whether it is true or false, we will then order our movements or not. So sort the movements or not. And of course it is false by default because, well, by default we do want to show the movements just in the order they appear in the array. But then as we click that sort button, we will then call this function display movements with sort set to true. So let's now create a new variable called movements here. And this variable here, we will define it conditionally. And actually we cannot call it movements because that's already the name here of the parameters, right? So let's just call it movs, all right? And again, we will define it conditionally. So we say if sort, and so that's if sort is true, then we actually want to sort the movements. So the movements array that we get here as an input. So movements. But now we cannot do this. And that's because, keep in mind that the sort method will then order the actual underlying array. So the actual movements array as it is in the account object. But that's not what we want at all. All we want is to display a sorted movements array, but we do not want to sort the original underlying data. So what do we do here? Well, we simply take a copy of the movements array and sort that. And so that's what we use now slice for. And this is one of the situations that I was telling you about earlier, where we need to actually create a copy using the slice method and not the spread operator. Because here we are in the middle of a chain. And so we want to keep going after this. And so it's a lot better to simply use the method here so that we can then simply chain the sort method onto that. And now all we need here is our compare function. And now remember how in the user interface, so in our application, how the movements appeared in a descending order. However, that is because we start to display the values from the bottom up. And so actually we want to now sort this array in an ascending order. And to do that, remember we do A minus B. So I explained before why it works this way. Okay, but now if sort is false, so that's the default value, then movs should simply become movements. Right? Let's get rid of this comment here. Give it a save. And now here, of course, we then need to use that movs that we just created. And with this, we have essentially adapted our display movements function to support sorting. And again, we did that by allowing a second parameter, which is an optional parameter called sort. And then if sort is set to true, then the movements that we're going to use to display them will be sorted like this. And if it's set to false, then simply the regular movements as they are passed in will be displayed. And now all we need to do is to call this function here with sort set to true whenever the user clicks that sort button. So that button is called button sort. And so let's now create our final event listener or event handler here. So button sort add event listener. And as always, we start by preventing the default. So you can get used to this. And then here we want to call print. And then here we want to call display movements. And of course with current account dot movements as always. And then the second parameter we will set to true. So that's the sort parameter. And if we ever are in doubt, again in VS Code, it nicely shows us what we can pass into the function. So movements and sort. Now this is not yet the 100% working solution, and let me show you why. So, as I log in, let me almost remove this here. So let's click now the sort button, and beautiful, that worked. So the movements are now indeed sorted. But now if I click the button again, it will not go back to normal, right? And how could it? We never told it to do so. So let's find a way of solving this. And we will solve this by using a state variable, which will monitor if we are currently sorting the array or not. Okay, so that variable needs to live outside of this callback function so that its value can be preserved after clicking this button here, right? Because as you know, this function here is executed each time that we click the sort button. And so if we defined a variable here in this function, then it would be created newly each time that we click that button. And so we want to preserve that sorted state throughout all the clicks. So we start with this state variable set to false. And so that's because in the beginning our array is not sorted. So sorted is false. And so if it is false, then here this should be true. So we then want to actually sort the array. So basically here we want the opposite of sorted, right? And so that's where our not operator comes in handy. All right, so we're doing the opposite of sorted. When sorted is false, then we want to sort it. So we need true here. But if it is already sorted, then we again want the opposite, and so then sort should be back to false. Now the only thing that's missing is to actually flip this variable. Okay, and so for that we do sorted equal the opposite of sorted once again. And so this is what then allows everything here to work. Otherwise, even as we would click, this sorted variable would then never change. And so with this, each time that we click, we change sorted from true to false, then from false to true, and so on and so forth. So let's try it now, finally. And yes, great, that works beautifully. And so our job here is done. And in fact, this application is now complete, at least for this section. So great job, congratulations for reaching this point, for finishing this application. This is really an amazing achievement, and you can pat yourself on the back for making it this far. Now, there is still one or two array methods to learn, and so let's do that in the next video. The last thing that we're going to learn in this section is how to programmatically create and fill arrays. So far, we have always simply created arrays like this, right? So basically writing them out by hand, literally. So just like this, or maybe we might have done it also like this. So using a new and then the array constructor, and then passing in all the numbers here as arguments, and then that also creates this array, right? Now, in these cases, we basically already have our data. So, for example, 1, 2, 3, 4, all the way to 7. So that's the data that we already have. And so therefore, we could then manually create these arrays. However, we can actually also generate arrays programmatically, so without having to define all the items manually. And there are many situations in which this is necessary, and there are also multiple ways of doing it. And the easiest one is to again use the array constructor function. So let's create a new array here like this. And then I will pass in only one argument, 7. So what do you think is going to happen? Well, we might think that this is going to create an array with only one element, number 7, right? But actually it doesn't. Instead, it creates a new array with 7 empty elements in there. And it simply contains nothing. So this output is very weird indeed. And the reason for that is this weird behavior of this array function, which does it so that whenever we only pass in one argument, then it creates a new empty argument with that length. So if we don't know about this special particularity of the array constructor function, then this can lead to weird errors. Okay. Now, also, we cannot really use this X array for anything. For example, we cannot call the map method on it to now fill it up. For example, we might want to do this. So map, and then in each element, we might simply want to put something there, like a 5. But then you will see, well, actually we need to log it to the console. But you will see that nothing happened here. So this is not really useful except for one thing, because there is one method that we can call on this empty array, and that is the fill method. So that's a new method that we haven't studied yet, but it's very straightforward. So let me show it to you. So that's x.fill, and then all we need to do is to pass in a value, and it will then fill up the entire array with this specific value. Okay, and this does actually mutate the underlying array. So we can just change it there, and then simply log the entire thing to the console here. So this doesn't work. Let's take it out. And now we get this array full of 1s. But let's actually turn this off so we can experiment a little bit more with fill, because this method is actually a little bit similar to the slice method. So besides this value that we want to fill the array with, we can also specify where we want it to start to fill. So let's say only at index 3. And so we also can specify a begin parameter, and then it only starts at index 3, which is this one. So it will then fill it up until the end, unless we specify an end parameter, just like in slice. So let's say 5, and also just like in a slice, the final index here is not going to be included in the array. So just these two here are filled up. And of course, we can also use the fill method on other arrays. So it doesn't have to be an empty array. Let's say we actually define this here as an array. Okay, and then we can also fill that array. So let's say r.fill. Let's fill it with 23 at position 4 to 6. And again, it will mutate the original one. And so you see that we put these 23s in these two positions. So from 4 to 6. Let's say from 2 to 6 to put some more in there. Okay? So this is the fill method plus empty arrays. So empty arrays plus fill method. And with this, we created an array programmatically, so without actually having to write it down manually, right? So let's bring this part back also to see it. So it's an entire new array that we here just created with our code. And indeed, the fill method can be very useful sometimes. However, what if we actually wanted to recreate the array from our first example? So what if we wanted to create this R array programmatically? Well, for that, we could use the array.from function. So that's array.from. And this is how we use it. And this is actually something completely new. And we didn't see this before. So here we are not using the from here as a method on an array. Okay? Instead, we are using it on the array constructor. So that's why it's array.from. And this array here is exactly the same as this one. So this function. So again, array here is a function. And then on this function object, we call the from method. So that sounds confusing, but we will make more sense of it in the object-oriented programming section. But anyway, into this function here, we can first pass in an object with the length property. So let's set it to 7. And then the second argument is a mapping function. So it is exactly like the callback function that we pass into the map method. So to start, let's also programmatically recreate this array here of 7 1s. And so let's write a callback function here. And in this case, we don't even need any arguments, but we still have to write the function. So let's write an arrow function here, which will simply return 1 in each iteration. So no arguments, no current element, no current index, and nothing. So all we want to return is a 1, and that will then put a 1 in each of the array positions. So let's call this one here y, and then log it to the console. And indeed, we get here the exact same result that we had before. But in my opinion, this is a lot cleaner than using this weird new array behavior then and together with the fill method. So in my opinion, this is way nicer. But anyway, let's now take it one step further and actually create this initial array from 1 to 7. So array.from length equals 7, and then our callback function. And as always, we get access to the current element. So let's call it current first, and then the current index. And so the index will vary between 0 and 6. And so all we have to return from this function is I plus 1. Okay? So again, this callback function here is exactly like the one in a map method. So you can simply imagine that you're using this as a callback function in calling the map method on an empty array. Okay? And so as always, we get access to the current element and the index. And so adding 1 to the index will then give us values from 1 to 7. So z meant, yeah, here we go. Now remember how earlier I used a variable like this, so an underscore, which means a throwaway variable. And so this is another use case for using this convention, because we do not need this current value at all. But we still, of course, have to define something as the first parameter, because the index that we need is only the second parameter. But to denote that we are not using this current element, we simply write an underscore. Okay, and then other programmers will also understand this convention and automatically know that we don't use this parameter. Okay, so this is how we create an array programmatically, and I hope you can see all kinds of different use cases for this. For example, you could create an array with 100 random dice rolls. So maybe you want to try that out on your own, and that is actually one of the assignments that I have later here for this section. So there's going to be a couple of exercises, and this will be one of them. But you can try it out immediately if you feel like it. So try array.from to generate an array with 100 random dice rolls. Okay, see if you can do that. But anyway, let's now move on and see a more real use case of the array.from function. Now, this array.from function was initially introduced into JavaScript in order to create arrays from array-like structures. So remember how I talked about so-called iterables before? So things like strings, maps, or sets, they are all iterables in JavaScript. And so they can be converted to real arrays using array.from. Okay? And that's the reason also for the name of the function, because we can create arrays from other things. All right? Now, besides these obvious iterables that I just mentioned, like maps or sets, another great example of an array-like structure is the result of using query selector all. So maybe you remember that query selector all returns something called a node list, which is something like an array which contains all the selected elements. But it's not a real array, and so it doesn't have methods like map, for example. But it's not a real array, and so it doesn't have most of the array methods like map or reduce. So if we actually wanted to use a real array method like that on a node list, we would first need to convert the node list to an array. And for that, array.from is perfect. So let's do something here now. And let's say that we do not have the movements of our application here stored in an array. So let me show that real quick. So again, let's pretend that we only have these values So all of these movements only stored here in the user interface, but we do not have them somewhere in our code. So we don't have an array containing these values. But now, let's say we want to calculate their sum. And so therefore, we need to somehow get them first from the user interface and then do the calculation based on that. So let's create a variable called movements UI. So the ones that we get from the user interface. So array.from, and now here the element that we want to convert to an array. And so that's going to be document.querySelector all, and then it is the movements value class. I'm going to show it to you in a second. So movements value. So in our HTML, we can see that exactly this is where the value itself is stored. And so that's what we want to get. So these numbers, right? And so we are selecting all of the elements that have this class. All right. So let's just start by checking it out. Movements UI. But now we only get 2 elements here. And so that's the one that by the time we load this script here are already in the user interface. So it's this and this one here. So not the 7 that are loaded from the account object. So it's not going to be these 7 here. Okay. So if we wanted to actually select exactly these elements, we would have to do this code here on some event handler. So let's do that actually. Let's simply perform this action when we click somewhere here. Let's say here on this balance label. So it doesn't matter where we click. So that is called the label balance. So we can attach event listeners to every object. Okay. It doesn't have to be a button. So I think we never did this actually. But let's see what happens now. So let's log in again here. And again, remember that we are doing this so that we can now read these 7 movements from the user interface as we click here. And indeed, now it worked. So now we get these 8 movements here. And you see that indeed it is these values that we see now on the screen. All right. But now let me also show you that we cannot call the map method on it, because the map method would be useful to now actually get just the number. Because you see that here we also have this euro sign, and so we need to get rid of that. And so the map method would be perfect for that. So what we would like to do is, let's just do it here for now. We would love to do, take the current movement. All right. And so in this case, the movement here, well, let's just call it element actually, because right now it is a DOM element. So we would take this movement, which is, remember, one of these elements here. And so from this element, we need to take the text content. And then we also want to replace the euro sign with nothing, basically. So I'm using the emoji picker here again on the Mac, but you can just get the symbol from your text up there. So from the code we already wrote. And I want to replace it with nothing. But now you will see, as we try this again, that it's not going to work. And in fact, it does actually work. And that's because I was saying it wrong. Of course it's going to work, because this one here is already a real array at this point. So we created this movements UI using array.from. And so of course it is going to work already. It would not work if we did it directly on the result of the query selector all. Okay. So sorry for that mistake. So it did indeed work already. But we can make this even better. First, of course, we need to convert this to a number. But that is not the point here, actually. So the point is that we can use now the second argument of the array from a function here, which is, remember, the mapping callback. And so basically, we can simply put this entire callback right here as the second argument. Okay, and now this movement UI array is already the final array as we see it here. So let's just check that out and then make really clear what just happened here. So again, and as we click here, we get indeed all the numbers that we have here. So let's recap. We used array.from to create an array from the result of the query selector all, which is a node list, which is not really an array, but an array-like structure. And that array-like structure can easily be converted to an array using array.from. And then as a second step, we even included a mapping function, which then transforms that initial array to an array exactly as we want it. So basically converting the raw element to its text content and replacing the 0 sign with nothing. Okay, and so then in the end, we end up exactly with the array of numbers that we intended. And by the way, I'm not sure if I mentioned it earlier, but there is another way of converting this here to an array. So let me grab it here. So movements UI2, and then we can actually spread the result of this query selector all into a new array as well. So this also creates the array, but then we would have to do the mapping separately. And so actually I prefer this. So to me, the array.from function was a great addition to JavaScript in ES6. Okay, and that's actually all I had to tell you here in this video. So that was the last couple of methods and functions that we learned about arrays. And indeed, we learned a lot of methods in this section, right? Now, keeping all of them in your mind to solve different tasks is, of course, a very hard thing to do. And so to make sense of all this mess, in the next video, I will help you decide which array method you should use in each situation to solve different problems. So I did the math, and since the beginning of the course, we have studied exactly 23 different array methods. And that's really amazing. And not just because 23 is my favorite number, but because that means that you can now do everything you can imagine with arrays. Now, the problem is that choosing between 23 different methods is not always easy. And especially when you just started learning about them, right? So probably in your mind right now, there is a big confusion between all these methods and about which one to use when. So to help you out with that, I created this summary lecture with all the 23 array methods. And I believe that the best way to figure out which method to use in each situation is by starting to ask the question, what do I actually want from this method? So do I want to mutate the original array, or do I want a new array? Do I maybe want an array index, or do I want to retrieve an entire array element? Or do I want to know if an array includes a certain element? Or maybe I just want to get a new string to transform the array to a new value, or simply to loop over the array? Well, these are a lot of different scenarios, and by asking exactly these questions, we can now categorize the methods and then easily choose between them. So this is kind of a framework that I developed, and so let me go briefly through all of these different scenarios with you. So these are the methods that mutate the original array. So if we want to add an element to the original array, we can use push or unshift. So we already talked about all of these methods, so of course I will not explain them again. This is just a reference for you to keep. Now anyway, if we want to remove from the original, then we use either pop, shift, or splice. And finally, we also talked about 3 other methods that mutate the original array, which is the reverse, sort, and fill method. Okay, so keep in mind that you have to be careful because they do change the underlying array that we're working with. And that many times is not what we want. So if instead we want a new array, then we can use one of these methods. So if we want to calculate one array from the original, then we use map method. And this one we use all the time as it loops over the original array and creates a new one based on that. We can also create new arrays by filtering for a condition or by taking a slice of the original array. We can also concatenate 2 arrays and create a new array based on that. And finally, we can flatten the original array using flat and flatMap. Next, sometimes we need an array index. And for that, we have the indexOf and findIndex methods. Now, the difference between them is that findIndex can basically search for an element in the array based on a test condition that we provide in the callback function. But besides that, they are pretty similar and both give us the index of a certain element in an array. Now, if we actually need the array element itself, then we use the find method. And so this one again is based on a test condition specified in a callback function. Next up, sometimes it's very important to know whether an array includes a certain element or not. And for that, we have includes, some, and every. So with includes, we can simply test if an array contains a single value, while on the other hand, with some and every, we can specify a condition based on a callback function. So some is going to return if at least one of the elements in the array satisfies the condition, and every only returns true if all of the elements satisfy the condition. So these 3 methods all return Boolean values, which is very helpful in a condition. For example, in an if-else statement. Okay, so that's where you many times will use one of these methods. Next up, sometimes we want to transform an array into a string, and then we use the join method. Or we might want to reduce the entire array to just one value. And as we already know, for that we use the reduce method, just as we studied in this section. So in the reduce method, we use an accumulator, which is like a snowball, to boil down an entire array to just one single value. And that value can be of any type. So it can be a number, a string, Boolean, or even an array or an object. All right. And so in fact, we could replace some of these methods that we have here with a reduce. Now, if all we want to do is to just loop over an array without producing any new value, we use the forEach method. So remember, this one does not create a new array, and in fact, it doesn't create any new value. All we do in the forEach method is to basically just do some work, but not produce a new value. All right, and that's it. That's an overview of all the 23 methods that we can use on arrays. And it might be a good idea to somehow keep this overview handy. For example, print it out on a paper or just store it somewhere on your computer. Anyway, now all there's left to do in this section is to complete the final coding challenge. So let's do that right in the next video. Now, before we go to that coding challenge that I just promised you, let's actually practice these array methods a little bit more. And again, that's because I had many people actually request yet another practice lecture of these array methods. And so you asked for it, and so here goes that lecture. So again, here you can already see the next coding challenge, but let's for now focus a bit more on some array exercises. And of course, we're going to continue working on our accounts examples. And the first exercise I want to do here is actually a very simple one, in which all we want to do is to calculate how much has been deposited in total in the bank. So in all the accounts across the bank. So let's call that bank deposit sum. And so, as always, let's take our accounts variable, which is that array which contains all the four bank account objects. Now, the first thing that we need to do here is to somehow get all these movements that are in these different objects all into one big array, so that we can then from there filter the deposits and then add them all together, just like we have been doing many times throughout this section. So let's use the map method here, because we basically want to create a new array out of the accounts array. But now we want to create an array which only has all the movements. And so, as you know already, whenever we want a new array with the same length as the previous one or as the original one, then we use map. And our callback function here, again, each account is called like this. And then all we want to take out is account dot movements. And let's start by immediately taking a look here at this variable. And of course, missing the log here. And indeed, we get an array of arrays. And here are all the different movements. Now, how do we get all of these values out of the arrays and into the main arrays? So whenever we have an array of arrays, how can we basically remove all the values into the parent array? Well, remember that for that, we can use the flat method. So just like this. And now indeed, we got a big array with all of the movements that we had previously. However, I hope that you remember that we can even simplify this here even further. So this map and flat, because as it turns out, it's very common that we want to do these two operations at the same time. And so that's the case here. And so instead of map, we can simply use flat map like this. So that will apply or map callback function and then flatten the result. And so you will see here that the result looks exactly the same. And now all we need to do is to filter for the deposits. So basically for the positive values. And so this is nothing new at this point, and the same for now adding them all together. So we have done that many times before. So let's just write it out here as we already know how it works. And here we go. So the result is 25,180. And let's say that they are all in the same currency. So all dollars or all euros. So this part here was the same as we had done before. The only trick was really this part here. So getting all the different movements array out of the accounts array and then putting them in one flat array so that we could then filter and add them all together. Let me just add here a number. So that was exercise number 1. And now in exercise number 2, I want to count how many deposits there have been in the bank with at least $1,000. So let's call this here num deposits 1,000. And there are actually 2 ways of doing this. So I will start with the way that is probably easier, but then after that, I will actually save the same problem using the reduce method. So many people have asked me for advanced use cases of the reduce method because it is probably the most difficult of all of them. And so therefore, I want to show you how we can basically count things using the reduce method. But again, let's start with the easier solution here. And so if we want to count the deposits, basically now we have to do the same thing as we did here, right? So we have to take all of the movements and put them all into one array. And let's log that here already. And here it's accounts. And so you see we have a similar result to previously. And now what we could do here is to filter for movements greater than 1,000, like this. So movement greater than 1,000, which leaves us only with these. And then from that, we can simply take the length, right? And so this will then return 5. And indeed, this shows us that we got 5 deposits over $1,000. Let's say at least, so greater equal. All right, so that was one way of doing it. Let's comment it out, because as I mentioned before, I actually want to show you how we could do the same thing using reduce. So let's get rid of this part, because the flatMap, of course, we still need that. We still need that array with all the values themselves. Now, okay, so you already know that the callback function of the reduce method always has as a first parameter basically the accumulator. So that's like the snowball onto which we want to accumulate a certain value. So here, that is the sum, which we started at 0, and then onto that sum, we keep adding the current element, and then basically in each iteration, we returned that entire new value. So the previous sum plus the current value. Okay, so again, this here is the accumulator, which is like the snowball onto which we keep adding our snow, which in this case here was the sum. But now in this case, our snowball, so our accumulator, will be the number of movements that are greater than 1,000. All right, so let's call that the count, and then here again the current. Then here we're going to have the function body, and again we will start counting at 0. So this initial value right here is just like having any value outside of a loop where we keep storing a new value. And that new value might very well be a counter that we only update on a certain condition, which is exactly what we're going to do now. So we will say that whenever the current value is greater or equal than 1,000, then we want to return the count plus 1. And otherwise, we just want to return the count. So give it a save, and here we get our result. I think it was 5 previously. Let's just take a look at the array itself by simply logging it to the console here like this, or we should probably even do this to actually see the whole array. And you see that it is indeed 6. So before it was just 5 because I had it like this. And so you see there is one movement with 1,000, and so then it is only 5. But what matters here, and let's get rid of this. So what matters is that our reduce function here works. So we can even use reduce to basically simply count something in an array. So what's important to keep in mind is that we have this value here outside, so this accumulator, which we can use to reduce the array down to anything that we want. And in this case, it is a counter, but it could really be anything. And we will actually do something even more sophisticated in the next example. But for now, I want to bring your attention to this part here of the code. So this adding 1. right? So you know that there is an operator for simply adding 1. So let me duplicate this here. Then I will comment it out. And again, you know that we can simply use plus plus here like this, right? Or at least we think so, because now as I reload, we are back to this being 0. So why do you think that is? Well, there is actually something that I didn't tell you about the plus plus operator. And so I thought that this was a good opportunity to maybe clear that up. And for that, let's simply do a very simple example down here. Let's say let a equal 10. And then let's log to the console a plus plus. And so again, you see that a is actually still 10, even though we used this plus plus here. So why is that? Well, the plus plus operator does actually increment the value, but it still returns the previous value. So if we now log the a again here, you will see that now it is indeed 11, right? So the plus plus operator did its job here, but the thing is that when we use it like this, it will still return the old value, which here was 10. All right, and so the same thing happened here. So we did count plus plus, which then increased the value from 0 to 1, but the result of this expression here is still 0. And so 0 was returned here to the next iteration, and therefore, in the end, we will always have 0. So like this, it's impossible to increase the value to 1, 2, 3, 4, 5, and 6. So this is actually something really important to understand about the plus plus operator, and which I didn't make really clear before. Now, fortunately for us, there is an easy solution, because we can simply use the so-called prefixed plus plus operator. So we can write it before the operand, so plus plus a. And so now the result of this here should already be 11. So both of these should now be 11. And indeed, they are. And so if we do the same thing here, then that will now finally increment or counter here, and we are back to seeing 6 as our result here. So let me keep this one here actually just as a reference, again, because I didn't talk about this before. All right. So that was exercise number 2. And now let's go to exercise number 3, which will be an even more advanced case of the reduce method. And in this one, what we're going to do is to create a new object instead of just a number or just a string. Because why not? So we already know that reduce boils down an array to just one value. And so that value might very well be an object. It could even be a new array as well. And in fact, we could use reduce to replace many of the other methods that we have. So reduce really is like the Swiss knife of array methods. We could use it for everything. Okay, and with that being said, let's get started on this exercise, of which the goal is to create an object which contains the sum of the deposits and of the withdrawals. So basically, we want to calculate these two sums all at the same time, all in one go, using the reduce method. So let me call this one sums. And then we have to start again in this way. So we need to get all of our movements into just one array. So I'm just copying that. And then here comes the reduce method. So here the first element, as always, is the accumulator, which again I will just call sums. And then the second one is the current value. Here we will actually need a function body to write our code. And then we need the initial value of the accumulator as always. And as I was saying, the goal of this exercise is to create an object. And so our starting point then of course also needs to be an object. And this could be an empty object just like this, or we could of course also already start filling it. So let's say that we want to start with deposits of 0 and withdrawals at 0 as well. Okay, and now here in our function body, we can simply basically ask if the current value is a deposit or a withdrawal. And once again, we do that by checking if the value is greater or below 0. So if it's greater than 0, and here again using the ternary operator, so if it is, then we want to add the current value to the deposits. So to this value here in our object, right? Now here in this callback function, what actually is this object here? Well, it is simply sums, which is our accumulator, right? Because this here is always the initial value of that accumulator, so of this variable. So we can access the deposits on sums dot deposits, and we can then add the current value onto that. And if not, so if current is below 0, then we can add it to the withdrawals. Okay, now we're actually not yet done here, because remember that in an arrow function, the value is only automatically, so implicitly returned when we don't have a function body with curly braces. But right now we do here, right? And so therefore we have to explicitly, so to manually return the accumulator from the function. So that's how the reduce method works. We always have to return the accumulator from each iteration. Now, usually that happens implicitly, like here, but you already know that this function here has an implicit return, right? But this is easy to forget in these cases, so that's why I'm emphasizing it here. So again, we always need to return in the end the accumulator. And so now this should actually already work. So sums, and indeed we get all the deposits and all the withdrawals. And this value should be the same, as this one here, right? But now we calculated it in a different way and put it directly in an object by using the reduce method like this. So that's great. And let's actually destructure this object immediately. So we can do this. So we need to now use the exact same names as here. So deposits and withdrawals. And so here we can now log these two to the console. And indeed, we now get these two values here. Now this works just fine already, but I don't really like this part here so much. So let me just show you another way in which we could do it. So I'm just commenting it out here. Maybe you actually like this part here more, but we actually have some duplication here. And so let's fix that. So this part here is very similar to this part here, right? All that changes is the deposits and the withdrawals. And so we can actually do this. So here we can now conditionally say that we want to select either deposits or withdrawals based on this condition, right? So using here the brackets notation instead of the dot notation. So in this case, we will want to get the deposits and otherwise the withdrawals. And so then it's onto this value that we want to add the current one. And here I probably have some spelling error. And so we get the same result, but I think that this way here is just a little bit cleaner. But in any way, what matters here is that we were able to create a brand new object based on the reduce method. And this can be really helpful in many situations. And so please take some time to review this exercise, because this was really a great use case on how to use something other than a primitive value as the accumulator of the reduce method. And I would even challenge you to do this with arrays. So as a challenge, I would challenge you to recreate any of the examples that we did previously in this section with map, filter, and reduce to use only the reduce method. And that is totally possible. And so, yeah, you can try that out. You don't have to, and I will certainly not do that now. But as an exercise, and to get an even better understanding of the reduce method, you could totally do that. Now, this lecture is already running a bit long, but I still have one more exercise here for you. So let's quickly do that. And this one will not have anything to do with the accounts now, but instead, what I want to do now is to create a simple function to convert any string to a title case. So title case basically means that all the words in a sentence are capitalized except for some of them. So there are some exceptions. Let me try an example here. So this is a nice title would be converted to this is, and then the A is lowercase. So this is one of the exceptions. And then nice title. All right. So let's get to work here. So convert title case is going to be a function which takes a title and will then convert it. And so this is going to be a nice exercise combining string and array methods all in one function. Let me start by writing an example of a string here that we might want to capitalize. So convert title case. And let's actually try this one. And let's also try some more. This is a long title, but not too long. So just to see what happens here, and also just to put some of the different exception words in there. And is another title with an example. Like this. And so now we can worry about writing our function here. And let's start by creating an array which contains the exceptions, so the words that should not be capitalized. And the exceptions are a, n, the, but, or, on, in, and with. And there might be some other exceptions here, but this is just an example. You can always search for title case on Google and see the exact rules if you want to make sure that this really works. All right. And by the way, it is a bit of a common pattern to create an array of exceptions and then use that for some computation further down the road. I've done this myself many times, and so keep this technique in mind. But now let's go on to the actual conversion. So let's call it title case. And so, of course, we must work on this title argument that comes in. And so what should we start by doing? Well, first of all, let's do something that we should many times do with our input strings, as I mentioned before, which is to convert them all to lowercase. And this is especially important in this case because we are now working with capitalization. So we will capitalize some of the words, and so they should, of course, all be lowercase to start with. So that's then going to affect like this or this word here. Then we need to capitalize each word here individually, of course. And so we need to be able to work individually on each of the words. And so whenever that is the case, we need an array, right? So we need to split this string into an array so that these words, which are separated by spaces, each of them are going to be one of the elements of the array. So split, and then by the empty string, and then by the space character. And this is, of course, far from being done, but let's nonetheless already return this just to see if it works. Okay, so this is exactly what we just did. And so now let's work on these words. So basically we want to now go through the array and capitalize each of the words that is not in the exceptions array, right? So here, for example, the A is in the exceptions array, so we don't want to capitalize this word, but we want to do it for all the other ones. So basically we want a new array with all of these same words here, so the same 5 elements, but some of them capitalized. And so again, whenever we want a new array of the same size as before, we use map. And so now finally our old friend map comes into play again. So in this array, each element is a word, so let's call it that. And so again, we want to capitalize it. So let's just do it for starters for all of them. And remember that one of the techniques to doing that is to take the first character of the string, so like this, and put it to uppercase, like this, and then we simply add the rest of the string to it. Remember? So we did that previously. And so the rest of the string is basically taking everything starting at position number 1. So let's check that. And indeed, it worked beautifully. Now the only problem is that we have these exceptions here. So we have an A here and a but, and here is a with. And so we want to now use the exceptions array to exclude them. So how should we do that? So excluding kind of sounds like filtering maybe, but that's not what we want here. Because we still want to keep an array of the same length, we just don't want to apply this here to all the words. And so what we're going to do here is another logic. So we will do exceptions, and then we are going to check if the current word is included in that array. And so for that, we have another array method, which we studied many times before, which is called includes. So here we are checking for that word, and then, as you know, this will return a Boolean, so true, false, and then we can use that Boolean to basically ask if the word is an exception or not. So if the word is indeed included in the exceptions, then we want to simply return that word, right? And only otherwise we want to then return the capitalized version. So let's check. And indeed, that already worked. So A and but, and down here the with, are now no longer capitalized. Let's actually change or fix that here. Exceptions like this. So that looks better. So again, let's go over that logic here. So if the current word, so for example, this A here, is included in this exceptions array, then simply return that word. So without any modifications. But if not, well, then capitalize it according to this rule or this technique here that I demonstrated earlier. And so after that, it is actually really easy. Now all we have to do is to join the array back with the space, and there we go. that's actually it. I noticed that I just forgot one word here, which is and. So that's also an exception. Let's give it a save. And so this creates this weird situation where the first word of the title is actually not capitalized. And of course, we don't want that. But that's actually an easy fix. All we have to do is, in the end, then capitalize that entire title case, right? So basically doing this here on the final output that we have here. But let's not copy this. Let's instead refactor this into a standalone function. Let's put it in here actually, because we don't need this function anywhere else. So capitalize, it takes a string, and then here instead of word, we will use string to make it a general function, and then here we will call it with word. Right, so everything works the same. And then, as I mentioned earlier, when we return the title case, we simply capitalize it again. So just to make sure that a situation like this here does not happen. So title case, and here we go. Problem solved. Nice. So I hope that these were 4 nice examples for you to practice these array methods even more, so that you are now ready finally for the final coding challenge of this section. So let's go there right now. Welcome to the final coding challenge of this section. And this one can really be seen as a final test of this section. So we're going to practice most of what we've been doing here. And so let's get started. And in this challenge, we are back to Julia and Kate studying dogs. And this time they are studying whether dogs are eating too much or too little. All right. So eating too much means that the dog's current food portion is larger than the recommended portion, and eating too little is the opposite. And then there's also eating an okay amount. And so that's when the dog's current food portion is within a range 10% above and 10% below the recommended portion. And we will check that out in detail in a second. Okay, and so here are your tasks. And actually, each of them can be seen as a separate challenge. So there are 8 of them. So this is going to be a long one. And some of them are actually a little bit tricky, so a bit hard to solve. And that is one more time on purpose, so that you can actually challenge yourself and try to do a little bit more than just what we learned here in these videos. And as always, if you cannot solve one of them on your own, then just go ahead and watch the solution and then go back to the next point. All right, now anyway, let's get started here. And the first task is to loop over the array that contains the dog objects. So that is this object here, and this is the data that we're going to work with. So it's this array called dogs, and in each position of the array, we have one object per dog. All right? So your task is to loop over that array, and then for each dog to calculate the recommended food portion, and then to add it to the object as a new property. So do not create a new array here. Just loop over the array that we already have and add the recommended food portion as a property. And so I hope you know which array method you need to use for that. And to calculate that recommended food portion, simply take the weight of the dog and elevate it to 0.75 times 28. Then, next up, find Sarah's dog and log to the console whether it is eating too much or too little. Now in this one, it's important to keep in mind, or important to notice, that these owners are actually inside an array. And so this makes this task a little bit more tricky. And so again, that is on purpose. Next up, create an array containing all the owners of dogs who eat too much. So call this one owners eat too much, and then an array with the opposite. So with owners of dogs who eat too little. Then log a string to the console for each of the arrays that we created previously, like this. So Matilda, Alice, and Bob's dogs eat too much. So that's based on this array, and then based on this array, a string like this. Okay. Then afterwards, log to the console whether there is any dog eating an okay amount of food. All right. And so let's take a look at what an okay amount of food actually means. So here we have this hint too. And so being within a range 10% above and 10% below means that the current food portion, which is stored here in this property, should be greater than the recommended food portion that you calculated before times 0.9. So that's 90%. And at the same time, it should be less than 110% basically of the recommended amount. So these two conditions here at the same time mean that the dog is eating an okay amount of food. So basically, it's what we see here. So the current portion should be between 90 and 110% of the recommended. Then number 7, create an array containing all the dogs that are eating an okay amount of food. And I want you to reuse the condition that we created before here in number 6. Finally, create a shallow copy of the dogs array and then sort it by the recommended food portion in an ascending order. Now just keep in mind that the portions are inside the array's objects. Okay, so to sort this array is a little bit trickier than what we did before, because the value is now here inside of an object and not just in the array itself. But the way that we write the callback function is pretty similar. So we will still have the a and b parameters, but these are now objects. And so to compare the recommended food portion, you will have to get that property out of each of these objects. So yeah, that's it. It's probably going to take you some time, but what matters most is that you practice and that you don't give up. But anyway, let's take now like half an hour or even 1 hour to solve this one, and then I see you back here. All right, so let's get started with the solution. So the first one is to calculate the recommended food for each of the dog. Now, as I said, you should not create a new array, but simply loop over the already existing array, so this dogs array. Actually copy it here. So copy. All right. So looping over this array, and then to each object, we want to add a new property. And so the forEach method is the way to go here. Then each element is a dog. And what we want to do is to add a property. So dog.recommended food is equal to dog.weight elevated 0.75 times 28. And now let's take a look at the dogs. And indeed, now they have the recommended food. Now let's just get rid of this decimal part here. So let's say here math.trunc. So we used this one before. We simply truncate. So we cut the decimal parts. And so that's number 1. And now number 2. Let's check it out again. So we need to find Sarah's dog and then log to the console whether it's eating too much or too little. So basically we need to find the object here. So in this case, that's going to be this one. So we need to find this object and then compare the recommended food we just calculated with the current food. Okay, so the trickiest part here is going to be to find the owner. But I believe we can do it. So let's call this one dog Sarah. then it's dogs, and we use the find method because we want to find one element of the array based on a condition. So in each iteration, we have one dog, and now we want to take dog.owners, and now this itself is also an array. So it is this here. And what we want now is for this array to include Sarah. And so we can do this. Includes Sarah. And that's it. This is how we get our true or false value. So remember that in the callback of the find method, we need to return a true or a false value. And then the find method will return the first element for which the condition is true. And in this case, we get the true or false value by calling the includes method on the owners array. And so when the array of owners includes Sarah, then that condition is true, and then we are going to get this object. So let's just make sure here. And let's see. And indeed, it is the correct object. We need some more space here. This we don't need anymore. And now we just need to log to the console whether the dog is eating too much or not. And we already know that it's eating too much because the current food is 275 and the recommended is 191. So let's log Sarah's dog is eating. And here I'm going to use my old friend, the ternary operator. Sarah.current food. If it's greater than dog Sarah, the recommended food, well then here we want to have much. Because in this situation, the dog is clearly eating too much. Oh, and of course this needs to be here inside the curly braces. And here, now it's correct. So we're asking basically this question. So if the current food is more than the recommended, then the dog is eating too much, and else too little. And so indeed, Sarah's dog is eating too much. So that's the conclusion we had already reached by looking here at the numbers. Okay, moving on. Let's take a second here to look at the exercise again. So create an array containing all owners of dogs who eat too much. So let's copy this name, and then also one where they eat too little. Okay, so how are we going to do that? Well, we know that we want a new array based on the existing dogs array, right? And we want to create this new array based on a condition. So once again, we want to compare the current food to the recommended food. All right, and therefore the correct method to use here is the filter. Okay, so in each iteration we get a dog, and we're going to return whether this dog's current food is greater than the dog recommended food. Because here we are looking for the dogs that eat too much. And so that means that the current food is greater than the recommended. All right. So this will give us the dogs, but let's start by taking a look at this variable for now, even though we want the owners. So this one doesn't show it to us, but yes, so this dog here is eating more than the recommended, right? Now, we now want to get the owner, or actually the owners. So again, we want to create a new array based on an existing array, and this time this new array should have the same length as before. We simply want to take something out of the original array and put it into the new array. And so that means we're going to use map. So once again, we have a dog, and we want to return the dog.owners. All right. And now we have an array of arrays where one is Matilda and the other one is Sarah and John. And so finally, the next step to transform all of this into just one array is to call flat, right? And so indeed, we end up with this array with just one level and with all the owners of all the dogs that eat too much. So great. And maybe you can see here that we can actually do even better, because whenever we have a map combined with a flat, we can instead use flatMap. So let's transform this here into flatMap. And then we don't even need this part. And the result is the same indeed. Okay, and based on this one, we can easily create the owners where the dogs eat too little. So all we need to do is to invert this sign. Let's get rid of this one here. And so these are the other three owners, basically. Okay. Next up, our task is to create some strings. So let me just copy the strings. And so that's based on the arrays that we just created. All right, so these are the two strings. And actually, they will not be the same. So this is just an example. So here we see Alice, Bob, and Michael's dogs are together, and here they are not. So the string will be different, but that doesn't matter. So what matters is that here we have dogs eat too much. And so now all we do is to take the owners that we already have, eat too much, and essentially join them together using the separator string of and, like this. And so now we get this array here, Matilda, Sarah, and John, dog. So let's just add this, eat too much. And now the other way around, eat too little, and here too little as well. Beautiful. So we're making good progress here. Let's move on to number 5. So log whether there is any dog eating exactly the amount of food that is recommended. So whenever you see the word any, you can think of the sum method. So remember that the sum method will return true if at least one of the elements in the array satisfies a certain condition. So log to the console dogs.sum. And so one more time, we are comparing the current food with the recommended food. And this time we want to know if there is at least one dog eating exactly the same amount as the recommended portion. And so we use the equal operator here. So current and recommended food. And, well, there is none. Let's take a look at our dogs here just to confirm that. So these are different, these are different, these are different, and also probably, yeah, this is also different. And therefore, if all of them are false, then the sum method also returns false. All right, number 6. Log to the console whether there is any dog eating an okay amount of food. Okay, and so now this formula here comes into play. Let's copy it just so we see it down here. And so once again, the goal is to simply return true or false whether there is at least one dog eating an okay amount of food. So we need the sum method again. And now this a little bit more complex condition. So dog.the current food portion needs to be greater than the recommended times 0.9. So that's 90%. And then at the same time, so this, now let me just copy it here. So at the same time, the dog should also be eating less than 110% of the recommended amount. And so now we get true. So there is at least one dog, but we don't know how many. And so that's the task basically of the next point, which is to filter out all the dogs that are actually eating this okay amount of food. And for that, we should also export this condition into a separate function. So this is really just a function, right? So we can take it and store it into its own variable. And let's call it check eating okay. And then simply the function. And so here we can then use that function. And yeah, we still get the same result. And now, as I was just saying, the goal here is to create an array containing only the dogs that are eating an okay amount of food. So we want a new array based on an existing array, but only with some of the elements. And so it is time again for using the filter method. So dogs.filter, and now this is very easy because we already have this condition callback function here in this variable. And well, we only have one dog in this condition, as you see. So that's Michael's dog, where the recommended food is indeed pretty close to the current food. And so we consider that this is an okay amount of food to eat for the dog. Okay, almost ready here. So I told you this is a long one, but I hope you're having fun with this one. This kind of seems like a real world challenge. So like a real world task, doesn't it? So I took quite some time designing this challenge, and even that was also a lot of fun. But anyway, let's now create a copy of the dogs array and then sort it by the recommended food portion. So let me actually copy this so we don't forget what we have to do here. So we start by creating a copy. So dogs.copy, no dot, of course, just the name is dogs.copy. And so let's use dogs.slice for that. And actually we can call the sort method then immediately on that. Okay, so here we are going to need a callback function as always, which is the sorting function. And this always has A and B as the parameters. So we could call them something else, of course, here, but I like to always call them A and B. And actually we don't even need this block here. So remember that before, when we wanted to sort an array in an ascending order, we simply would do A minus B like this. But this was when we had an array simply like this. So just with numbers. But now we have these numbers here in objects. And so A and B are now the objects. However, the values that we want to subtract are in these objects, and we can simply get them out of there. So we want to sort by the recommended food portion, and so let's simply do this. And that's actually it. Let's call this here dogs sort, sorted, and then let's log that to the console here. Dogs sorted. Let's see. And yeah, that worked. Or actually, we cannot see it yet. So yeah, here is the recommended food. So we start with the lowest one, then 191. And you see that indeed it is in an ascending order, 284 and 376. Okay, so that worked. And so we finished this coding challenge. Phew, this was a lot of work, and as I just said, also a lot of fun. And I hope you felt the same, and also that you felt the same for this entire section. So this project was a great project in my opinion. It was a lot of fun to build it together with you and to put it together and design it in the first place. So I hope you're proud of what you achieved here. And one more time, I want to congratulate you for making it this far and still sticking with this quite long course. Anyway, with that, I see you in the next section where we will actually continue building on this project by adding a couple of new things to it. So over the last few sections, we have learned all about common JavaScript data structures and also strings. But now it's time to turn our attention onto two additional ways of representing data: numbers and dates. Now, these might be a bit less important than things like strings and arrays, but you should still know how to use them. And so in this section, we will continue working on the Bankist app, but now we will incorporate numbers and dates, and also internationalization and timers, which are another two very important aspects that you should actually know about. Let's start this section by learning how numbers work in JavaScript, how to convert values to numbers, and also how to check if certain values are numbers or not. And before starting this section, go ahead and open up your starter files for this section so that we can take a look here at the script.js. So as I said in the last section, in this one we will continue working on our Bankist application. Okay. Now, what's different here is that now we have actually different data. So we have only two accounts now here, and each account now has a new array which contains the dates of the movements. We also have the currency property and a locale property. All right. And so we will use this data in later lectures of this section. Okay. Then down here we have the complete application that we built in the last section. And if you want, you can go ahead and replace this entire code that I have here with your own code from the last section. Okay. What matters here is that we make the application work just as it was working by the end of the last section. All right. So again, we have the same application, only the starter data is a little bit different, but everything else is the same. And so now let's start learning a little bit about numbers. And the first thing that you should know about numbers is that in JavaScript, all numbers are represented internally as floating point numbers. So basically always as decimals, no matter if we actually write them as integers or as decimals. So we can show that by doing this. So we need a new terminal here. And so here is our application back again. Let's close this and open up the console. Give it some more space. And so you see that 23 is in fact the same as 23.0. Okay? And that's the reason why we only have one data type for all numbers. Also, numbers are represented internally in a 64 base 2 format. So that means that numbers are always stored in a binary format. So basically, they are only composed of zeros and ones. Now, in this binary form, it is very hard to represent some fractions that are very easy to represent in the base 10 system that we are used to. So base 10 is basically the numbers from 0 to 9, while binary is base 2, and so that's the numbers 0 and 1. Okay? So as I was saying, there are certain numbers that are very difficult to represent in base 2. And one example of that is the fraction 0.1. And that then results in very weird results like this. And this is kind of a classic or a running joke in JavaScript because this result should of course be 0.3 and not with all of these zeros here. But JavaScript simply has no better way of representing this number. So in base 10, 1 divided by 10 is simply 0.1. And so that's very easy to represent. But for example, if we were trying to do 3 divided by 10, then that is also impossible to represent for us, right? It would be this number here and 3 until infinity, okay? And so in binary, the same thing happens with 0.1. So we get basically an infinite fraction, and that then results in a weird result like this one. Now, in some cases, JavaScript does some rounding behind the scenes to try its best to hide these problems, but some operations, such as this one, simply cannot mask the fact that behind the scenes they cannot represent certain fractions. And by the way, many other languages use the same system, for example PHP or Ruby, and so don't let anyone make fun of JavaScript because of this, okay? So we just have to accept that it works this way because we really cannot do anything against this. So just be aware that you cannot do like really precise scientific or financial calculations in JavaScript, because eventually you will run into a problem like this. So point 2, which will result in false, which of course is incorrect as we know. This should be true, but well, this is simply an error in JavaScript that we have to accept. Okay? All right. Now that we know how JavaScript represents numbers, let's go back to actually working with them. So we know how to convert a string to a number, right? So that's like this. But there's also an easier way, so kind of a trick that we can use, which is to, or actually this should be a string, otherwise that doesn't make much sense. But as I was saying, there is an easier way, which is simply plus 23 the string. And this works because when JavaScript sees the plus operator, it will do type conversion. So it will automatically convert all the operands to numbers. And so therefore we see 23 here in both these cases. So in this purple color, which are numbers. So this here makes our code look a lot cleaner in my opinion. And so let's now actually go to our project and replace all the occurrences of number simply with the plus sign. So here, if I save it now, the prettier extension should get rid of the parentheses here, and it does. So here and here and here as well. And that should be it. Yeah, that's it. Great. And so our project will work the same, but the code is a little bit cleaner now. Okay, so here we converted strings to numbers, but we can also do something called parsing. So we can parse a number from a string. So on the number object, which is kind of this function here, but it's also an object in the end, remember, because every function is also an object. And this number object here has some methods to do parsing. So let's use parseInt. And so here we can now specify a string, and that string can even include some symbols. And JavaScript will then automatically try to figure out the number that is in this string. All right. And so here we get 30. And this is actually a number. It's not a string. All right. Now, in order to make this work, the string needs to start with a number. So if we have something like this, then it's not going to work and we get not a number. Okay. So this is a little bit like type coercion, but even more advanced because as we just saw, it tries to get rid of unnecessary symbols that are not numbers. And this can be very useful for example, in this situation, where we get some kind of unit from CSS and then need to get rid of that unit. Now, the parseInt function actually accepts a second argument, which is the so-called radix. And the radix is the base of the numeral system that we are using. So here we are simply using base 10 numbers, so numbers from 0 to 9. And most of the time we are doing that, and so we should always pass in the number 10 here. Okay, so that can avoid some bugs in some situations. And you see the result here is the same. But if we were working, for example, with binary, then we would write 2, and then the result would be completely different. In this case, we cannot even see it, but let's just keep using 10 here. So this is with integers. So that's what the int here stands for. So parse integers, but there's also parse float. So number.parse float. And let's now try 2.5 rem. And so now it reads the decimal number here from our string. So a floating point number. Let's see what happens if we used int. And then we only get the integer part, right? So it will then stop here at this decimal point. But that's of course not what we want. And by the way, we could even have like some white space down here that would not affect anything at all. All right. Now, by the way, these two functions here are actually also so-called global functions. So we would not have to call them on number. So this here also works. Okay. But this is the more traditional and old school way of doing it. Now in modern JavaScript, it is more encouraged to call these functions actually on the number object. Okay? So we say that a number here provides something called a namespace. All right? So a namespace for all these different functions like parse float and parseInt. But anyway, let's now explore another function of the number namespace, and that is the isNan, so is not a number. So number.is not a number. And we can use this one to basically check if any value is a number. Well, not any value, but more about that later. So for example, if we pass 20, then here we get false. And so is it not a number? False, right? So let's try the same with the string 20. And so here we also get false, all right? Because this also isn't not a number. It's just a regular value, right? But now let's try it by converting something. So for example, this string, if we try to convert it to a number, then this will be not a number, right? And so therefore it is true. So let's just do that here. So yeah, this works as well. And so you see, this is of course not a number. All right. But let's try something else. Let's, for example, divide 23 by 0. And maybe you know that dividing by 0 gives us infinite. Okay, so dividing by 0 is something that's not allowed in mathematics, and so it will give us infinity. So infinity is also not a nan, and so therefore we get false here as well. So let me just demonstrate that here. So indeed, this gives us this special value of infinity that also exists in JavaScript. And so this is not a number is actually not a perfect way for checking if a value is a number, because it doesn't consider this use case, and sometimes this might very well happen. And therefore, there is a better method called isFinite. So number is finite, and let's try it with the same numbers. So here we get true. Okay, so basically this should be the opposite now of this one, because this is not a number, but it is finite. Okay. Now if we try it with 20, the string, then here we get false, because it's not a number. And so this is actually better to check if something is a number or not. And I know this sounds a bit confusing, and the confusion comes from the fact that we have this weird thing here that is also called not a number. All right. And therefore I'm just telling you that the isFinite method is indeed the best way of checking if a value is a number. So a real number, not a string. All right. So let's try again this one here, trying to convert it. And we know that this here is not a number. So literally, this will be NaN, right? And so this should be false as well. And it is. And now finally, this last use case, which gives us infinity. And so it is false as well. So that's where the name of the method actually comes from. So is finite. And so infinity is of course not finite. All right. And so this method is the ultimate method that you should use to check if any value is a number, at least when you're working with floating point numbers. So if you are sure that you just need to check for an integer, then you can use isInteger as well. So let me just write here a comment as well. So this one you should only use to check if value is not a number. So literally not a number, this value. Okay. But usually in practice, I never use this. Whenever I need to check for a number, this is the one to go. Or if I'm using integers, then I use isInteger, as I was just saying before. So we can do this. Also, this is also integer, remember. And so both are true. Okay. But then, of course, if we try this here, it will be false. Now, in our project that we're currently building, there is not really a need to check if any of the inputs is really a number or not. And so in this particular case, we don't need to go back and change anything. But it's still good to know about especially this method here. So this is your go-to whenever you need to check if something is a number or not. And going back here, the parseFloat function should be your go-to whenever you need to read a value out of a string, for example, coming from CSS. So then you always get this, and it's very nice to be able to read the number out of this string. Let's now learn about some more mathematical operations and also about rounding numbers. And we have already been using lots of mathematical operations. For example, plus, minus, times, divided, exponentiation, and so on. And so we don't need to go over these again. So let's start here with the square root. And so just like many other functions, the square root is part of the math namespace. So math.sqrt. So this stands for square root. And so all we need to do is to pass in the number, and then it will give us the square root. And the same could be achieved using the exponentiation operator as well, by doing 1 divided by 2. And so that 2 is the square. So we want the square root, so we use 1 divided by 2. And actually we have to put this into parentheses, and now it works. All right, and the same would work for a cubic root, for example, of 8, which would be 2. And so actually this is, I think, the only way you could calculate a cubic root if you need it. Next up, let's get the maximum value of a couple of values, okay? So again, we use math, and dot max this time. So let's just use a couple of numbers here. And so, as the name says, the maximum value gets returned to us. And this max function here actually does type coercion. So it should now still give us 23. Okay. However, it does not parsing. So if we try 23 pixels, for example, it will then result in not a number. So this does not work. All right. And just as we have max, we also have min. Let's just put it back to 23. And now here we get 2. All right. Now, besides a couple of methods, there are also constants on the math object or on the math namespace. And so, for example, if we wanted to calculate the radius of a circle with 10 pixels, we could do that. So for that, we use math.pi. And for now, let's just take a look at that. And so it is this constant that you might know, probably. And so again, let's say that we get like 10 pixels from the user interface. So we can say parse float of 10 pixels. And then we simply have to square this value. This is how we calculate the area of a circle with this radius. All right. Now, another thing that is on the math object is the random function that we already have been using a couple of times. And it's very important to be able to generate good random numbers when we need them. So before, we have already created random dice rolls, remember? So that we did by math.random. And so this will give us a number between 0 and 1. So as I reload, you see I get different values. Then we multiplied this by 6. And then we removed basically the decimal part by doing math.trunc like this. Okay. Now the problem with this was that then the highest number could be 5. And so we simply added +1 to offset that truncation here. So that cutting off of the decimal part. And so now we're going to get values here between really 1 and 6. But now let's actually generalize this formula so that we can use it from now on to always generate random integers between two values. So let's create random int. And we want to pass in a minimum and a maximum. And then we want to return that number. So as always, we need to start by removing any decimal parts of the result of math.random. And then we will multiply this math.random by max minus min. Okay. And then we add that 1 back on. And so let me show you why we do this. So it is because it gives us a number between 0 and 1. So math.random is between 0 and 1, right? So if we multiply this by max minus min, then we get a number between 0 and max minus min. Okay? And now if we add min to all of this, so the minimum value, then we get min to max minus min plus min. So we added min on both sides here, basically of the equation. And so then we can cancel this minus min plus min, and we end up with a range between the minimum and the maximum value that we specified. All right, so let's just add that here as well. So adding that minimum that I just explained here in this last step. And so this is how we end up with a nice function which will give us always a number that's going to stay between min and max. So let's try that out. So random int, let's say between 10 and 20. And so here we see 20, and let's try it a couple of times. So I'm going to save this file here a couple of times. And you see that all of these results are always within this range. Now I maybe overdid it. Probably it's easier to just reload this page. All right, so we haven't seen any 10 or any 11 yet, but it's going to work just fine. And we will get it if we reload it even more times. Okay, next up, let's talk a little bit about rounding. And let's start by rounding integers. So you can add some comments to this here if you want, but I'm just going to leave it like this. I will just add here rounding integers. And so we have already been using math.trunc, right? So what this does is to simply remove any decimal part. And so we end up with 23 here, right? Let's just take this one out. All right. So again, this one simply removes any decimal part always. But we have also other ways. So we also have round. So math.round. And so this one will always round to the nearest integer. So this one is going to be 23 and the other one 24. Let's duplicate this a couple of times to save us some time. Then we also have ceil. And this one will basically round down. So both of these results should become 24. And so that's these two here. So line 318 and 20. Or actually, it's these two. So I'm confusing these numbers. All right. So both of these are 24 because they will both always be rounded up. And then we also have a floor. And so these two will both be rounded down to 23. And so that's what we get here. And by the way, all of these methods, they also do type coercion. So if we do this, then it's going to work just the same. Now you might think that floor and trunc are very similar. Let me just put this one down here. And indeed, they do the same when we are dealing with positive numbers. So basically, floor and trunc both cut off the decimal part when we are dealing with positive numbers. However, for negative numbers, it doesn't work this way. So let me compare them here. So trunc minus this and also floor. Okay, and so now this one here, just like before, gets truncated. So it simply removes this part, but floor now gets rounded to minus 24, because with negative numbers, rounding works the other way around. And so actually, floor is a little bit better than trunc, because it works in all situations, no matter if we're dealing with positive or negative numbers. And so here, let's go ahead and replace this with floor. So we're looking for a really generalized function here. So this random int function should work in all situations, even if we give it negative inputs here. And so therefore, we need to work with floor here. All right. So that's rounding integers. Let's talk about floating point numbers. Or we can also say decimals. And now with decimals, it works in a little bit different way. So let me show you how. So in decimals, we have to specify the number like this in parentheses. And then on that number, we call the toFixed method. Okay, and let's try it here with 0 first, just so we can see the results. And so you see that with 0, it is converted to 3. But this 3 is white here, while these other ones are pink or purple. And so this means that is actually a string, right? So toFixed will always return a string and not a number. And that's important to keep in mind. So if we set here instead of 0 the 3, then it returns 2.7 and it adds zeros until it has exactly 3 decimal parts, just like we specified here. All right. Now let's add something more here, like 2, 3, 4, 5. And let's say we only want 2 decimal places here now. So this should become 2.35. And indeed it does. Okay. And if we now wanted to convert this result to a number, then we simply would have to add the plus sign here. And then we already know that this here converts a string to a number. And indeed, now it is purple again. So with decimals, it works differently than with integers. And that's once again because things in JavaScript evolved kind of in a weird way in this kind of old language. And if the language was designed today, definitely this would be very different. But yeah, this is what we have to work with right now. Okay. Just keep in mind that this here works in a similar way than the string methods. So this is a number, so it's a primitive, right? And primitives actually don't have methods. And so behind the scenes, JavaScript will do boxing. And boxing is to basically transform this to a number object, then call the method on that object. And then once the operation is finished, it will convert it back to a primitive. Okay. All right. So once again, this lecture looked a little bit like a reference of a couple of different methods. But to make it a bit more fun, let's now apply some of this to our Bankist project. And the first thing that I want to do is to round the requested loan amount. So this one here. So this looks weird. Oh, it's because of this number. Okay. So we could use this application in this other page here on the other side, but I prefer to have everything here in one screen. But anyway, I can take a loan like this, right? With the decimal part. But in practice, I've never seen a bank giving out a loan like this. And so let's apply the rounding to the loan functionality. So that's here. And the rounding then needs to happen right here. So the value that we get from the loan here needs to be rounded down. Okay. And then we actually do not need to convert it to a number because as I showed you before, the math.floor method actually does type coercion itself. Okay. And we are using floor here because we simply want to round any value down. All right. So in this case, it would have been 150 and that's it. So let's try that again now. So let's ask for 150.56. And so now we get just this. Okay, probably I added one more zero there, but that doesn't matter. Next up, let's use the toFixed function or method to make our numbers here look a little bit nicer. So here, for example, we have this decimal part with the 2 numbers, but here then we only have the 0.9. And so this should be like 0.90. And here it should be 1300.00. And the same also up here. All right. So for that, we can use the toFixed function that we just learned about. And so let's do that in all the places where we display numbers on the screen. And so that's in these 3 functions. So display movements, display balance, and display summary. So let's start here at the top. And so here we have the first occurrence. So this movement here is a value. So it's a number that we display. And so on here, we can simply call .to fixed and then with 2 decimal parts. All right. And now let's just copy this from here. So display balance. So let's do the same here. And the same in the summary. And so that will then hopefully also fix this weird, really long number that happens because of the rounding errors in JavaScript that I just explained to you in the previous lecture. So everywhere we print a number, I will do this now. So, okay. Then also on this result and also on the interest. Let's give it a save. And that's a lot better. So it worked. You see, now we get 0.00. And here we also get nicely 0.90. And the same down here. We are now back to having just 2 decimal places, just as we requested, so to say. So this lecture was kind of a short overview of some more math functions, including some rounding and also some other stuff like getting the max and the min value. And yeah, so good to know functions. And of course, there are a lot more. So if you need something like logarithmical functions or sinuses, then of course you can always check out the MDN documentation. One operator that I didn't mention in the last lecture is the reminder operator. And the reason for that is that the reminder operator has actually some special use cases, and so it deserves a lecture on its own. So what is the remainder operator? Well, as the name says, the reminder operator simply returns the remainder of a division. So let's check that out. So the remainder operator is this one. So the percentage sign. And so let's check what 5 remainder 2 is. And it is 1. So why is that? Let's say we divide 5 by 2. And so then we get 2.5. But if we took only the integer part, so only 2, then the result would be 2. Okay? So if we did the division only until the integer part, then that result would be 2, because 2 times 2 is 4, but then there would be the remainder of 1, right? Because 5 minus 4 is 1. So we can say that 5 is 2 times 2 plus 1. All right, and so this here is the remainder, and therefore 5 remainder 2 is 1. Well, let's try another one. Let's say 8 remainder 2, or 3 actually. And so now the remainder is 2. Okay, and if we did 8 divided by 3, then we would get this number here. But again, if we only took the integer part, so 2, then we would only end up with 6. So 2 times 3 is 6. So let's write that. 8 is 2 times 3. So this 3 here times 2 plus the remainder, which is 2. So 6 plus 2 is 8. And so 2 is that remainder. And therefore, that's the result that we get here from the remainder operation. All right. So maybe you're not yet familiar with this concept. And so I hope that it made sense. Now, one thing that is many times useful in programming is to check whether a certain number is even or odd. So even numbers are 0, 2, 4, 6, 8, 10, and so on and so forth. And the odd numbers are all the others. So 1, 3, 5, 7, etc. So when is a number even? Well, it's even if it is divisible by 2. And divisible by 2 means that if we divide it by 2, the remainder is 0. So let's check that. So 6 is an even number, right? And so the reminder of dividing it by 2 is 0. And that's because dividing 6 by 2 is an integer number. So it's exactly 3. So 3 times 2, so this 2 here gives then 6. All right. But on the other hand, an even number is, for example, 7. All right. And so here we have the reminder as 1. And that's because 3 times 2 is 6. And then plus 1, which is the reminder, is 7 again. And so just like 5, which is also an odd number. Okay? And so now we can use that knowledge to check whether a certain number is even or not. So let's create a function is even, and a simple arrow function is perfect here. So if the remainder of n with 2 is equal 0, well then of course this will return true. And otherwise it's going to return false. So when it's 1, then the result of this function will be false. So let's use this. Is even, let's try with 8, 23, and maybe, well, something else. Doesn't really matter. And so intuitively, we know that 8 is an even number, and so we get true. This one is an odd number and an even number, and therefore we get the correct results. Okay? And so, of course, this works to check if any number is divisible by any other number. All right? And whenever the result of the reminder operator is 0, then that means that the first number is completely divisible by the second one. And again, this is sometimes very important to know in programming. So let's see another example here involving our application. Not really in practical terms, but just to have some fun. So let's select all of the rows of our movements. So yeah, let's check the HTML here. So each of the movements is this row, so this element with this class. And so let's select all of them, and then we will paint them a little bit based on some conditions. So let's select all of these elements. So all. So that's dot, and then this class name. And so this here will return a node list. And so let's convert it to a real array. And for that, this time I'm going to use the spread operator. So I will spread all of these elements into this newly created array. And then on that array, I can immediately call forEach. And so let's specify a callback function with the current element, which is the current row and the current index. All right. And now let's say that I wanted to color every second row of the movements. So all I have to do is to check if the current index is divisible by 2. So I, which will start at 0, then it's going to be 1, 2, 3, 4, and so on and so forth. So if I want to color every second row, then if I do this, then every second number will be divisible by 2, and every other second number will not. So I can just check if it's 0, and if it is, then I take the current row, take the style, and change the background color. And remember that we have to use camel case notation here. And let's change it to orange red. So just to make it a little bit fun. Okay. And actually, just like before, this here actually has to happen inside of a handler. So an event handler function, because this code here will execute right when we start our application. But then as we log in, we overwrite that with the deposits of the current user. And so let's again do that as we click here on this balance, just so that we have like any reference point. Okay. And now let's try this again. All right. And now as I click this label, well, like magic, every second row is now painted in orange red. So beautiful, right? Well, not really, but at least we know that our code worked. All right, let's do another one. So now let's say that I want to paint every third row also in even another color. And so I do the reminder of 3. And each time it is equal to 0, then I do set this background color to blue. All right. And so this here will be at 0, 3, 6, 9, and so on and so forth. While this one here is going to be, as we already saw, at 0, 2, 4, 6, and so on. And you see that there's going to be some overlap here, but that's not a problem. Here we are missing the R. Give it a save, and just try it one more time. So this is just for fun, of course, but there could be real applications to this. So you see that now every third row is indeed blue. So really nice looking effect that we just created here. But yeah, it's just to illustrate really how the reminder works. So whenever you need to do something every nth time, so to say, so every nth time, then it is a good idea to use the reminder operator for that. So here, for example, every second time, every third time, but of course this might then depend on your specific need, maybe in your application. So this is how we use the reminder operator, yet another one in your toolbox now. And with that, let's go straight to the next video. Starting from ES 2021, we can use a feature called Numeric Separators to format numbers in a way that is easier for us or for other developers to read and to understand. So let's say that we wanted to represent a really large number. For example, the diameter of our solar system. So let's say diameter, which is 287 billion and 460 million. And just from looking at this number here, it's really difficult to read and to understand it. So does this mean like 28 billion, or is it just 2 billion? Or really, what is this number? It's really hard to read like this. There's just too many zeros here, right? Now, to help with this, when we write a number this large in the normal English language, we usually use a 1000 separator like the comma. So we would write this number like this, right? And then it becomes really easy to immediately see that this means 287 billion and 460 million. And now, fortunately, we can do the same thing in JavaScript as well, using the new numeric separators. So numeric separators are simply underscores that we can place anywhere that we want in our numbers, and which will make it then really easy to understand and to parse numbers this large. So using the underscore here as a 1000 separator then makes it really easy to understand that this number here means in fact 287 billion. Now let's just log it to the console to see what JavaScript actually sees. And so here we see that in fact the engine basically ignores these underscores, so these numeric separators. It simply sees the number itself. And so what this means is that we can actually place the underscores, so the numeric separators, anywhere that we want. So let's do another example. let's call this one price in cents. And I'm going to set it to 345_99. And so again, using the underscore here then makes it really obvious that this is actually a price in cents. So of course, the number itself does again not contain the underscore. And so our price is indeed 35,599 cents. But by placing the underscore here, it makes it really obvious that we have first this value here and then this other value here in cents. And in fact, it's so obvious that we could even get rid of the cents part here in the variable name, right? So basically, we can use the underscore now to give meanings to certain parts of our numbers. So here we said that these are thousands, and here we said that these are cents. So let's try another one. Let's call this transfer fee. And here again, we place the underscore like this. And so here immediately it looks like it is $15, for example, and 0 cents. But if we did the same thing like this, so placing the underscore here, then it suddenly looks like 1,500, right? While in fact, it is the exact same number. So both of them are exactly 1500s, but just the underscore alone gives them different meanings. And so we can use that to our advantage whenever we write numbers in our JavaScript code. Now, another variable here called pi, and this one is to show you some restrictions as to where we can place the underscore. So pi is 3.1415, and we can only place underscores between numbers. So we could place it here, and there would be no problem at all. Let's just log it. But actually, the underscore doesn't make a lot of sense here. So let's remove it, and let's say we wanted to place it here. Well, here we get then an error because that is not allowed. It's also not allowed to place here, and also not at the beginning of a number or at the end. So all of these are illegal, and yeah, like this it works, but we can also not place 2 in a row. So the error message here is pretty explicit about that. Okay, and now just one final detail that we need to be aware of is that when we try to convert strings that contain underscores to a number, that will not work as expected. So let's try to use the number function that we learned before to convert a number. So of course, with this, it should work just fine, right? So we have 230,000, the number, or actually the string, and then here it converts to a number. However, if we place an underscore here, so if we wanted to have a numeric separator here, that would not work. So now it is not a number. So what that means is that you should really only use these numeric separators when you are writing down numbers like this. So really in the code. If you need to store a number in a string, for example in an API, or if you get a number as a string from an API, you should not use underscores in there, because then JavaScript will not be able to parse the number correctly out of that string. So it's not going to work as expected, and you will get this not a number that might then introduce bugs into your application. And the same is true with the parse int function. So here we do not get not a number, but we only get the 230. So only the part that is here in front of the underscore. Everything else will then be ignored. Let's now meet one of the primitive data types that we never talked about before, and that is BigInt. So BigInt is a special type of integers that was introduced in ES 2020. And so let's quickly take a look at it. So we learned in the first lecture of the section that numbers are represented internally as 64 bits. And that means that there are exactly 64 ones or zeros to represent any given number. Now, of these 64 bits, only 53 are used to actually store the digits themselves. The rest are for storing the position of the decimal point and the sign. Now, if there are only 53 bits to store the number, that means that there is a limit of how big numbers can be. And we can calculate that number. So that's 2 elevated to 53, and then minus 1 because the numbers start at 0. And so that is this gigantic number right here. And so this is essentially the biggest number that JavaScript can safely represent. Okay? Or actually it's 53. So this is the biggest number. All right? And it is 2 because, again, we are working with base 2, which is only zeros and ones. And this number is so important that it's even stored into the number namespace as max save integer. So this gives us the exact same number. All right. So any integer that is larger than this is not safe. And that means it cannot be represented accurately. So let's duplicate this line here. And for example, add 1 to this. And so you see that this is not correct, right? It only added one number to this one where it should have been added to. So if we do this, then we get the exact same thing. So we keep adding numbers here, and they are always the same. And so that means that JavaScript can simply not represent these numbers accurately. And so if we do calculations with numbers that are bigger than these, then we might lose precision. Okay? So in some numbers, it does actually work for some reason, but that's because JavaScript behind the scenes uses some tricks to still represent some of the unsafe numbers. But again, sometimes that works, sometimes it doesn't. And so that's why we call these unsafe numbers. So you see, sometimes these numbers are, or at least look correct, and sometimes they don't. Okay? So this can be a problem sometimes because in some situations we might need really, really big numbers, way bigger than this one here. For example, for database IDs or when interacting with real 60-bit numbers. And these numbers are actually used in other languages. And so we might, for example, from some API, get a number that is larger than this, and then we have no way of storing that in JavaScript. At least not until now. Because now, starting from ES 2020, a new primitive was added, which is called BigInt. All right? And BigInt stands for big integer, and it can be used to store numbers as large as we want. So no matter how big. All right, so let's say we need this number, and I'm just using random numbers here. So if I log this, then you see, well, this here, which probably does not have precision because, of course, it's larger than this. But if I use the n, then this will be a big int. So let's see that. And so this n here basically transforms a regular number into a big int number. And you see in the console here, it then also does look different. Okay? So this is a really, really huge number. But now JavaScript has a way of finally displaying this number here accurately. All right? We can also create big ints by using the BigInt function. So sometimes that's necessary, and then without the n. And so this gives us kind of the same result. Well, not really for some reason, but I guess it is because JavaScript will first have to still represent this number here internally before it can then transform it into a big int. And that's the reason why here from a certain point on, this second number is different. So this constructor function should probably only be used with small numbers. For example, like this. Okay, so this is how we create BigInt numbers. But let's now see some operations with these numbers. And, well, basically it's very simple. All the usual operators still work the same. So let's say we have 1 or 10,000 n plus 10,000 again. And so in this case, of course, we wouldn't even need a BigInt here, but this is just to demonstrate that the operators work just the same with BigInt. So we get indeed 20,000. And the same is true with other operations. So for example, a multiplication, let's try a really huge number, 10 times this other huge number. And so it then gives us this result. Now, what is not possible is to mix BigInts with regular numbers. So let's say we have huge, so some random number like this, and then we have a regular number, which is just 23. And so if I wanted to multiply them, so huge times num, then we would get this error. Cannot mix BigInt and other types. All right. And so this is where we then would have to convert this number here to a BigInt. And this is where the constructor function that I showed you here becomes necessary. And so now it is indeed going to work. However, there are two exceptions to this, which are the comparison operators and the plus operator when working with strings. So let's see that. So we can still do a BigInt and then, for example, greater than a normal number. So this still works and we still get true as expected. Okay. However, when we do this, so 20n equal 20, we will get false. But that makes sense because JavaScript, when we use the triple operator, does not do type coercion. And in fact, these two values here, they have a different primitive type. This is a regular number and this is a BigInt. In fact, we can check that, or at least I think we can. I never did this actually. But yeah, indeed, the type of this is a BigInt. All right. But however, if we do the regular equality operator, so the loose one, then this should still be true, right? Because then JavaScript does the type coercion, and so then it will coerce this one to a regular number, and then they're both the same. So just like, so it would even work like this. So this is one exception. Let's write that here. So logical operators are one exception, and the other exception is when we do string concatenations. So let's say huge plus, and then some string here is really big. And so you see, in this case, the number is then actually converted to a string. So even the BigInt number. Okay. Now, one other thing that I didn't tell you up here is that also the math operations that we talked about earlier are not going to work here. For example, we cannot take the square root like this, QRT of 16n. All right, so that doesn't work. All right, finally, let's take a look at what happens with divisions, because BigInt is indeed an integer. So what happens if we do this? 10 divided by 3n. And we know that with normal numbers, this would not be an integer, right? So 10 divided by 3 is 3.33 until infinity. So here. But with BigInt, it will simply then return the closest BigInt, right? Let's try it with 11 here. And so it simply basically cuts the decimal part off. Of course, with 12, it would then be 4, right? But with anything else, it will then cut off the decimal part. Okay, and basically, this is all that I have to tell you in an introduction video like this one about BigInt. So this new primitive type adds some new capabilities to the JavaScript language when you really need to work with like huge numbers, just like this one here, for example. Now in practice, you will probably not use this very much, but it's still good to know that BigInt exists and also how it works. When we build real-world applications, one type of data that comes up all the time is dates and times. So let's learn the fundamentals of dates and times in this video so that in the next one we can then implement them into our application. Now, dates and time can be a little bit messy and confusing in JavaScript. And so just like with numbers, I will try to make the fundamentals here as clear as possible. So first, we need to actually create a date. So create a date. And there are exactly 4 ways of creating dates in JavaScript. I mean, they all use the new date constructor function, but they can accept different parameters. So let's see how. So the first way is simply to use the new date constructor like this. And then we can assign this to a variable. And let's just call it now. And then here I'm logging now to the console. And so we get the current date and time at this very moment. So you see that Sunday, August the 2nd, 2020, and plus this time here. Next up, the second way is to parse the date from a date string. So again, we use new date, and then we can pass in a string. And for example, this string here would work just fine. For example, just this part here. Okay, so simply giving JavaScript a string here, and it will then automatically parse the time based on that. And so that's the second date that we get here. But we can also, of course, write a string ourselves. For example, let's try Christmas here. So we can even write December 24, 2015 or something. And so indeed, that works. And we even get the day of the week here. So JavaScript is pretty smart in parsing out this string that we write here. Now, however, it's generally not a good idea to do this because it can be quite unreliable. All right. However, if the string was actually created by JavaScript itself, then of course it is pretty safe. So actually in our accounts object, or in our account 1, for example, we now have these dates. So movement dates. And so let's try to parse this string here. So let's create a new date object in JavaScript based on that string. So that's in account one dot movement dates and then 0. All right. So again, this is okay because it was JavaScript who created that date that I just showed you there. So this date here. And by the way, this Z here means the UTC. So that's the coordinated universal time, which is basically the time without any time zone in London and also without daylight savings. So that's based on a string, but we can also pass in year, month, day, hour, minute, hence even second into this constructor. So let's say 2037 and 10 19, 15, 23 minutes and 5 seconds. So indeed, we get November 19, 2037 at 15 hours, 23 minutes, 5 seconds, just as we have here. Now you might have noticed that here we have 10, but November is actually the month 11, right? And so that means that the month here in JavaScript is 0 based. And that's a little bit weird, but well, we can just get used to that, right? Now, what's cool about this is that JavaScript actually autocorrects the day. So let's try this here again differently. So let's try November 31st. But we know that November only has 30 days, right? And so if we take a look at this, it will then autocorrect right to the next day. So that's going to be December 1st. And we can even try November 33rd, which should then be December 3rd. Okay, so this sometimes is actually pretty useful. Finally, we can also pass into the date constructor function the amount of milliseconds passed since the beginning of the Unix time, which is January 1st, 1970. So let's see that. So again, new date. And if we pass in 0, so 0 milliseconds after that initial Unix time, then indeed we get January 1st, 1970. Okay, and this will actually be pretty useful, even though it looks a bit strange. And let's now create a date that is 3 days after this. And so that is essentially 3 times, which is 3 days, and 1 day is made out of 24 hours, which is made out of 60 minutes, which is made out of 60 minutes, which is made out of 1000 milliseconds. And so this is how we convert from days to milliseconds. So 3 days times 24 hours, which is the number of hours in 1 day, times 60, which is the number of minutes in 1 hour, then times 60, which is the number of seconds in 1 minute, and then times 1000 to convert to milliseconds. And so now we get January 4th. So that's exactly 3 days later. Okay, and this number that we calculated here, let's actually calculate it also here. So this is the timestamp. So we call this here a timestamp of the day number 3, essentially. And we will see why this is useful a little bit later. Now, these dates that we just created here are in fact just another special type of object. And so therefore, they have their own methods, just like arrays or maps or strings. And so we can use these methods to get or to set components of a date. All right. So working with dates here, and let's now actually create a date again. And this time we're going to store it in a variable. Let's call it future. So new date, and let's actually use the same as this one. Okay, just without the seconds, that's not really necessary. Okay, let's just log it to the console here to make sure. Okay, and let's, for now at least, just comment out these here. So we already know how it works. Now we just want to work a little bit with this particular date. So we can use future, which remember is simply this object here, and then the method get full year. And so indeed we get 2037. There's also get year, but never use that. Okay, always use get full year. Don't make the mistake of using that other one. Next up we have get month, and remember that this one is 0 based. So 10 is actually the month number 11. Then we have get date, and this is actually the day. So I think that this method has a little bit of a weird name. And so that's because get day is actually not the day of the month, but the day of the week. Okay, And 0 here is Sunday, and so 4 is the Thursday. So we saw already that it's Thursday, and so that's equivalent to number 4. And then besides these, we also have 3 more, which is get hour, or hours, minutes, and seconds. So sometimes these can be pretty useful to work with a date. Besides that, we can also get a nicely formatted string. So basically similar to what we have up here, to ISO string. All right, so this is the ISO string, which follows some kind of international standard. And maybe you noticed that this is actually similar to the string that we used before, coming from account 1. So that's movement dates, right? So these were generated by exactly this method. And so that's one of the very useful cases, is when you want to convert a particular date object into a string that you can then store somewhere. Finally, we can also get the timestamp for the date. And remember that the timestamp is the milliseconds which have passed since January 1st, 1970. So get time. And so we see that this huge amount has passed, well, since that date. And now we can take this number and reverse this. So if we wanted, we could now create a new date only based on these milliseconds, and it would then give us exactly that same time. So you see, it's the same as this one, right? And so simply based on the milliseconds that have passed since January 1st, 1970. And timestamps are actually so important that there is a special method that we can use to get the timestamp for right now. So if you want simply the current timestamp for this exact moment, then you don't even need to create a new date. All we have to do is to call date.now. And that then gives us this timestamp. Okay. Finally, there are also the set versions of all of these methods. So let me just show you the one for the year. So I'm not going to go through all of them here. And so future.set full year. And this again is a method. So let's set it to 2040. And then we can take a look at our date. And so now it is November 19th, 2040. And of course, then the day of the month here has changed. And so yeah, there also exists set month, set date, set day, and so on and so forth. And these also perform autocorrection, just like here when we create a new date. Okay, so that's basically all the methods that you need to know about dates. And these last here are all quite intuitive, and all you need to know really is that there are all these different ways of creating dates. Now in the next video, we will then sum up what we just learned here to add dates to the Bankist application and make our project even better. Let's now implement dates in our application. And to see what we have to do, so where we have dates in our application, let's go to our demo here. And so we have the date first here, and then also in all of these movements. So each of them here, besides the deposit and the value itself, like we have it now, we also now need the date here. And so that's the reason why in our account objects, we actually now have the movement dates. It's so that we can display them here. But let's start with this date here. And actually the very first thing that I want to do is to basically fake it that we are always logged in. Okay, so let me do that here. Fake always logged in. And so this way, we don't have to always log in each time we want to do something. So to that, let's set the current account to account 1. Then let's call update UI with that current account. And also we need to make the user interface visible with this here. Okay. So these 3 lines will now make it so that Jonas is automatically logged in, except for the message here, but that doesn't really matter. Okay. So as I was saying, let's start by displaying the current balance here. So as I was saying, let's now create this date here. Okay. And let's check out the class name. So that's as always a little bit hidden. So it's the class date. Okay. And so that is already selected at label date. And once more, let's start by setting the state outside here of any callback function so that we can see the effects as we implement our code. So anyway, let's start by creating the current date. And so remember, that is simply by doing new date. And so that is basically right now. However, we don't just want to print that. So let's see how that would look like. So label date, as I have already selected, which again is this element with the class of date, and then text content, and let's set it to now. And so this result here is not exactly what we want, right? So instead, we really only want the day, the month, and the year. And I want to display it in this format. So I want day, then month, and then year. And so this is how we display it in Europe, or at least in Portugal, where I am located. Okay. Now, of course, you can format it in any way that you want. For example, how it looks like in your country, but I will do it like this now. Now, later in this section, we will learn about something called internationalization, which sounds very complicated, but it will allow us to format dates and time according to the user's location, basically. So if the user was in Portugal, then the date would automatically be formatted this way. But if the user was, for example, in the US or in India or wherever, then the date would be formatted in the way that it is usually formatted in that country. All right? So to do this, we need to get the day, month, and year. So let's create variables for each of them. All right. So we take now, and then we call the getDate method, just like we learned in the last video. Then let's take the month, which is now.getMonth. And remember that this one is 0 based. So I'm going to add 1 here. And then the year, which is now .getFullYear. And actually, let's also get the hour and the minute so we can display that as well. So get hours and const the minutes. Get minutes. Okay. And now that we have that, all we have to do is to build a nice string with that. So that's the day slash the month slash the year. And then I want a comma and the hour and the minute. So min. All right. And that looks a lot better. Now here in Portugal, whenever the month and the year is only 1 digit here, then we usually write 08 and 02. So basically we pad this number here with a 0 on the left. All right. So let's do that with the day and with the month, because this is actually a good use case for this method that we studied earlier. So on the day and on the month, we want to use dot pad start. And actually this needs to be a string now. And so let's make it a template literal. Like this. So basically this is now a string. And so on that string, we can call pad start. And then we want this always to be 2 characters long. And we want to pad it with a 0. And probably just writing 0 would work just the same. And so now we get 0, 2. But if the day would be, let's say 12, then that 0 will not be added because the final length that we're looking for is always 2. Okay, and the same with the month. So let's copy it here. And beautiful. So that looks perfect. And now let's move on to actually use the dates here on the movements. Okay. Just keep in mind that, of course, as the time goes on, this value here is not going to change. So this is static, right? So if we wanted to keep displaying the actual time, we would need something called a timer, which is something that we will do by the end of the lecture. We will not do it for this, but we will implement a timer like this. Maybe you have seen it counting down here. So this logout timer. All right, so this time here is going to stay static, but yeah, that's not a big deal for now. But anyway, let's now go to the function which displays these movements. So display movements. So here it is. All right. And so now besides the movements, we also want to display the times of these movements. But now we actually have a problem, because into this function, we are only passing the movements array itself, right? However, we also want the, let's see, we also want the movement dates. And so the best thing to do is to simply pass in the entire account into this function here as well. So just like we already have it in these two, where we already passed in the entire account, let's do the same here as well. So just the account. And then here we need to say account.movement and here account.movements. And finally, where we call this function, we then need to pass in also the entire account. And so that's here in the display UI function. Okay. And so now it is a good thing that we have this refactored function that we created in the last section, where we call all of these methods here only in one place. And so now we only needed to change calling this display movements function here in this one place. And so that's the whole goal of refactoring. It is making it easier to implement new features as time moves on. All right. So let's see how we could do that. So in here, we are looping over the movements. So that's this array that we compute here, which is whether the sorted movements or simply the movements themselves, right? So we are looping over this, and in each iteration, we are generating this HTML. And so now we simply need to add one more element here to this HTML, which is going to contain that date. So let's do that. So in our HTML, we can see that there is this element here called movements date. So let's copy that and paste it right here after the type. Okay. And so let's actually create a variable out here and then put that variable right here. Let's call it display date. Okay. Now, where is the date actually coming from? Well, as we already know, it is in the accounts.movement dates, right? And so here we are looping over the movements, And so at the same time, basically, we also need to loop over the movement dates. Okay? But that's not a problem because we already have the index here. And so what we can do is to write account or ACC dot movement dates, and then we take it at position I. So that is the current index in the movements array, and the same index is then going to point to the equivalent date in this movements date array. All right, so this is a common technique of looping over two arrays at the same time. So we call the forEach method on one of them, so that's the movements, and then we use the current index to also get the data from some other array. Okay, and so that's going to be at the same position because we're using the same index. So let's create a new date out of this, because as we saw before, this is going to be a nicely formatted time string, right? And so we can use that string to create a new date object. And we need that object so that then from there we can call our usual methods to get the date and the month and the year. Okay, so that's the reason why we need to convert these strings back into a JavaScript object, because only then we can actually work with that data. And now let's actually create these same variables that we already have here. So there's no need to repeat it all. Let's actually get all of this and then delete what we don't need to make this a little bit faster. So we don't need the hour and the minute. So we don't need this. And we want to create this variable called display date. So the date that we're ultimately going to use here. Display date. And now here we need to change from now to date like this. All right. And we see it already worked. Great. So let's compare it actually here with the dates. So July 12, 2020. And yeah, that works. Here then we have 11, which for some reason is also 12. But I guess it's because we're close to midnight here. And so for some reason, probably it then changes over to the next day. Then here we have 27 of May. And so that's also what we get here, all the way to the last one, which is 18 of November, so 2019. So this is accurate. Great. Now, when we click here on the sort, it's probably not going to work. So we get some kind of error here. So cannot read property slice of undefined. Let's see why that is. Well, that's weird, because account.movements here is clearly defined. It shouldn't be undefined. Let's set this here to true by default. And so, well, now it is sorted. So very weird that we get this bug as we click here. Let's just log to the console. But indeed, this one here will be not undefined. But actually it now is undefined. So we get account.movements is undefined right now. And that's weird. But I guess it has something to do with the fact that we faked or log in here. So never mind. Let's take a look at this later. Okay, let's just not sort for now until we are back to having our application normal. All right. So actually, let's take this code here now and put it into the code that is executed when we log in. So besides this welcome message, we then also want to create the current date. Okay, so it's back to the original now. Let's now log in. And then we get the message here and the correct date. But now what I wanted to show you is what happens when we request a loan. So you see that we get this error here, right? And that's because this movement doesn't have any date, right? And that's why we get not a number in all the three values. So we need to fix that. So essentially, whenever there is a new transfer or a new loan, we need to not only push the new value into the movements array, but also into the movement dates. All right. So let's actually see that in code. So that's account 1. And so we see that the movements has now 9 elements, while the dates only has 8. All right. So we need to fix that. So let's come here to the transfer. And then besides doing the transfer and updating the UI, we also need to add transfer date. But that's easy enough. All we have to do is current account dot movement dates dot push, and then simply create the current date. So new date, and that's it. So JavaScript will then automatically convert this date here into a nicely formatted string. All right. And now the same here also for the receiver, because the receiver also gets a new movement here. Okay. And so they also need a new date for that movement. Now, as I told you also in the last section at the beginning of the project, in the real world, we would probably have an object for each movement. And so that object would then contain the amount, the date, and some other information about the movement. But I don't want to restructure the entire application now, and so therefore I simply created this separate movements dates array. All right. Now let's just take this here and also add it to the loan. So that's right here. So add loan date, and that should be it. So just to make sure here, let's really log in again. All right. And now I'm going to request this loan. And now we get the current date. So August 2nd, just as we have it up here. Okay. So let's see now the account. So account 1. Let's take a look at the movement dates. And so indeed, this is the one, or actually this is the one that I just added. So this looks a little bit different from these ones, because actually it is really the object itself. All right. So that's not good. So let's instead use the toISO string right here on the date and do the same also up here. Okay, and let's see if that fixes it then. Okay, so probably there was some error here because we're back to having not a number. And, oh, actually I need to take a look at account 1 now again. And so let's check out the latest date. Oh, and I didn't call the method. That was stupid. Actually, this is something that happens to me quite frequently with these date methods, because we don't have to pass anything in there. And so there's a tendency to forget that we even need to call the method. So don't make that same mistake. All right. And now it works indeed. So let's check if the string looks nice with the same format as all the others. And yeah, it does. And so with this, we finished one more lecture. Now here I'm actually seeing something weird. So it's 19:1, but this should kind of be 0:1, shouldn't it? So we need to apply some padding to that as well. So that's a good coincidence that we are just at this time where I can see this. So let's go ahead quickly and fix that right here in the login callback. So that's here. And so essentially what we just need to do is to add this part to the hour and to the minute. So we make all of them a template literal again. And then like this. One more time. Now, okay, to see the effect, we need to log in. And beautiful. So that's a lot better. And now we indeed finished this lecture and are ready to move on to the next one, where we're going to work just a little bit more with dates. Let's now perform some operations with dates. So one cool thing that we can do with dates is to do calculations with them. For example, we can subtract one date from another date in order to calculate how many days have passed between the two dates. And this works because whenever we attempt to convert a date to a number, then the result is going to be the timestamp in milliseconds. And with these milliseconds, we can then perform calculations. So again, the timestamps are going to be really helpful here in this situation. So let's get this date here. Okay, and let me just demonstrate what I just said. So I will convert to a number this future. So you see, it worked. And the same thing is going to happen when I use the plus operator on it. So you see, and so in fact, that does mean we can now do operations with it. So if we subtract one date from another, the result is going to be a number like this, so a timestamp in milliseconds, and then we can simply convert these milliseconds back to days, or to hours, or to whatever we really want. So let's actually now create a function that takes in two dates, and it's going to return the number of days that pass between these two dates. So days passed is going to be a function, or let's use an arrow function. So a nice one-liner. So date 1 and date 2. And then all we need to do is date 2 minus date 1. And so let's suppose that date 2 is later. But in case we do not want to suppose that, we can simply take the absolute value here. And then it doesn't matter which of the dates here happened first in time. But for now, let's keep it like this so I can show you later what I mean. So for now, let's actually also return this result. And then I will just call this function here. So calc, or actually it's just called, well, it should be called calc. So this looks a bit nicer. So calc days passed. And then let's just create two dates here. So let's use this one here. Maybe make it a little bit simpler. Let's say here, April 14th. So this is the first date, the first that happens in time. And then the second date, let's just say, well, April 24th. So this then makes it easy for us to visualize the result. And let's just call this const days 1 and then log it to the console. All right. And so this gives us these milliseconds. And so now we just need to convert them. And this is similar to what we did, I think, in one of the previous lectures. So we want to divide by 1000. And so this converts milliseconds to seconds. Then that times 60 to convert it to minutes, then times 60 to convert it to hours, and then times 24, which converts it to days. And again, that's because there are 24 hours in a day, there are 60 minutes in 1 hour, 60 seconds in 1 minute, and 1000 milliseconds in 1 second. And so now we get 10 days. And that makes sense, right? So from April 24 to April 14, we have exactly 10 days. Now what if here we pass 4? So now it's going to be the other way around, right? So now we have minus 10, but we don't want that. We always want it to be 4. And so that's what I meant earlier, where we can now simply take the absolute value of this. So math.absolute. Which of the dates we pass in first. So if we now put 4 here and 14 here, then the result is still going to be 10. Great. So this works just really nice. Now, if you need really precise calculations, for example, including time changes due to daylight saving changes and other weird edge cases like that, then you should use a date library like moment.js. And that's a library that's available for free for all JavaScript developers. But for something simple like this, we should be fine. Now let's just consider that one of these days here also has some time. So let's say in this one here, it's also 10 in the morning or 10 hours and 8 minutes. Doesn't really matter. But let's see what happens to the days now. And so indeed, we now get 10.4. So we might not want that. And in this case, we can simply use math.round on all of this. Okay, so keep that in mind. But I will just leave it like this. All right. And now let's actually use this function to format and display our dates in a little bit nicer way here in our application. So basically what I want to do is if one movement happened today, then here instead of the current date, I want to display today. Then if it happened yesterday, I want to write yesterday. And then if it happened like a couple of days ago, then I want this to say like 2 days ago or 5 days ago instead of the date. And I'm sure you have seen this kind of stuff in many web applications that you use in your daily life. For example, if you post something on Facebook and if you then watch it the next day, it will say that you posted it yesterday. It's not going to display the exact date if it was just yesterday. And so that's a really nice use case of using a function like this. So let's grab this here. So I'm copying it. And then let's go to the display movements function where we do actually print the date. Now this is all kind of getting out of hand. So we have a lot of extra code here. And now we will add even more. So this function here and even some more stuff. And so let's take all of this here and actually create a new function which will have the purpose of formatting this. All right. So let's cut this here, as I just said, and create a function up here just to make it a little bit more modular. All right. And then we could also reuse this function in some other place, even though right now, in this case, we don't need it. I'm just doing this to split up the functionality a little bit across different places in our code. Okay, so this one receives a date as an input, and it will return the formatted date then. Okay, so I'm copying all of this, but actually this one should stay back here where we got it from. And then also, so this, we need this variable back here where it came from. So display date, because we use it down here as the value that we eventually want to print to the user interface. And so this one should actually be the result of calling our new function. So this format movement date. So format movement date. And here we pass in the date variable that we just created up here. All right. And so with this, we just exported the functionality here into a new function. So let's grab this and put it here at the top of the scope. And so for now, just to keep this working, let's return then this value. All right. And as you see, and let's just make sure by logging in. So as you see, the dates are now still being correctly printed. So we successfully exported this functionality here of displaying the dates into this function. And now we can just implement what I just said. So basically calculating how many days passed since the current date and between the date that we are working with. All right. So let's say const days passed and between. So between right now, that is new date. And then the second date is the date that we just received here. So let's just print this to the console to see if it works. Okay. So what's all of this here? So we are printing here actually the wrong thing. So we want days passed. So that was a mistake, obviously. But it's still not correct. And okay, I have another mistake. So probably you saw this already. So I did not even call the calc days passed function. But now it should be good. And indeed, now we have our days here. All right. And now let's actually round them. Okay, so that's what I was just saying earlier, so that we should probably round these dates. So we already learned how to do that. So math.round all of this. And so this looks a lot better now. Now let's actually modify our dates here a little bit. And you should do the same. And what I'm going to do is to make one date yesterday, and then also a date like 3 or 4 days ago. So see what's your current date, and then simply subtract 1. So for me, it's August 2nd. So I'm going to use August 1st, and then also July 28th, and maybe another July here, 25, or maybe 26. Okay, it's just so that we can see like the yesterday or 3 days ago or something like that. All right, so do that now. And then let's go back here to our function. And then we want to implement some logic based on this day passed. So if days passed is 0, and so basically that is if we do something today, then actually the string that we want to print is not the current date, but instead today. All right. Then if 1 day has passed, we want to return yesterday. Okay. Next up, if, well, let's say if the number of days passed is within the last week. So that's less or equal 7. And then we will return the number of days. So days passed, days ago, and else. So only if more than 7 days have passed, only then we want to return the actual date. Okay, does that make sense? So let's save and see if it works. And yes, beautiful. So that's yesterday, 5 days ago, 7 days ago, and then here the other dates right here. So that's beautiful, great. Let's now just do something. And actually let's transfer like 500 to Jessica Davis. And that's going to be the other way around. Jessica Davis 500. And so now we should get one log here with today. Yes, indeed, there is today. And now if we log in as Jessica Davis, we should get the same. So now we have a deposit coming from today. And actually, we also have something from 7 days ago. So great. That's amazing if you ask me, that we are capable of now doing something like this, which looks like a real web application that you might use every day. All right. Now, maybe the logic here is a bit confusing with all of these returns, but that's completely normal. So as you know, once we return, the function stops executing. And so these other returns will then never be reached. And so this is a pretty common technique. And actually, we wouldn't even need this else. So if I just remove this here, then all of this code will only be executed if all of these here are not executed. So only if all of these here are false, the rest of the code is even executed. So you see it works the exact same way. Awesome. So our application is even better now. And in the next 2 lectures, we will then do what I mentioned earlier, which is internationalization, which is to basically format these dates and also these numbers here according to each of the countries of these accounts. So JavaScript has a new internationalization API. Now that sounds very fancy, but all it does is to allow us to easily format numbers and strings according to different languages. So with this new API, we can make our application support different languages for users around the world, which is pretty important. For example, currencies or dates are represented in a completely different way in Europe or in the US or in Asia, for example. Now, there is a lot of language-specific things that we can do with the Internationalization API. But in this section, we're just briefly going to talk about formatting dates and numbers. And starting with dates in this video. So in our application, we have dates in 2 places. First right here, and then second here in each of these movements. Now, in case you're wondering why these labels like today or yesterday or 5 days ago are gone here from my application, it's just because I'm recording this video a couple of days later. All right. But anyway, let's go to the place in our code which displays this first date here, so that we can format that according to different languages and see what it looks like. And so that is right here in the login handler function. And in particular, this is the code that we have currently. Remember doing this? But now we will actually be able to get rid of all of this and simply replace it with the Internationalization API. So it will do this kind of formatting for us automatically. But for now, let's actually display this date here outside of the login so that we can experiment a little bit with this API without having to log in all the time. So I will grab the current date. Experimenting with the API. Okay. And then we also need to get just this part where we do then actually display something in the DOM, right? So we want to set this text content property here to something. And we want to set it to a formatted date. And so let's now use the Internationalization API for that. So that's new, and then Intl, and so that's basically the namespace for the Internationalization API. And then for times and dates, we use the .dateTimeFormat function. Okay. Now all that we need to pass into this function here is a so-called local string, and this local is usually the language and then dash the country. So something like this. So English and then dash US, for example. All right. And so all of this here will create a so-called formatter for this language in this country. So English.us. And I will show you a list of many different locales here in a second. But for now, let's get started with this one. So all of this creates a new formatter. And then on that formatter, we can call .format. All right. And then here we actually pass in the date that we want to format. So that's now. And that's actually it. So let's reload here. And you see that now the date is actually formatted just like it is usually formatted in the US, with the month first and then the day. Now English is also spoken in other languages. So let's try the UK now, or Great Britain. So for the UK, we have to use this one. And now you see that it is different. So you have the day first, then the month, and it also has this leading 0 here. And so you see that now it is actually formatting this date for this exact locale that we specified here. And so just with this one line of code, we have correctly formatted the date for any user around the world. And let's try some other countries here as well. For example, we could try Arabic for Syria. So that would look like this. So in these symbols that I cannot really understand, but what matters is that it is indeed formatted correctly. Let's just put it back here. All right. And to get these different codes, let's just Google ISO language code table. And then the one that's easiest to understand is this one here. So go to the one that has lingos.net. And then from there, you can find your own code and then experiment with that and see if it's also correct. All right. Now, this is the most straightforward way of formatting dates and times, but we can actually take it to the next level and add some options to also customize this a little bit. For example, you see that right now, it only displays the date here, but not any time, right? And so we can change that by providing an options object to this function here. So let's define that options object outside here. And I'm simply calling it options. And so all we have to do is to specify the hours property, or hour, and set it to numeric. And the same for the minute, set it to numeric as well. And now we have to then provide this object here as a second argument into the date time format function. So options. And of course, we could have written this object right here, but I will add some more stuff to it in a second. And then this line of code here becomes a little bit messy. So it's quite usual to have a configuration object like this one here defined outside. So, as you see, now we get indeed the time. But on the other hand, now the date is gone. So let's get that back as well. And here we can specify properties for each of weekday, year, month, and day. So let's start with the day, and I will set it to numeric as well. So let's see what happens then. And so now we only get the day. Let's add the month as well. Numeric again. And so now we get the month here as 8. Okay, and that's because we specified it as numeric. But for month, we can also write long. So let's see what happens then. And so now we get August, and so not just the number. And for the month, there is even another option, which is 2-digit. And so then it would be 08. But let's leave it at long. And now the year as well. Let's set it to numeric, and of course in quotes. All right, so that's 2020, but we could also say just 2-digit, and so then it would be 20. But again, let's leave it as numeric. And finally, we can even specify the weekday. And here I'm using long again, and so then it will write out the day completely. So Wednesday, August 12, 2020, and all of this nicely formatted, just like people in the US do it. All right. Now here we can also say short or narrow, and you can experiment with that. So let's see what it would look like in the UK. So that's pretty similar. But now let's see, for example, Portugal. So PT-PT. And so now you will see this here, of course, written all in Portuguese. And the same, of course, for other locales, so for other languages. Now, in many situations, it actually makes more sense to not define the locale manually, but instead to simply get it from the user's browser. And so that's pretty easy to do as well. So let's define another variable here outside. So locale, and then that's simply navigator dot language. So let's log it here to the console first. So you see that mine here is set to English, Great Britain. And so if I replace this here now, then you will see that it will go back here to displaying it in English. All right. And so if you do this yourself now, then your date should be displayed to whatever language you have in your browser. Anyway, let's now take this and actually put it here into our login. So replacing all of this, I will just comment it out to leave it here. And now we have a duplicate here. Let's get rid of that. So now the date will only get formatted when the user actually logs in. All right. But now let's take a look at our account objects here. And so you see that now in each of the accounts, I defined a locale, right? So account 1 is Portuguese and the other one is in English. And so let's now actually use these locales to display Jonas's date here in the Portuguese format and Jessica's date in the American format. Okay, so that's easy enough. We just have to find the correct place in our code. So yeah, that's right here. And remember that we have the account in the current account variable. And so here, instead of using this locale that's coming from the browser, so instead of using this, we use current account.locale. So let's give it a save. And now I will log in as Jonas. And remember, that should now display in the Portuguese format. And indeed, it does. Now the problem here is that our entire user interface is in English, but now I have this weekday here in Portuguese and also this month name. So to fix that, let's actually set the month here back to numeric and also get entirely rid of the weekday. So let's try that again. So we got rid of the Portuguese words here, but the formatting still follows the official Portuguese way. Now let's check out Jessica Davis. And so you see it looks different now. It is now in the American format with the month first and then also with the AM time down here. And of course you can set one of these accounts to your own language to see how it would look like in your language to make it a little bit more personalized for yourself. Great. So with this, we have localized this date here. Now we need to do the same with the dates down here in the movements. So let's go to that function which formats these dates. Remember, we created a function for that up here. So that is format movement date. Okay. Again, let's now do this formatting here also for these movements. And so what we're going to do is to replace all of this here with a new nicely formatted date. So instead of returning all of this here like we did before, we will simply return new, and then again the intl namespace, date time format, and then here we need the locale, and so let's actually pass that into the function. All right, so this function right now only receives a date, but we also now need a locale. So let's add that here as a second parameter. And now wherever we call this function, and that is down here, so here we now need to pass in that locale, of course. And so that comes from the account.locale. So the current account in here is called ACC, remember? And so that locale is at acc.locale. All right. So return new date format, and then simply the locale that we receive here, and then format the date. And so that's again the date that we receive as an input here. Okay, and that's it. And in this case, we don't want any options object because here we don't need the hours or the minutes. All we want is to simply display the date as simple as possible. And in that case, we don't even need any options. So let's give it a save here. Try it now with Jessica Davis. And you see that indeed, now it is the American format with the month first like this. Let's just transfer some money here to Jonas. And so of course here our today still works. So these kind of easier to read and understand labels that I showed you earlier. So that is the American format. And now let's again see Jonas format, which should now change to the Portuguese one. And indeed, it did. And so this part is now working as well. Great. So in a nutshell, this is how we localize dates in JavaScript using the new Internationalization API. And as always, feel free to read the documentation on MDN. So that's just MDN Intl. And so here you're going to find all kinds of different functions. So I mentioned in the beginning that there's all kinds of stuff we can do with this API. So besides dates, so we can also format lists or like words and their plurals. All right. But if you want to learn about this one a little bit better that we just used, you can go ahead and read the documentation right here. In the next video, we will use this number format function here to format all the remaining numbers that we have in our application. So let's move on and do that now. So in the last video, we formatted dates using the Internationalization API. So now let's actually format regular numbers. And let's start by doing some experiments in the console first before we move on to our application. So I'm just defining some number here. It doesn't really matter which one, just so we can experiment with it a little bit. Okay, so let's do the most basic formatting now, simply doing new, and then again, this intl namespace. And now this time we use number format. And so this again takes in a local string. And so let's experiment with the US. Okay. And so all of this here creates a formatter. And then one more time on that, we can call the format method, where we then pass in what we actually want to format. And so that is this number. Let's just also log here to the console that this is about the US, so that we can then have some other locales as well. Okay, so you see that the number is now formatted using these dividers here. So these commas here as separators, so that it's easier to read 3,884,000 and so on. But let's see how it works in other countries. So in Germany, for example, it is different. Let's add some spaces here. Okay. And so here we want like this. And since we're doing this, let's try some other countries here as well. Let's just say Syria. Why not? So the one that I used earlier as well. So that is Arabic, and then the country is SY. And you see that in Germany, as in general in Europe, the separator is the dot, and then a comma for the decimal part. So basically just the opposite as it is in the US, as you see here. And then for Syria, well, it's even more different. I cannot even read this, of course. And of course, we can also just use the locale from the browser. So that would be navigator.language. And actually, let's log that here. And so, yeah, in the UK, it's basically the same as in the US. So again, this is just the most basic formatting, but let's now define an object here. So again, options for this formatting. But of course, now we have other properties in this object. It's no longer day or month or something like this, but instead we can specify the style, for example. And here we can say that this is a unit, and then we can set the unit property to something. And let's say mile per hour. And there are tons of units like this. And so as always, you can read more about the units that are available in the documentation. But let's see what happens now. No, but apparently nothing happens. Now we just need to pass in this options here, of course, into the number format function. So again, as a second argument, and let's do that here in all of the 4 at the same time, using these multiple cursors. And let's give it a save. And indeed, now we get this unit here. And one more time, you see that it's written differently in the US or in Germany, for example, or in Europe in general. And you see in Syria or in Arabic, apparently this is how you write miles per hour. Okay. But of course, we can try others. For example, for temperatures, there is Celsius. And so indeed, we get degrees Celsius. So that is for units, but we can also say percent, and then the unit is completely ignored. So we get the percentage sign, and again, it is different in different countries. So here we have this space. And then there's also currency. So these are the 3 different options for the style. So that's unit, percent, or currency. And again, if we have a currency, then the unit is just completely ignored. But we do have to then define the currency. So let's say euro, and for that, it is like this. So EUR. And so if we give it a save, then we get indeed the euro sign. And so here in Europe, it comes after the number, and in the US it comes before the number. And it's important to understand that we do indeed have to set this currency here, because the currency is not determined by the locale. Okay, so it's not defined by the country here, because it's of course possible to show, for example, euros in the US. All right, and so of course we have to define the currency here manually. So it's not going to be implied from the locale string. Okay. Finally, we can also turn off or on the grouping. So let's use grouping and let's experiment with false. And then you see that the number is just printed as it is without the separators, so the grouping. But let's get rid of this one here. And again, if you're interested in even more properties that you can set here in the options, then just check out the documentation here on MDN. Okay, but now what we're going to do is to actually use this knowledge and implement currencies here in our application. So let's move up here, and I'm going to start here in the movements. So where is that function? Now you see we have a lot of code here already, and in the real world we then split up all this code into different files. Okay, because as it is right now, it is indeed a little bit messy, but for now it is just okay as we have it. Now, anyway, right now we are displaying the currency here in these movements right here. So we convert everything to 2 decimal places, and then we display the euro sign here ourselves. But now we want the Internationalization API to take care of all of this. So let's create a variable out here so that we don't have to do all that formatting here in the template literal. So we do it outside here. So let's call it formatted movement. And then again, we use new and then number format. And now you already know that we have the locale right in the account object. And so that's again ACC, right? So just as we did here for formatting the date, we use acc.locale. And then we also need an options object. And this time, let's actually write that object right here. So we need to set the style to currency. And then we need to define the currency property. So just as we did earlier in this video. And let's just experiment a little bit here. Let's say that we want US dollars instead of euros. Okay. And so now here we can get rid of all of this, including the euro sign, and now simply use this value. So formatted movement. Okay, give it a save. And now we need to, of course, log in here. But before doing that, I see already that we have some problem here with is this object. And the problem is that we here didn't even call the format method. So all we did was to define this variable here as number format. And so that's then this formatter, remember. But on that, we then need to actually call the format method. And so this is where we pass in the value that should be formatted. And that is simply the current movement. So this mov value here. So if I save it now, then that should be fixed. And indeed, you already see US dollars right here. But anyway, let's log in as Jonas now. And yeah, everything is US dollars. However, the number itself here is of course still formatted in the Portuguese way. So that's the current locale of the current user. Remember? So that's Jonas, and the locale is PT. Remember? And so therefore, the number is still formatted in that way and not in an American way. That's only for the currency. Okay, so that's USD, but the rest is still according to the user's locale. So that's what I said earlier, that the currency is completely independent from the locale itself. So in this case, we have a European country with an American currency. All right. Now, indeed, we also have the currency in the accounts object. So we have the locale and also the currency. And so let's now get that currency also from the account itself. So that's right here. And so here we actually want account.currency. So if I load it now, then indeed we get euros. All right. And if I log in as Jessica Davis, which has USD as the currency, then we get the dollars, and we get it also formatted in the American way. Because for Jessica Davis, the locale is also, it is English in the US. And so this is what it looks like here, formatted for the US with US dollars. Of course, we could change this to euros, and then, of course, now we would have the euro sign. All right. So one more time, you can see how powerful this is and how easy it makes formatting for us developers. Okay. Now, anyway, that is the movements, but now we also have the currency in a lot of other places. For example, here in the balance, and then also down here in these statistics. So let's start to also implement the same formatting here in the balance. And so that is, that's right here. Okay, so here we also have this old way, basically, of formatting, but we know that we can do better. So we can now go ahead and grab all of this like this and paste it here and then use this. Okay. However, as you can guess, that is not a good practice because we are repeating the don't repeat yourself principle. Right? So let's get rid of this. And as you can guess, we will create a new function here, which will take care of formatting the currencies. So let's call it format cur, which stands for currency. So a new function. And let's create a very reusable function here. So instead of passing a whole account object into this function, which is very specific, of course, to this exact application, let's do a function that you could use in any other application. So basically a function that is less dependent on the underlying application data. Okay, and so instead, what we will do is to simply pass in all the data that this function needs to work with. So that's the value, the locale, and the currency. Okay, so again, we could pass the entire account object here instead of these two, but here we just want to do a reusable function. And so this is a lot better for that. All right, so this is the code that we had written earlier. And here we don't even need to create a new variable. All we will do is to return the result of this number format function. Now we just need to adapt this a little bit. So here it's just the locale that we get in here as an argument. And then here the same for the currency. And what we want to format is the value that we get in. All right. So again, a nice and simple reusable function that can take any value, any locale, and any currency, and will then return this value here nicely formatted for that locale and currency. So let's use that here. So of course, instead of what we had before, formatted mov will now become format the currency, and then the value is mov, the locale, which I think is the second one. Yeah, it is. So it's very handy, again, here in VS Code to just hover over the function name. So the locale is at account.locale and the currency at account.currency. And so we can get rid of this. Now I will just copy this part here. And so now what we want to format is account.balance. Okay. And we actually don't even have to store it into a separate variable first. We can just take this result directly and then display it as a text content here in our application. So if I log in now as Jonas, then this should already be nicely formatted, and indeed it is. So we see we have this nice separator here, which makes our number easier to read. And now as Jessica Davis, it should be the American separator, so with the comma here. Okay, so that's great. All that's left now is these three values down here. All right, but that should be easy enough with the function that we already created. So let's just copy it here. And then we simply basically need to paste it here to these three places. So here it is the incomes that we want to format, right? So incomes. Then here it is this part here. So the absolute value of the out. And then finally down here, it is the interest. Now I copied that code from earlier. So again, it is this interest that we want to format now. So interest. And indeed, you can already see, even without logging in, that it worked down here. So we have this nice separator here indeed. And so if we log in again with Jessica Davis to see it as US dollars, then we get this nice result here as well. Beautiful. And actually, that's it for the internationalization API. That's all I had to show you. But as I told you right in the beginning, there is a lot more potential in this API. To finish this section, let's quickly talk about timers in JavaScript. And we have two kinds of timers. First, the setTimeout timer runs just once after a defined time, while the setInterval timer keeps running basically forever until we stop it. So basically, we can use setTimeout to execute some code at some point in the future. So let's use this to simulate ordering a pizza. So when we order a pizza, it doesn't arrive right away, right? So instead, it's going to take some time, and we can simulate that. So let's write setTimeout, and then this function receives a callback function. So just like some array methods or DOM event handlers, right? And we already talked a lot about this. And I think we even used the setTimeout function here as an example of callback functions a bit earlier, right? So let's use an arrow function this time, actually. Because why not? And so here, let's just say, here is your pizza. And then just some pizza emoji here, maybe. All right. So this callback function here is the first argument of the setTimeout function. And so again, we do not call this function ourselves. We simply pass in this function as an argument to setTimeout. And it is this function who will then call our callback function in the future. And when does that future arrive? Well, that's what we specify here in the second argument. So here we pass in the amount of milliseconds that will pass until this function is called. So let's say we want to call this function after 3 seconds, and so we need to pass 3000. So 1 second is 1000 milliseconds, and so this is basically 3 times 1000. Okay, so let's give it a save, and you see the page reloaded. And now, after 3 seconds have passed, we get this log to the console. Okay, and so with this, we really delayed calling this function here, right, by exactly 3 seconds. And we can also say that we schedule this function call for 3 seconds later. All right. Now, what's really important to realize here is that the code execution does not stop here at this point. All right. So when the execution of our code reaches this point, it will simply call the setTimeout function. It will then essentially register this callback function here to be called later, and then the code execution simply continues. And we can prove that by doing something after the setTimeout. So let's say waiting. And if we now save this, then immediately we will see this waiting in the console. So let's check that. And indeed, we get waiting. And then after the 3 seconds, then this log here appeared. All right, so this is really important to understand. So again, as soon as JavaScript hits this line of code here, it will simply basically keep counting the time in the background and register this callback function to be called after that time has elapsed. And then immediately JavaScript will move on to the next line, which is this one. All right. And this mechanism is called asynchronous JavaScript. And we will talk about how exactly all of this works behind the scenes in a special section just about asynchronous JavaScript. Okay, but anyway, what if we now needed to pass some arguments into this function here? It's not that simple, right? Because we are not calling this function ourselves. So we are not using the parentheses like this, and so therefore we cannot pass in any arguments into the function. Right? Now, however, the setTimeout function here actually has a solution for that. And it works like this. So basically all the arguments here that we pass after the delay will be arguments to the function. So let me demonstrate that to you. So let's say here olives, and then another argument, spinach. And so here I can now specify the ingredients. So olives and spinach will be ingredients in our pizza. So let's say ingredient 1 and ingredient 2. And here we can then use them somehow. Let's make this a template literal. Let's give it a save here. And so the waiting once again appeared immediately. And then after 3 seconds, our string appeared logged to the console. And indeed, this third argument that we passed in did now become the first argument or the first parameter of our function here. And then the fourth argument became this second one. And if we passed in even more, we could then get access to them here in this callback function. All right. And that is essentially how the setTimeout function here works. There's just one more detail that I want to show you, which is the fact that we can actually cancel the timer at least until the delay has actually passed. So before these 3 seconds here have passed, we can cancel the timeout. And so let me show you how. Now to build this example, I first want to change something here. So I want to put the ingredients into an array. So let's say, again, olives and spinach. And so how would we then pass in these ingredients here? We're not going to do ingredients 0 and ingredients 1 like this, right? No, instead we will spread the array here using the spread operator. And so this will then take the elements out of the array and put them here basically comma separated. And so this now works exactly the same. But now what I want to do here is to say that if the ingredients include spinach, because that's something that many people don't like, so if the ingredients include spinach, then clear timeout. And so now here we need to pass in the name of the timer. And so we can basically assign this timer to a variable. So let's say simply, let's say pizza timer. And so here we can then use that variable, so that timer, to clear it. All right. So again, here we basically stored the result of the setTimeout function, which is essentially the timer. And then we can use that variable to clear the timeout. And then we can use that variable to basically delete the timer. And for that, we use clear timeout. And so now, since this array contains this spinach here, now you will not see the pizza string here printed to the console. All right. But if it did not include spinach, then of course, it would still work after 3 seconds. All right. So this is how the setTimeout function works. And that's actually it. That's all you need to know about the setTimeout function. It's pretty straightforward, right? So let's now actually go back to our application and implement a timer to simulate the approval of our loan. Okay. So when we click this button here to request a loan, then we get the value immediately right now. But typically a bank takes some time, like some days or some weeks, to approve that loan. And so let's simulate that here by taking like 2 or 3 seconds. So what happens when we successfully request a loan is essentially this code here, right? And so let's simply wrap all this code into a function. So curly braces, then function just like this, and then put all of this into a setTimeout. And then down here, give it a save, and then it should be nicely formatted. Okay, and now let's say, well, after 2.5 seconds. Okay, and so let's just see what it looks like in practice. So requesting a loan of 1,000. And so now it's going to take 2.5 seconds. And indeed, the bank just approved my loan here. So that was 10,000. Let's do something else. So count the seconds here. And now my loan was approved. And so then it appeared here in the movements, and it also appeared here in the balance. You saw that? So that makes our application a little bit more realistic. But let's go back now, because we also need to talk about setInterval. So we learned that setTimeout here simply schedules a function to run after a certain amount of time. But the callback function is only executed once. Now, what if we wanted to run a function over and over again, like every 5 seconds or every 10 minutes? Well, for that, we have the setTimeout function. So this one is going to be setTimeout. So let's use the setTimeout function to basically create a clock that will display in our console. So setTimeout, and then a function. And of course, I could have used an arrow function, but it doesn't really matter here. So our callback function, and let's create a new date here. So let's say now and then new date. Okay, so this is nothing new at this point. And then let's just log that date, so that current date, to the console. And we want to execute this every 1 second. And so here we say 1 second. So let's see what happens. And indeed, once every second now, this should be executed. But it doesn't. And that's because I made the mistake of calling setTimeout again. But of course, as I was saying all the time, this one is actually called setInterval. So maybe you were already spotting this mistake, but now let's see what happens. So now, after each second here, we get the current time displayed to the console. So what's happening here is that this callback function is now executing every second. Okay? So every second a new date is created here and is then logged to the console. And of course, we could also say every 3 seconds. And then we would get the current time on the console every 3 seconds. You see? So it's adding 3 seconds each time now. But 1 second here makes a little bit more sense. Now, of course, you could print a real clock using this function now. Like you could get the current hour, minutes, and seconds from this now date. And so I would challenge you to do that actually, to take a minute or two in order to build like a real clock that is only logging the hours, minutes, and seconds here to the console. Now, I'm not going to do that here, but I think this would be a nice challenge to train a little bit the stuff that we've been using previously in the section. But for now, this is actually enough for this video. So take this challenge that I just mentioned, and then I'll see you soon in the next video. Welcome back. And this is going to be the last part of this project. So we're almost done here. Now, for security reasons, real bank applications will log out users after some inactive time. For example, after 5 minutes without doing anything. And that's what we will implement in this video using the setInterval timer. And let's start with one final look at our flowchart. So the timer appears in multiple places here, and the first one is right here. So whenever the user logs in, the logout timer will start or restart. All right. And then as soon as the logout timer expires, which will be after like 5 or 10 minutes, then we want to log the user out. All right. So basically that's what we will do with the timer, but let's start very simple. So the place where we want the timer is here in this function about the login. Okay, so this here is the handler function that handles the login. And so our timer will start here. Now we already have plenty of code here, as you see, right? And therefore, let's actually create a separate function which will start this logout timer. All right. So let's say start logout timer. And this function doesn't need any arguments. All it does is to basically export some functionality into an external function. So let's write some pseudocode here, basically by writing some comments to say what exactly we are going to do here. So we will start by setting the time to, let's say, 5 minutes. Okay. Then we want to call the timer every second. Then in each call, so in each callback call, print the remaining time to the user interface. And then when the time is at 0, so after the timer basically expired, so when we reach 0 seconds, stop timer and log out user. Okay, and to make this a bit easier to visualize, let's go again here to our demo application. And so the timer that I mean is this one here, which actually starts at 10 minutes. And you see that after each second, a new time is basically printed here. All right. And I'm not going to wait for 10 minutes now, but when this reaches 0, then the user will, of course, be logged out. Okay. So let's basically do everything that we described here. So I'm setting the time for now just to 10 seconds. Okay, just so we see what's going on. Or actually, let's say 100 seconds, so that we have actually more than 1 minute. Then we want to call the timer every second. So basically what this means is to use the setInterval function and then pass in a callback function, and this callback will be executed every second. And so 1000 milliseconds here. All right. Then each time that this function is called, print the remaining time to the user interface. And then this one here as well. So when we're at 0 seconds, stop the timer and log the user out. So we want to print the time here to this label, which is called label timer. So let me just show it to you here in our elements that I pre-selected. So label timer is the element with the selector of simply timer. Okay. So let's go. So label timer dot text content is equal to the time. And so that's this here. So I forgot to write the name of the variable actually. And now to make this actually work, we also need to remove 1 second in each of these function calls, right? So decrease 1 second. And so time equal time minus 1, which is essentially the same as saying time minus minus. All right. So this is the logic of this timer. We start with a certain number of seconds. Right now that's 100. And then each time that this callback function here is called, we remove 1 second from that. Okay. And so this is called every second. And so basically we will end up with a timer which shows the current number of seconds each second. Okay. And now all we need to do is to then call this function here on login. So, well, let's do that here before updating the UI. So start logout timer. And now let's quickly log in here. And indeed, you see this number here decreasing now. Okay, so hopefully that that logic makes sense of decreasing 1 second every second. Now, where is that? We have too many functions here, I guess. Now, here we go. So again, the logic here is to decrease the timer by 1 second every second. And so therefore, we get this number here going down by exactly 1 each second. All right. Now, we don't really want to see only the seconds. We want to see the minutes as well. So basically, we need to convert this simple number of seconds to minutes and seconds. All right. So let's do that here as well. So let's say the minutes is the current time divided by 60. So that's the easiest way, basically, of writing it. So it's not going to be correct, but it's going to show us what we need to do next. Now here we're also seeing already what happens with this timer after a certain number of seconds. So indeed, as soon as the time hits 0, it will not simply stop, right? We're not telling the timer anywhere to stop. And so it will simply continue and become negative. And so that's what we will have to implement then down here. But let's leave that for later. For now, we just want to display the number here in minutes and seconds. But for now, I will just show you the minutes, just to show you what we need to do next. So you see that we have 1 minute, 0.6 or 0.5 something. So it's decreasing every second, but this number here after the comma or after this period doesn't really make sense, right? So basically what we want to do is to take whatever remains of dividing the time by 60, because that will be our seconds. So let me show that to you as well. So seconds will be the remainder of dividing time by 60. And so that's where, again, the reminder function is very helpful. So the reminder operator, actually. So let's now print both of them here as a template literal. So minutes, and then colon the second. Okay, and this is still far from being complete, but let's take it step by step here. So you see that this number here is now decreasing very nicely. And it started at 1 minute and 40 seconds. And that's exactly what 40 seconds is, right? So let's do this again, actually. And notice down there how it starts exactly at 1:40. So you saw that? And that 40 appeared because that is the reminder of dividing 100 by 60. So let's see it here in the console. So when we divide 100 by 60, then this is the result. But if we do 100, the remainder, then we get 40. All right? And that's because 1 times 60 plus 40 is then again 100. All right? Now here we actually do not want then this value after the comma, right? We are only interested in basically the integer. And so let's cut off that decimal part by saying math.trunc, all of this here. And then we also want to pad this number here with a 0. So for example, right now we are at 8 seconds or -8, but we want to see 0.8, just like in a normal clock. Okay, and for that we can again use the pad function. So let's convert this here to a string so that we can then call pad start, which should have the length of 2, and pad it with 0, or just the number is okay. And then the same here. And so now we should get a nice looking clock already. Let's actually start at 120 seconds, which is exactly 2 minutes. So you see now it's a nicely looking and nicely working clock, basically. So a countdown timer that starts counting from 120 seconds, which is exactly 2 minutes. And so that's why in the beginning the seconds is 0, because the reminder of doing 120 by 60 is 0, because 2 times 60 is exactly 120. Right? So 2 times 60 is 120, and therefore there is no reminder. So there are no seconds in our case. Okay? But let's now do it with only 10 seconds, because then we get that negative, and we can then work with that. So what we want to do here is as soon as we reach 0 seconds, we want to stop the timer and log out the user. So if the time is 0, then we need to stop the timer. And we do that by using clear interval. So remember in the last video, we used clear timeout to stop the setTimeout function. And now we can use clear interval to do the same with the setInterval timer. All right. Now, in order to make this work, remember, we need to give a name to this timer. So let's simply call it timer. And then here we can use that variable to indeed stop that timer. And then we want to log out the user, which basically means setting the opacity of this whole container here back to 0. So here in our login, we did the opposite. So we set the opacity to 100. And now logging out the user basically means setting it back to 0. And here this text content should also be set to something else, so not the name of the current user. So let's copy that. And so here the welcome label should say login to get started, which is basically also the default that we see right now, right? And then the opacity back to 0. And remember that usually when we first see the application, all of this is actually invisible. And let's do that here, actually. So get rid of this fake always logged in. So we did that before to test our code, but now it's no longer necessary. And so this is how the application is supposed to look like in the beginning. So we logged in, and now our timer down here is running. And so let's just see what happens once it reaches 0. And indeed, we got logged out here. Okay, so that works beautifully. But let me log in again here so I can show you something that happens and that we need to fix. So as I log in, it takes quite some time until something happens here. Maybe you didn't catch that, so let me try it again after we get logged out here. So I will scroll down immediately and then I hit enter. So you see, before it was still at 1 second. So it was the value that we had before. And that happened because this entire function here is only first executed after 1 second, right? So this callback function that we passed into setInterval is not called immediately. It will only get called the first time after 1 second. But in fact, we want to call this function also immediately, all right? And so the trick to doing that is to export this into a separate function, then call it immediately, and then also start calling it every second using the setInterval function. So let me just show it to you. So I cut the function here. Let's put it here. So we need to give it a name. I'm calling it tick because that's a pretty common name. And now I put it here. And so right now everything is exactly the same as before. But what I wanted to do is to also call this immediately. And so this is how we do it. And so now right away this function gets called, and then after that every 1 second. And so let's try it now again. Let me scroll down here. And you see, this time we didn't have that problem. Now it's simply not counting down, but that's because I did this small mistake here, which you see is very common in development. You will do this also all the time. And well, now we didn't see at the beginning of the timer, but believe me, now it's actually working correctly. However, you might have noticed that we still have a problem, which is the fact that actually we get logged out once this hits 1 second. And so watch closely now what happens when we reach 1. You saw that? And so that's not what we want to happen. This should only happen at 0 seconds, not at 1 second. And the problem here is that we decrease this time by 1 second before checking for 0. So basically the problem here is that in the iteration here, so in the call where the time is 1, right? So here it's going to be 1, and then we decrease to 0, and then we check for 0. And so in this iteration where the time is initially 1, this part of the code still gets executed. And again, because we increase that 1 second to 0 here before this. And so we need to put it after, of course. And so now this part of the code here only gets triggered if the time really is 0 here in this whole function. So now you will see that the logout will only really happen after exactly 10 seconds. So you saw it reached 0, 0, and then we got logged out. Great. So let's increase this here a little bit. And then I will log in as this user. So you see that it's running. And now I will also log in as Jessica Davis, just to see you yet another problem that we have. So you see, it's weirdly alternating between these two numbers. And the reason for that is that right now we have basically 2 timers running at the same time. So 1 timer of Jonas and 1 timer of Jessica. And so that's not at all what we need, right? That's a big problem right now. So how can we fix this problem? Well, basically what we can do is that whenever we log a user in, we check if there is already a timer running, and if so, then we stop that timer. So I believe that is the best solution to this problem. And so what I'm going to do now is to return the timer from this function so that we can then use it here in this callback function of the login and delete it in case that it exists. So let me write that code actually, and then it's going to become a lot easier to understand. So here we will return the timer. And that's important because to clear the timer, so to use the clear interval function, we need the timer variable. And so therefore I'm returning it here. So let's then save it here. So that's down here. And so this is going to be the timer. Now we actually need this as a global variable. So let me put that outside here. So the current account and the timer. And the reason for that is that we need this variable to persist between different logins. So otherwise, after this handler function here would be ready, then the timer variable would disappear. So that's the reason why we have current account out here, and it's also the reason why we need to keep the timer out here. That's the only way in which we can then actually check if it appears. So timer and current account both need to be in the parent scope of this function scope. So let me show you what I mean. So here I will then set the timer to the timer that is returned here. However, if there already is a timer, I first need to clear it. And so let's do that. So if there is already a timer, then clear interval timer. And that's it. So let's think what happens when I log in first as Jonas. So when I log in now, there's going to be no timer, right? So in this situation, there was no timer already, was it? There wasn't, because I just logged out for the first time, and so no timer variable was created. But now, since I did log in, now timer is equal to that timer that I just exported from this function using the return keyword. And so this timer now does exist. And so when I now log in as someone else, so Jessica Davis, for example, then when the code reaches this line here, then a timer will indeed exist. And so then that timer is going to be cleared. Okay. And so now there is no problem anymore. Okay, so now it's running smoothly without any problem. And that, of course, also works when the timer here has a higher value. Let's put it back to 2 minutes. So I can now log in. The timer starts running normally. And when I log in then as Jessica, then the timer gets cleared and resetted basically, and it started again from 2 minutes. Okay. So all this might seem a little bit complicated, I know, but it's all kind of a matter of thinking about what we want our code to do. So all we're doing here is to use all the tools that we already know to basically achieve one goal that we want to achieve, which is in this case, this timer here running and being resetted each time that another user logs in. Now, another functionality that we want our timers to have is to basically reset once we do something in the account. Because remember, the goal of this timer here is to track the inactivity of the user. So the time where the user doesn't do anything. But if I do something, let's say transfer money, then we should not get logged out. It should be resetted. But as you saw, we still got logged out even after doing that transfer, of course. So what we need to do now is to also reset the timer whenever the user does a transfer or requests a loan. So these are the only two activities that exist in our application. And so these operations should always trigger the timer to be reset. Okay? So let's go here to the transfer. And let's do it here at the end. Reset the timer. So what does resetting the timer actually mean? Well, all we need to do is to basically clear interval using the timer that we already have and then start it again. So clear interval and then the timer variable. And so now one more time, it is important that this timer variable is actually a global variable. So a variable that's outside of any of these handler functions. So we define timer, remember, out here, because we didn't want it to be inside of this handler function here. And that was because we wanted this variable to persist throughout multiple logins. But now it's also important because we need it later for other operations. So inside other callback functions. And in particular in this one now. So clear interval of that timer that was defined previously, and then we simply start a new one. So basically we then overwrite that initial timer that we had before. So start, logout timer, and that's actually it. So imagine that the timer was at 1 minute 30 seconds. So when we do a transfer, that timer is cleared and a new timer is started again at 2 minutes. Okay, and now finally the same for requesting a loan. So let's try that. And now the timer is running down here. All right, and now let's try to transfer something to JD, so the other user, let's say 100. And watch what happens down here to the timer now. And indeed, it got resetted to 2 minutes. At the same, when we request a loan, let's say 100, and then after the 3 seconds have passed, then our loan got approved indeed, and our timer reset to 2 minutes. Beautiful. Great. So our application is now actually finished and feature complete. Everything is working just as in our demonstration, and I think this was a great application to teach you really a lot of different stuff in JavaScript. So huge congratulations for finishing this great application. It's good to see that you made it to this point with me, and I hope that you're really proud of this application that you just built. You can now show it to all your friends and everyone that you're telling about your coding journey, and I'm sure they will be just as happy as you are about this amazing progress. So once more, great job and well done. And with that being said, I hope to see you soon in the next section where we're going to build together some features of a real website. So UI components that you find commonly in normal websites, such as sliders or pop-up windows. So that's going to be really exciting. So I hope to see you there soon.